Hi, welcome back. In today's video, we would like to write a program to check the validity of passwords input by users. So we would like to have these rules to see if a password that the user entered is valid or not. So first of all, it should be at least 8 characters long. So whatever that is going to the user enter, that is going uh, to be entered by the user that is less than 8 characters long, it is going to be rejected as a valid password. Then we would have to have one lowercase letter, at least one uppercase letter, at least one digit, and also at least having one specific characters, something like this. Okay. So you see that this is a very practical example that we see in many places that you want to create a profile for yourself. You need to have specific number of characters and some criteria to meet in order to have your password validated. So here I'm going to code that. So first of all, I'm having a function called isValidPassword, okay? So here, this function that is called isValidPassword is initialized and created using the def keyword, and we are having one argument. And whenever we call this function, we are passing the password. Okay. Then when we enter this function, the first thing that we need to do is to check the length of the password. Using the length function, we can understand the user input is how long, how many characters are included. If the number of characters or the length of the enter password by the user is less than 8, we are going to have this message being shown to the user. Password must be at least 8 characters long. So we are going to check the first criteria using this part of the code. Okay. Then we need to check if it has at least one lowercase, at least one uppercase letter, at least a digit, and have a specific character or not. And these are the characters that we are defining as specific characters. For example, and pound, dollar sign, etc. until the end. This is our defined special characters, and the password must also include one of them. Okay, special characters. So all of them are assigned to false. Initially, we mentioned that, okay, we are initializing these Boolean flags for different character types, and we are assigning them to be false. And we're going to check the entered password by the user. If they are meeting these criteria, we are going to assign true to them. So now we would like to check these characters. First of all, we check each character in the password. So for each character that is in the password that the user entered, we're going to check if that one character is having a lowercase. If this happens, we are going to mention, okay, it assigned true to has lower Boolean variable. It was initialized to be false. But now that we see that the entered password by the user has one lowercase, we are going to assign true to it. And we check also to see if there is at least one character that is uppercase. If this is true, we are going to assign true to has upper, which was initialized to be false. Then we are going to have the is digit, and also for this character we see if at least there is one character that is a digit. If so, we are going to assign true, and also we are going to have here another for loop, so saying that, okay, for each character that is in password, if that character is inside this, okay, if it equals to any of these signs. If so, assign true to has special, Boolean flag variable, and this part is just for checking the character in the password. And then in order to validate all the conditions, we are going to have an if not condition here. So for example, we mentioned that if we don't have the lowercase, meaning that, for example, if the has lower variable after this for loop is still equal to false, it means that the password that the user entered is not having at least one lowercase character. Therefore, we are going to return this message. Also, we are checking to see if has upper is still false. We are going to show this message. You need to have at least one uppercase letter. If there is no digit, we are going to show this message. If there is no special character, there is going to be this message. And finally, we're going to say, okay, password is valid if all of these criteria has been met. Okay. So let me run the code once and we're going to analyze the code one more time. So initially, we're going to ask the user to enter a password. We're going to assign it to the variable called password. And using the print function, we are calling the isValid password function and passing the argument password. Okay, so password is the argument for the isValid password function. We are passing the password as the argument of isValid password, and all of this is inside a print function because the output of this function, whenever it is called, the output of this function must be printed. This is why we are having the print in the output. So when I run the code, it says enter a password. I would say, for example, Reza for the moment. It says password must be at least 8 character long. So my password is not validated. Why? Because it checks to see if the first condition is this. Is it having 8 characters at least? No, it's not. Therefore, it is saying that it must be at least 8 characters. So I would say now Reza Shahin. Now it at least has 8 characters. I enter. It says password must contain at least one lowercase letter. So here is the message. Okay. Password must contain at least one lowercase letter. This is exactly where the output what the output is showing here. Why? Because the has lower boolean variable is initialized to be false, and now here I am going through all the characters of the password. For example, I'm going through R, then E, then Z, then A, etc. until the end, and check if any of them is in lowercase. If so, we're going to assign true to has lower. But this message is only shown when this has lower boolean variable is not assigned to be true. It is assigned to be false still. So in this for loop, we couldn't find any character that is uppercase, therefore that is lowercase, sorry. Therefore true has never been assigned to the has lower variable, and therefore we are having this condition being true, so has lower is false and this message is shown. Okay, so I run the code one more time. I have Reza Shahin and the last n is a lowercase, therefore we are meeting that condition. Okay, lowercase letter is at least one lowercase letter is included. So when I enter, it says this message. You see, password must contain at least one digit. Password must contain at least one digit. So what is the problem with this password? This password has at least the 8 characters. Yes. Is it having a lower case letter? Yes. In the when we are checking the characters one by one, the last character is a lowercase character. Therefore, this true is assigned to has lower, and all of the other characters are uppercase. Therefore, when we are checking the is upper function for each character. We are at least one time assigning true to has upper. So also we are having this function is not going to be, this message is not going to be shown because we at least have one uppercase letter. But here we are checking to see if if any of the characters that I entered for my password is a digit or not. So because I was not having any digit, this condition never became true, and this true has never been assigned to has digit boolean variable. Therefore, here it says has digit boolean variable. Is it false? Yes, it's false. Therefore, it is going to return this message. So now I'm going to enter the same password, Reza Shaheen, and I put number 1 in the end. So when I run the code, we see that we get another message. Password must contain at least one special character. This message is shown. So the problem of the digit is now solved because now we are having at least one digit, because when we were iterating through each character, we saw that we had one digit, and true has been assigned to has a digit variable. So this message is not shown. But when we were iterating over the characters and checking to see if there is one of these characters is included in my password to assign true to has a special, we saw that neither of these characters were included in my password. Therefore, no character was having any of these signs. Therefore, this was not true, and therefore true was not assigned to has a special, and therefore we are checking to see has a special. Is it still false? Yes. Therefore, this message is shown. So now what if I have my password Reza Shaheen, the last n is lowercase, we have one digit, and I have this sign. So now it says password is valid. So this is how we can have a password checking validation system to see if the user is entering a password that can meet all of these characters and criteria for us. Thank you for watching. Hi, welcome to this video. In today's video, we would like to write a Python program to find those numbers which are divisible by 7 and multiplies of 5 between 1,500 and 2,700, both included. So we would like to write such a program. In order to write such a program, first of all, we need to define the range. So the starting point is 1,500 and the ending point is 2,700. Okay. Now, in order to find the numbers that are divisible by 7 and multiplies of 5, we need to have a for loop because we need to iterate through all the numbers between this number and this number. And then, if they are divisible or multiply of 5 and 7, we are going to print those values. One important point to consider here is that we are saying that we want those numbers which are divisible by 7 and multiplies of 5. It means that it should pass both conditions, not either of them. If we were looking for either of them, we had to have or word here instead of and. So when we are having and, it means that both conditions must be true. Okay, now we know what we want. We're going to have a for loop saying that for each variable num in the range start and end plus 1, because we know that when we are having a for loop, the starting point is inclusive, but the ending point is exclusive. So when we write down the end, which is 2,700, it is going to loop up to 2,699. Okay, so the end point in for loops is exclusive. So range
starting point, ending point. Okay, so the starting point is inclusive, but the ending point is exclusive. So we are going to start from the starting point 500, sorry, and the ending point we want it to be 2700. But if we write down this number there, it is going to go up to 2699. Therefore, we need to add 1 here to have the full range. Then we check if that number is going to be divided by 7 and its remainder of this division equals 0, it means that it is divisible by 7. Yeah. So one condition to understand if a number is divisible by 7 or not is the following. So a number is divisible by 7 only if that number is divided by 7 and the remainder of this division equals 0. In this condition, we know that that number is divisible by 7. So if a number is divisible by 7 only if that number is divided by 7 and the remainder of this division equals 0. In this condition, we can say, okay, that number is divisible by 7. So this we are checking here using the modular operator, because we learned that using modular operator, we can understand the remainder of the division between two numbers. And because we were having the division by 7 and multiplies of 5, therefore we need to have the AND operator here. And here, in order to check if a number is multiplied of 5 or not, again we are going to do the same test. If a number is multiply of 5, that number, when it is divided by 5, the remainder of this division must be equal to 0. Also, we can say a number is a multiply of, for example, 5 only if that number is divided by 5 and the remainder of this division equals 0 again. In this condition, we also understand that number is a multiply of 5. So if a number is a multiply of 5 only if that number is divided by 5 and the remainder of this division equals 0. So we are using modular operator to check this. So if this number is divided by 5, the remainder equals 0. So if both of these conditions are true, because we are using AND operator, print that number for me. It means that that number is also divisible by 7 and multiplies of 5. So print that number for me. And this is the message I'm going to print. Here we are saying that numbers divisible by 7 and multiplies of 5 between 1500 and 2700 is the following, for example. And then we are doing this for loop to and in each iteration we are going to understand if that number is divisible by 7 and multiplies of 5. If yes, print that number. If no, go up and go for the next iteration. So when I run this code, we see that, for example, numbers divisible by 7 and multiplies of 5 between 1500 and 2700. These are the numbers: 1505, 1540, 1575, 1610, 1645, etc. until the end. And the numbers that are not printed out here, they are not divisible by 7 and multiplies of 5 at the same time. This is why we don't have them in the print here in the output. Thank you for watching. So in this video, we learned how to print numbers that are between two numbers. So we discuss how we can find if a number between two other numbers, so the numbers between, for example, 1500 and 2700, all of them between this range, we considered if a number in this range is divisible by 7 and at the same time a multiply of 5. Thank you for watching. Welcome back. In today's video, we would like to write a program to construct the following pattern. This is the pattern that we would like to have, and we need to write a program to do this for us. So we see that it's a repetitive pattern. So we are having star being printed in different lines. We can either do it manually. For example, we can have this print star. We can have this. And then in the next line, we can have the print. Now 2 stars, for example, with a distance, etc. until the end. But it's not a very efficient way of doing it. In order to do that, we learned that repetitive tasks are very good to be done using loops. So we are going to use loops here in this example to do the job for us. So first of all, we see that what is the maximum number of rows that we see here. So we are what is the number of columns that we are having here. So here it's only one column. Here we are having first column, two column, third column, fourth column, and the fifth column. So we are going to have up to 5 columns. So in one row, first we are having 1 star. In the next row, we are having 2 stars. In the next row, we are having 3 stars. So the maximum number of stars that in one row we can have is 5. This is why we are having our n equals to 5. The maximum stars that are there in one single row is 5. So we are having n equals to 5. Now, let's start the work. We said that for repetitive tasks, it's better to use loops. Here we are going to have a for loop with our iterating variable I for each I that is in the range of 1 and n plus 1, because we learned that when we are having the range, the starting point is inclusive, but the ending point is not inclusive, okay? Therefore, we are having the ending point, which is 5 plus 1 here. And in each iteration, we are going to print the star with the repetition, with the number of I. What does it mean? It means that, for example, when I equals 0, when I equals 1, sorry, because we are starting from 1, print 1 star, okay? But if I equals 2, print 2 star, 2 star, with 1 space between them. Why? Because we are having it here. So we are having a star and then a space multiplied by I. It means that whatever the value of I is, multiply it with this. Okay, so this is going to be printed as large as the value of I. If I equals 1, it is going to be printed once. If I equals 2, it is going to print it 2 times. A star with a space. Okay, if it's 3, it is going to print the star with a space 3 times. Therefore, here, when we are having the I equals 1, we are having 1 star being printed. When we are having I equals 2, we are having 2 star being printed. And then it goes up, increase the iterating variable, I equals 3, it is going to print 3 stars, then 4 stars, until it is 5 stars, okay? So now let me run the code. We see that in the first iteration, we are having I equals 1 because the starting point is 1, we are having 1 star. Then I equals 2, we are having 2 stars. 3 stars, 4 stars until the end, 5 stars, because we are having the endpoint exclusive. 5 plus 1 is 6, and we are going to have therefore up until 5 inclusive, and we are going to have this print. So this print is the first half of the pattern. Okay, so this part is now created. Now what we need to do is to have a for loop, another for loop to print us the stars, the remaining stars, and in each iteration, now instead of increasing the number of stars, reducing the number of stars. Okay, so in order to do that, we are having the second half iteration, an iteration for the second half of the pattern. So we are having a for loop for each I in the range n-1 and 0. So it is going to start from 4. Let me have a comment here. Range. So it is going to start from 4, and it is going to continue up until I equals 0, but because it's inclusive, it is going to go one number before that, which is 1. And in this iteration, the point is this. We are going to reduce the iterator variables. So by default, I, when it is equal to 1, in the next iteration, it is going to be 2. In the next iteration, it is going to be 3, etc. But when we indicate that this number, the third argument, we are going to start from 4, I equals 4. In the next iteration, I will be equal to 3 because we are reducing one value from it at each iteration. In the next one, I equals 2. In the next one, I equals 1. And we are going to stop there. Why? Because the ending point is 0 and the ending point is exclusive. So the last number before that is when I equals 1. Okay, so we are having a for loop for each I in this range, starting from 4, ending at 0 exclusive, and in each iteration we are going to reduce the value of I by 1 unit. Then in each iteration we are going to print again stars to the number of I. For example, when we are having 4, I equals 4, we are going to have the 4 stars with one space between them. Then in the next iteration, I equals 3, we are going to have 3 stars. Then I equals 2, we are going to have 2 stars. Then I equals 1, we are going to have 1 star. But why we started from n-1? Because already we have the row which has 5 stars, which is here in our pattern. So the next row is having 4 stars. So the next for loop that we are writing should have the starting point from the 4. So this is why we choose n-1, which is this number. So we want to start from 4 because we already have this row with 5 stars. We're going to have the 4, and in each iteration we are going to reduce the value of I up until it reaches to ending point 0 exclusive. So now this pattern will be created when we are having this for loop. So if I run the code, we see that the second half of the pattern is now also created. So the first part, for the first half of the pattern, we use the first for loop, and for the remaining part of the pattern, we use the second for loop. Here we saw that we started from 4 stars, then 3 stars, then 2 stars, and finally 1 star. So in this video, we learned how we can use for loops to construct this pattern instead of manually printing these stars. So now this way, everything is easier. Thank you for watching. Hi, welcome back. In today's video, we are going to write a Python program that asks a user to enter a string, and we would like to reverse the entered string by the user and print the reversed version of that string, or let's say phrase. In order to access inputs from the user and store it, we are going to have this line of code. We are going to use the input function. We are saying that enter a word, and whatever they are going to enter, we are going to store it in the word variable. And simply, when we want to reverse a word, we are going to use slicing. In order to reverse a word, we need to write down the name of the variable, and then we are having colon colon -1. This way, the compiler is going to directly start reversing that string for us and assigning it to reversed word variable now. And finally, it is going to print the reversed word, which is this message. First of all, is shown using the print function reversed word colon, and then the reversed word is shown here. So this variable that we reversed is shown here. So let me run the code. So when I run this code, it says enter a word. I would say Reza, for example, and I enter. It says the reversed word is Azer. So A, Z, E, and R. Exactly from the end, it starts to reversing our string. So let me try another example here. Reza Shahin. So I enter. It says NIHAHS space. Even the space is there. And then the rest of the work is there to reverse our word, our string, let's say. So if I have a phrase, what would happen? For example, this is the Python online course that we are having here. So it's, first of all, it's our original phrase. This is the Python online course that we are having here. And now you see that it starts from the last word and starts reversing the last word, then the one to last, two to last, etc. So you see that instead of here, we are having this word. Instead of having, we are having exactly this word. So having ends with ing. It starts with G, N, I, V, A, H. So V, A, H. And then we are having the era instead of the R, and we are having EW instead of V, and the all of the words are reversed here. So in this video, we learned how we can get one string or a phrase from the user and then start reversing it simply using this methodology. So we write down the name of our string that is holding the string inside of it. So the word variable is having the input string from the user. Then we write it down and simply we are having colon colon -1 starting to reverse our string from, and it is going to basically, the compiler is going to start reading our string from the end. So this is why we are using -1. -1 is the index of the last letter in our string. So it is going to start reading our string. For example, if my string is, for example, Reza. Okay, when we are having the indexing, so the index is 0, 1, 2, 3. So for letter, I'm providing the space so I can explain it easier. So for letter R, the index is 0. For letter E, the index is 1. For letter Z, the index is 2. For letter A, the index is 3. Okay. Also, it can be this way. Okay, -2, -3, and -4. So here we see that letter A is also having the index -1. Letter Z is having the index -2. Letter E index -3, and letter I index -4. Therefore, when we are using this methodology, basically the compiler starts reading from the last letter of our string, which is also having the -1 index. So the compiler starts reading from here for each word. And when it is going to read from here, it is going to also store it. And now we are having the output which is reversed, because instead of having the Reza, now the compiler is seeing AZER, because it is reading it from the end, from the -1, then -2, -3, and -4 until it reaches the starting point, which is R now. Okay, so this is how the compiler treats a reversing, and after reversion, it is assigned to reversed word variable, which is another string, and then we are printing it here in the output. Thank you for watching.
Welcome to this video. In today's video, we would like to write a Python program that prints all the numbers from 0 to 6 except for 3 and 6. Okay. In order to do that, the one method is to print, for example, 0, then print 1, etc. until the end manually. But we learned that if we are doing repetitive tasks, it's important to use for loops. So now I would like to use for loops here. Here is my for loop. So for each num is my iterating variable. For each num that is in the range between 0 and 7, we are looking for numbers from 0 to 6, but because we learned that the ending point is exclusive, so we are going to have between 0 and 7 is exclusive, so it is going to include up until 6. If num equals 3 or equals 6, simply continue. And if this statement is not true, print that number for me. So when I run the code, we see 0, 1, 2, 4, and 5. And 3 and 6 are not being printed. So let me analyze the code for you. Num is my iterating variable here. Okay. So in each iteration, num is going to take one value. First of all, num is going to take value 0 in the first iteration. When num equals 0, what happens is the following. It checks to see if num, which is 0, equals 3. No. Is it equal to 6? No, it's not equal, because this condition is not true. Therefore, this block of code, which is one part of the if condition, is not going to be executed, and then it is going to come here. Using the print function, we are going to print that num, which is 0 that we see here. Okay, and this end keyword helps us to have all the prints in one line rather than having them in different lines. So if I remove this, for example, when I run, you see that they are not in one line. They are in different lines. Okay, so when I have this, everything is going to be printed in one line and with a space. Okay, so you see it here. In the first iteration, num equals 0, and we're going to have the 0. Then num equals 1, and we are going to, in the next iteration, 1 equals 3. No. Is it equal to 6? No. Therefore, we're going to go to the print again. We're going to print 1 and put 1 space. Then num equals 2. 2 equals 3? No. 2 equals 6? No. Therefore, we're not going to go to this part and we're going to print. Simply, we are saying that, okay, 2 is printed with 1 space. After that, we are having num equals 3. Here in the next iteration, num equals 3. 3 equals 3? Yes. And because we are using the OR operator, we are not even going to check this part, because when we are having OR operator, either of the conditions must be true. So we don't care if it's the first one or it's the second one. If one of them is true, we are going to have the result to be true. Okay, so whenever we are, let me review it here for you. Whenever we are having the AND operator, both conditions must be true to enter it. Okay. When we are having the OR operator, however, one of the conditions must be true to have the true output. Output. To have the true output. Okay. So when we are having AND operator, both conditions must be true to have the true output. But when we are having the OR operator, one of the conditions must be true to have the true output. So we are having the OR operator and one of the conditions, either this one or this one must be true. And num equals 3 means that 3 equals 3, so it's true. Therefore, we are going to continue and execute this part of the code. So when this condition is true, we are going to say, okay, so we enter this if condition, and the code in the if condition is continue, meaning that do nothing, skip. Okay, so nothing will happen, and we are getting out of the if, and we are going to increase the num one more time. So we are having num equals 4. This is why when num equals 3, nothing happens actually. When num equals 3, we are using the key word that is continue, meaning that, okay, carry on, skip, and do nothing. And when we say continue, okay, it is going to go for the next iteration where we are having num equals 4. So num equals 4, we enter the this part again. So 4 equals 3, no. 4 equals 6, no. So this part is not executed, and we are printing 4. Then num equals 5, we are having this condition is not true because 5 is neither equal to 3 nor to 6. We are going to print 5. And finally, we are having num equals 6. So we are saying that num equals 3, no. Or num equals 6, yes. Therefore, continue, enter this part and use the keyword continue. So we are going to continue and do nothing, skip. This is why nothing is being printed here in the output when we are having that num equals to 6. And this can be true for many other situations. For example, we can have num1 in range, for example, between 0 and 101. Let's say between 0 and 100 we want to investigate, but because the ending point is exclusive, I'm saying 0 and 101 colon. Then we check, for example, if num1 divided by 2 equals 0. In this situation, print, for example, the number is even, and we can have this condition here. So when I run the code now, we see that, okay, let me also print the code. Okay, we see that the number is even, the number is even. So also I need to have the num1 in each iteration, so it is going to show me which number is even. So when I run the code, it says the number is even. It's 2, 4, 6, 8, 10, etc. until the end, you see. So we see that here I'm having a for loop from 0 to 100, and if that number, that iterating variable in each iteration is divided by 2 and the remainder of this division equals 0, it means that that number is even, and we are going to print that number. So this is another exercise combining the concept of for loop and if conditions. Or we could say if it was divided by 7 and the remainder of the division equals 0, it means that that number is divisible by 7. So we can say divisible by 7. So if we want to print the numbers that are divisible by 7 between 0 and 100, we can run this code. We see that all the numbers that are divisible by 7 are printed here in the output. And also we could say, for example, if the number is divisible by 7, continue, do nothing. Okay, otherwise print the number for me. So print the num and we are going to have also the AND keyword to have all the numbers in one line. So when I run the code, okay, we are having a very large range, so we are having a lot of output. Let me reduce the range. So when I run the code, we see that, okay, here let me first comment this part. So now if I run the code, we see between the range of 0 and 50, all the numbers that are divisible by 7, we're not printing them here. And we are printing all the numbers except those that are divisible by 7. Okay, we see 1, 2, 3, 4, 5, 6, 7 we don't have. Then we have 8, 9, 10, 11, 12, 13, and 14 we don't have. 21, for example, we don't have. 28 we don't have, etc. until the end. So this is how we can combine the concept of for loops and if conditions in order to check certain conditions and continue and skip and do nothing in certain conditions and do something else in other conditions. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that accepts a string and calculate the number of digits and letters. For example, when I run the code, it says enter a string. I write down Reza Shahin, and it says the number of letters, it's 10, and the number of digits it's 0. Okay, so we would like to write a program to calculate number of letters and digits. Okay, in order to do that, first of all, we're going to start with this message. We're using the input function to show this message to the user, enter a string, and then we are going to ask the user to enter a string, and whatever the user is going to enter, we are assigning it to text variable. We are having two counters here, letter count and digit count. So we are going to initialize them to be 0 because whenever we see a letter, we are going to increase it. So this way we are counting the letters and digits. Now we need to have a for loop. So in order to have a for loop, we are having our iterating variable, which is called char. So for each char in the text, this is the variable that we stored the string that we got from the user. If that character is a letter, increase the value of letter count by 1. And if that letter is a digit, if that character, let's say, is a digit, increase the digit count. And we are going to use the is alpha and is digit function to do that. Basically this function is going to help us to see if one character is a letter or it's a digit. So in order to understand if a char is a letter, we can use the is alpha function, meaning that, for example, if the name of my character is char, like this, char dot is alpha is going to tell us the answer is true or false. If it's true, it means that this character is a letter. If the output is false, it means that this character is something else. It's not a letter, let's say. So here, in order to check if one character is a digit or not, we are also going to use the is digit function. Okay, so here we are going to check to see if that specific character is a digit or not. If character is digit, this line of code is going to return true for us. If that character is not a digit, it is going to return false for us. So here we are iterating through each character of my string here, text, and checking each character one by one. So I say that character, in the first iteration. For example, let me run the code one more time. I say my string is Reza. It says we are having 4 characters. Let me say Reza 1. Okay, it says 4 characters, 1 digit. So now let's see how it works. In the first iteration, my character equals R because my string is Reza 1. Okay, in the first iteration, the char equals R, and then we check to see if R is a letter. What is the answer? Yeah, it's true. So because this statement is true, we're going to enter the if condition and we are going to increase the value of letter count by 1. So letter underscore count plus equal 1, meaning that we are going to increase it. Then in the second iteration, char equals E, and we are going to check if this character, which is E, is a letter. Yes, yes. Therefore, we are going to increase this value again. We are going to have letter count. Another time it is increased. So here, letter count was equal to 1. Initially, it was 0 because we initialized it here. Okay. Then after this iteration and doing this, it became 1. Now after doing after the character E in the second iteration, we are increasing the number of letters. Now it is also increasing by another 1 value, so it becomes 2. Now we are having the character. What is the next character? This is Z. Okay, character equals Z. We check to see Z is a letter. Yes, the answer is true. So we are going to increase this value again. We are going to increase this value 1 more time. Therefore, the number of letter counts now equals 3. In the next iteration, we are going to have char equals to 1. We check to see if char is a letter. Yes, so we are going to increase the letter count 1 more time. So now it's equal to 4. And finally, the last character is this one. Okay, is this one, 1. So we can have char equals 1. So we this time when the character is 1, we check this part. If the character is a letter, the answer is no. It's false because it's not a letter, it's a digit. This time my character is getting the value 1. Therefore, because this statement is not true, it's not going to execute this part. It goes and check the next condition. Here we are checking to see if our character is a digit. Is it a digit? Yes, the answer is true. Therefore, we are going to increase the value of digit count. Therefore, here the character equals 1. So digit count plus equal 1, meaning that the digit count equals 1. So now we iterated through all the characters of my string and we calculate the final number of letter count to be 4 and digit to be 1. So after finishing this for loop, we are having the number of letters in the output. We are using the print function. So letter count is being printed, number 4. This is exactly what we expected. This is what we calculated. And also we are seeing that number of digits. So it is digit count. So it is 1, which is exactly what we had here. So this is how actually we can get a string from the user. We can initialize the counters for letters and digits, and then we can loop through the string that we got from the user, and each character can be investigated one by one to see if it's a letter or if it's a digit. And in the end, because when it is a letter, we are going to increment the value of letter counter. If it's a digit, we are going to do the same. We are going to increase the counter. And in the end, we are going to print the letter count and digit count. Thank you for watching. Hi, welcome back. In today's video, we would like to write a Python program to check if a triangle is equilateral isosceles or scaling. So first of all, we need to know what are these triangles. Let me review the definitions. So a triangle is equilateral if all sides are equal. Okay, so a triangle is equilateral if all sides are equal. For example, side 1 equals side 2 equals side 3. So, for example, side 1 is 5 centimeter and side 2 and side 3 are also 5 centimeters. Therefore, side 1, for example, equals 5, side 2 equals 5, side 3 equals 5 as well. It means that side 1 equals side 2 equals side 3. When we are having this situation, we call our triangle equilateral. Now, we call a triangle isosceles if a triangle is isosceles if two of the sides are equal. Okay, it means that, for example, side 1 equals 5, side 2 equals 5, and side 3 equals, for example, 10, for example. So these two sides are equal. This is why that we can call this triangle isosceles. Okay, so two sides are equal. This could be side 1 and side 2. This could be side 1 and side 3. This could be side 2 and side 3. So if any of the two sides of a triangle are equal, we are going to call that triangle isosceles. Okay. Then we are going to have the scaling triangle, meaning that neither of the sides are equal. So a triangle is scaling if neither of the sides are equal, meaning that side 1, for example, equals 2, side 2 equals 3, and side 3 equals 4, for example. In this situation, we are going to call this triangle as scaling. So we would like to write a Python program to check if a triangle is equilateral, isosceles, or scaling. And we reviewed these three definitions to have a better understanding of what it means to have a triangle that is equilateral, a triangle that is isosceles, or a triangle that is scaling. Okay, now, first of all, we are going to ask the user to enter three numbers. So we are going to use the input function and ask the user to enter side 1. We are going to save it as a float because when we are using the input function, by default, it's a string. We are going to convert it to float and assign it to A. We are going to do the same thing with side 2. We are going to use the input function to get it, and then we convert it to float and assign it to B. And side 3 is also goes through the same procedure and is assigned to C. And now, in order to understand if a triangle is of the type 1, 2, or 3, we need to define a function. This is our function, check triangle. In this function, we are going to check if the triangle is equilateral, isosceles, or scaling. But before that, we need to check the sides of our triangle to see if they are valid or not, because it means that when we are having the addition of two sides, it must be larger than the third side. Okay, the third side, yeah.
So for example, a plus b must be larger than c, and a plus c must be larger than b, and b plus c must be larger than a. This is a general rule for sides of triangles of a valid triangle. So first of all, we are going to check this. If this part is true, we are going to call the check triangle function. Otherwise, if this statement is not true, it means that we are not even having a valid triangle. We need to revise it, and this message is shown. The given sides do not form a valid triangle. Okay, so we imagine that we are going to enter inputs that is a valid triangle. We are going to call the check triangle function, and we are going to pass three arguments, a, b, and c. So the check triangle function is called using three arguments, a, b, and c. So we check to see if the sides, all of them are equal. So a equals b equals c. If this statement is true, we are going to print this message. The triangle is equilateral. Okay. But if this statement is not true, so this part is not going to be executed, and we go for the next condition. If a equals b, or b equals c, or a equals c. So here we check to see if any of the two sides of the triangle are equal. So a equals b, or b equals c, or a equals c, because if any of these conditions is true, it means that we are having an isosceles triangle. So we check all the sides 2 by 2 if they are equal. If we at least have two sides that are equal, it's an isosceles triangle. Okay, if all of them are equal, it's equilateral. So we check a with b if it's equal or not, b with c, or a with c. If any of these conditions, any of these three conditions is true, we are going to enter this else part, and we are going to this elif part, and we are going to print this message. The triangle is isosceles. Otherwise, if neither this condition nor this condition is true, it means that the triangle is scaling. So we are going to print the scaling message in the output. Okay, so this is how we can check the type of our triangle. So let me run the code first. It says enter side 1, I say 5, enter side 2, I would say 5, enter side 3, I say 5. So all of the sides are equal. We expect to have this message. The triangle is equilateral. So when I enter, it says the triangle is equilateral. So we call the check triangle function, and we see with these three arguments, and then we check here a equals b equals c. Yes, so the triangle is equilateral. Then this message is shown. So if I run the code one more time, so 5, 6, and 7, when I run the code, this time it says the triangle is scaling. Why? Because we are having a triangle and neither of the sides are equal. So 5, 6, and 7. The first one, all of them must be equal. The second one, two of them must be equal. And if neither of them are equal, it's scaling. And finally, we are having, for example, another triangle, which is 5, 4, and 5, let's say. And this is a triangle of type isosceles. So this one. Why? Because the first side and the second side, both of them are the same number. So here we check a equals b, 5 equals 4, no. B equals c, 4 equals 5, no. A equals c, so 5 equals 5, yes. Therefore, it enters and checks here. The triangle is isosceles. So in this video, we learned how we can write a program to check if a triangle is of type equilateral, isosceles, or scaling. Thank you for watching.
Welcome back. In today's video, we would like to write a program to count the number of characters in a string. In order to do that, I would like to define a function that is going to do the counting of each character. So in each character, frequency is counted inside this function, char frequency. What I'm going to do here is the following. For example, when I run the code, it says enter a string. So I write down Reza, for example. When I enter, we see that it says R, the frequency is 1, E, the frequency is 1, Z, the frequency is 1, and A, the frequency is 1. So our program counts the number of frequency of each character. When I run the code one more time, I type down Reza R, for example. This time it says we are having two R, one E, one Z, and one A. So here, first of all, I ask the user to enter a string, and we use input function to get the string from the user. We assign it to text. Then we are having the call of the function of the char frequency. This is the name, and we are passing text variable as an argument of this function. And the output of this function is assigned to variable called frequency, okay, which is a dictionary. But let's see what's happening inside this char frequency function. When we call this function, the compiler comes here, it checks the name of the dictionary, sorry, the name of the function, and okay, so this is the function that was called. When this function is called, this part of the code is going to be executed. So first of all, we are creating a dictionary to store character count. And as a reminder, when we are having a dictionary, we're going to have key values. Okay, so a dictionary is having key value pair. It means that, for example, for the key one, we are having value 1. Then we are having, for example, key 2 and key 2. Then we are having value 2, for example, etc. Okay, so just imagine that we are having a dictionary with two keys and two corresponding values. So it's a key value pair, a dictionary. We are having the key 1, its corresponding value, key 2, its corresponding value. Here exactly, if you see that R is my key and its corresponding value is 2. So in a dictionary, we can easily count the number of frequency for each character. Now I created an empty dictionary here. Then we are looping over the S. So for each character that is in S. And what is S? S is exactly what we passed as argument to call the function. And what did we use to call the function as an argument? This is the text, which is what the user entered. So the entered string by the user is stored in text. We pass text as an argument for the char frequency call of function. Here we just name it s, and we are now looping over the string that the user enters. So we are looping over the string that the user entered. Okay. Now that we are looping over each character of a string that the user entered, just imagine the string is Reza R. Okay. Now, for example, in first iteration, character equals R. So we are looping over R. Then in the next iteration, character equals E, character equals Z, equals A, and equals R. So in each iteration, we move forward character by character. Now we are saying that for each character in the string, if character is inside the frequency dictionary. What does it mean? It means that, for example, we are checking to see now that my in the first iteration char equals r, okay? We want to see if r is in frequency dictionary, okay? In order to check that, we need to check the keys of my dictionary. And first of all, in the beginning, initially, this dictionary is empty. So when in the first iteration, when we are having the character R and we are checking to see if R is inside the frequency, the answer is false because initially it's an empty dictionary. So there is nothing inside that. Okay. Now that this statement is not true, we are not going to execute this part of the code and we go to the else part. When we go to the else part, now we are having the value of that character in the frequency dictionary equal to 1. Okay, so we are creating one element for the frequency dictionary here. So what's happening here is the following. So now frequency dictionary is having one key and its corresponding value. Okay, let me repeat it one more time. So what's happening here is the following. So first of all, we started by looping over the string that the user entered. So we are having the character by character, we are looping over the string. For example, if the string is Reza R, first we start by R. We check if R is in the frequency dictionary. The answer is no, because initially it's an empty dictionary. So this part of the code is not executed. We go to the else part. Here we are creating a key for this dictionary, which is R, and we assign its value to be 1. Okay? And after this has been implemented, we go up, we move to the next character, and next character is now E. So now the next character is E here. Okay? So now we check if E is in the frequency dictionary. Now our frequency dictionary has one key and its corresponding value, which is R and 1. So E, is it inside the frequency? No, because we only have R, so this part is not executed. Then we move on to the else part, and we are creating a key with the name E, and its value is 1 in the frequency dictionary. So now the next one is created, which is E, and its value is 1. Okay, so we go for the next character now. Next character is Z. So Z, is it inside the frequency? No, because here we only have R and E. So we go to the else part, and we are creating another key which is called Z, and its value is 1 in the frequency dictionary. We do the same with A. So A is not existing already there. We are creating one uh, and assign it to the A key. Now that we are going to the last character, the last character is R. So we check R, is it in the frequency? Yes. Now the answer is yes, because we already have one R. So in this case, we are going to increase its value by 1. Okay, so we are going to increase the value of the R key in the frequency dictionary by 1. So it is already 1. We are going to increase it by another 1 unit, so it will become 2. Okay, so let me repeat the last part. We are going to have the last iteration. So the last iteration is over R. We check to see if R is already there. Yes, R is already there. So R is there. So this statement is true. We check to see if this character is already in the frequency dictionary. Yes, therefore we are going to increase the value of R in the frequency dictionary by 1. So it was already 1. We are adding another 1. It will become 2. This is how this function is going to count the number. So the number of frequency of each character. So in this frequency dictionary, now I have R equals 2, E equals 1, Z has the Z has the value 1, and A has the value of 1. So A, Z, E, and R, they are my keys. As we said, it's a key value pair, and it's 2, 1, 1, and 1. It's their corresponding value. As we expected here, we saw the same thing in the output. So we were here. So here we called the function. We did all this computation, and in the end, we are returning the dictionary frec, okay, or let's say frequency. We are returning this dictionary. So we created this dictionary and we are returning it now, okay? And the return dictionary is assigned to this frequency variable, which is itself a dictionary. Now we would like to display character frequencies. So everything is inside this dictionary now, frequency, because the output of the function was assigned to this variable. Now we are having that. We are looping over characters and values. Let's say we call count here. These two are my iterating variables, character and count. And they're going to iterate over the keys and values respectively. Okay, keys and values, keys and values. For example, this char iterating variable is going to iterate over all the keys R, E, Z, A, and this count variable is going to iterate over their corresponding values 2, 1, 1, and 1. Okay. In frequency.items, when we are having the frequency.items, frequency is the name of the dictionary. .items means that the items function is going to help us to iterate over the keys and values. Now, in each iteration, we are going to print the character with its corresponding value. So in each iteration, we see R, for example, and its corresponding value is 2. So R is my character, its corresponding value is 2. We're printing it. Then in the next iteration, we are having E and 1. So E and 1, Z and 1, and A and 1. So this way, we are having a function to count the frequency of characters. And also in the end, to display these character frequency, we are using a for loop to iterate over key and value pairs of my dictionary. So in this video, first of all, we reviewed dictionaries, we reviewed how they are created, and we learned that a dictionary is a key value pair, and then we learned how to count the number of frequency of different keys in a unique dictionary. After that, we learned how to iterate through key value pair in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get a string made of first and last two characters of a given string. So if the string length is less than 2, return empty string instead. Or we can say, or a message, return an error message. Okay. So here is my code. When I run, it is going to return the first two and last two characters of a given string. For example, I'm calling the function using this string Python. What I get in the output is PYON. So the first two characters and the last two characters. I called it using hi Reza. I say I get hi, the HI and ZA in the end. And when I call the function with with a string less than 2 characters, I'm going to get this message. It must have at least 2 characters. Okay, so this is my code. But how can we do that? So here I'm having a function called first and last two. It accepts one parameter. Whenever we call this function, we need to have one parameter. So here I call this function first and last two with the argument Python. So I'm calling the function with a string. Here, first of all, in the function, I check to see if the length of the argument that is passed to call this function is less than 2 or not. So if it's less than 2, we are going to return this message. It must be at least 2 characters. Okay? So if the length is less than 2, it is going to show this message. But if it's not less than 2, we're going to return this part. And what is this part? Basically, this part is having a new string being returned with the first two characters and the last two characters of the S string. So for example, if my string is Python, here what's happening in the return, it is returning the S2 plus S minus 2, okay? And basically this part is going to create a new string that is py, which is the first two characters of my string Python, which is py, plus the last two characters, because we are having the index minus 2, okay? So the last two characters plus on, okay? So this one will become pyon in general in the end. So this is what we have as the output, as you see here. But why minus 2? So if I have a string here, let me give you another example. If I have a string called Python, the indexing works like this: 1, 2, 3, 0, 1, 2, 3, 4, 5. So this is the indexing. So index of the P character is 0, index of Y character is 1, etc. until the end. The index of N is 5. So the character N has the index 5. We also have another method for indexing a string. We can start from the end. So when we start from the end, the last one is minus 1. For example, the character N, the index is minus 1. Then the character O, the index is minus 2. Character H, index is minus 3. Character T, index is minus 4. Character Y, index is minus 5. And finally, the character P, its index is minus 6. So we can either count from left to right for indexing, where we are having from 0 until 5, or we can count from right to left, which will have this way. So n equals minus 1, o equals minus 2, etc. So this is the indexing of our characters of this string. So when we are having the string s, the first two characters, it will be index 0 and 1, which is p and y. And when we are having the minus 2 and then colon, it means that start from the minus 2, which is o, and go until the end, which is o and n. Okay? So this is how we can have this. So minus 2, it will be O and N. If I write down minus 3 and then colon, it means that it starts from H and continue until the end. This is how we can create a string from the first two letters and the last two letters. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to change a given string to a newly string where the first and last characters have been exchanged. So what we are doing here is the following. I'm having, for example, a string called Python, and in the output, we see that the first character, P, and the N, the last character, they have been exchanged in the output. So N is now my first character and P is my last character, while the rest of characters remained the same. You see it here. Yeah. So also this happens for the hello. H and O, they have been exchanged. We see O is my first character, H is my last character, and the rest of the characters are the same. And if we are having a character with less than 2, length of less than 2, let's say, we're going to have this message, not long enough, not long enough. So what we are doing here? First of all, we are calling the swap first last function. And this function, what is it going to do? It's going to create a new string and it is going to exchange the first and last letters. So swap first last function, we are calling it with an argument s. Here when I call the swap first last function, I'm having a string as argument that is passed. Then we check if the length of the passed argument is less than 2 or not. If it's less than 2, we're going to have this message being shown, not long enough, exactly as we have here. But if the length is larger than 2, we're going to return this part. Because this statement is not true, then we're going to go here and execute this part of the code. So what this part of the code is doing. So my string is hello, let's say. Okay. This part of the code is saying that s with the index -1. So the character with the index -1 of my s string, and this is my string. The character -1 refers to the last character. Okay, character with the index -1 refers to the last character. So create a new string where the first character is O because we are putting it in the beginning. So the first character is O. Why? Why O? Because we are calling the string with character of index -1, and character with the index -1 is O in the S, for example, a string which is hello. So the last character, which is having the index -1 of my string hello, is O. Okay, so I write down O here, plus, then we are having a new separation, let's say. So we are having now character from 1 to -1, and the ending point is exclusive. So we are writing it down like the following: from index 1, which is E, until index O, which is the -1, but the end is exclusive, therefore we're going to be having this. Okay, and why we are having index 1 from E? Because when we are having a string like hello, the indexing starts from 0, 0, 1, 2, 3, and 4. Okay, this is my indexing. And now H is having index 0 and E is having index 1. Okay, so from 1, which is the starting point, and the starting point until ending point. But we need to be very careful. Ending point is exclusive. So ending point is exclusive. We are going up until -1, but -1 is not included. Okay, so we start from 1, which is E. We go up until -1, but because it is not included and it is excluded, uh, we are not going to have that, so we are having ELL. Okay, so ELL plus, now we are having the index 0 of our string. So we mentioned that this string hello, the index 0 is the first character, which is H. So here is my age now. So now we are creating a new string with these characters. So O, E, L, L, and H. Okay. So this is how we are going to exchange the first letter and the last letter. Also here, I'm having another example for Python. The same happens here. So we are going to, let me write it down here. So we are having a string called Python. First, we are putting the last character, which is n, plus ytho plus p. Why? Because we are saying first the last character, which is n. So we are putting it here. Then start from the character with index 1 and go up until character -1, but the -1 is exclusive. So this is index 1, which is y, go up until -1, but -1 is exclusive. So we go 1 to the left, we are having the ytho as we have here. And finally, we are having index 0 of the string s. So index 0 of this string means that we are talking about the first character here, which is p. So now we created a string that is like this, nytho and p, exactly as we see here in the output. And in case that we are calling the swap first last function with any string that has the length less than 2, we are going to have not long enough message because it's less than 2. So the length of the character is measured through the len function. If it's less than 2, if this statement is true, we're going to show this message not long enough. So in this video, we learned how to exchange the first and last characters of a given string. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a function. And this function is going to check if a given string is palindrome or not. So palindrome means that it reads the same backward as forward using Boolean values. So here is my string. So you see that when I read the string madam from the left to right, it is madam, and if I reverse it, it will be madam again. So this is what we call palindrome. So reads the same backward as forward. Okay. And also here, this word is also a palindrome. So race car is my string. And if I read it from the right, which is RAC, which E, race, and CAR, race car. So from right when I read it, it's race car. From left when I read it, it's race car. However, the word hello, it's not the same. So when I read the word hello, from left it's hello, from right it's something like ole. And for example, for the next word, which is level, if I read it from left, it's level, and if I read it from right, it's also level. And finally, we are having the Python. So if I read it from left, it's Python, but if I read it from right, it's not Python. I'm not sure even how we can pronounce it. Nofip, something like this. So this is how we can understand if a string is palindrome or not. In order to understand this using Python, we write down a function that is called isPalindrome. And in this function, whenever we call this function, we are passing one argument. So we call this palindrome function with one argument called s. So whenever I call this function, I'm having one string. So the string is madam here. So is palindrome race car. So whenever I call this function, I'm having one argument being passed. So in this function, first of all, we use the def keyword to declare our function. This is the name of the function, and this is the arguments of the function. And in this function, we only have one argument. So in this function, what we are checking here is the following. We check to see if the string s equals to s when it is being reversed. So it checks to see if s string equals to its reversed version, and its reversed version is colon minus 1. Okay, s colon minus 1. This is the reversed version. Whenever I want to reverse a string, I'm going to do this. Okay, so now because this function, let's say this code will help me to reverse my string, I'm checking to see if my original string equals its reversed version. Okay, so here we check to see if it equals its reverse version. And when I call this is palindrome function with the madam string, or let's say argument or parameter, the output is true. Why? Because the original string, which is madam, is equal to its reversed version. Then we are having the race car, it's also true, but for hello, it's false. For level, it's true. For Python, it's false. So one thing here to mention is the following. So for example, if I have my string equals Reza, okay, this is my string, then my new string equals my string colon minus 1. So now print the reversed string is, then I would like to have my new string being printed. So when I run this code, you see that my original string is Reza. I want to reverse it. So now that I want to reverse it, I create a new string called my new string, and my string, which is Reza, is reversed using colon minus 1. And now I'm printing my new string, and you see that it is reversed. Other. It's the reversed version of Reza. Okay? So this is how we can reverse a string. So here we are exactly doing the same thing. In this function, we are having the original string and checking to see if it equals its reversed version. If this part is true, if they are equal, we are going to have the true in the output. If they're not equal, we are going to have the false in the output. So in this video, we learned how we can check if a string is palindrome or not. Thank you for watching. Welcome back. In today's video, we would like to write a program that calculates whether a person is eligible for voting based on their age or not. Here is my function. So it is called can underscore vote, and it needs one argument. And whenever we call this function, therefore we need to have one argument. And for example, here I'm calling the can vote function with the argument 20. So I'm passing this argument to the can vote function to check if this person with 20 years old can vote or not. Also with the age 18, also with age 16. So we're going to have three inputs to check whether the person can actually vote or not. So here, whenever this function is called, this code is executed and checked, investigated, let's say, these if parts. So first of all, we are checking to see if the age that the user entered or the age that we are investigating is larger than or equal to 18. If so, if this condition is true, it means that we are eligible to vote, because this is the only condition that we are defining here. So this person is larger than, it's more than 18 years or equal to 18, that person can vote. So we're calling the function with number 20. We check to see, okay, 20 is larger than 18. Yes, so you are eligible to vote. So when we run this code, we see this message here. You are eligible to vote.
Then we call the function with number 18. And 18, is it larger than or equal to 18? Yes, you are eligible to vote. Therefore, this message is also printed in the output. However, when we call the function with a number that is lower than 18, because this is the criteria for checking if someone can vote or not, we are calling a function, we are calling the function with a number lower than 18, for example, with 16. We check to see 16, is it larger than 18? No, it's not true. Therefore, this part is not executed and the else part is executed. Because whatever that is not inside this condition is going to fall into the else part. And this message is shown. You are not eligible to vote. You need to wait 18 minus age. So 18 minus the enter age, which will be 18 minus 16, so 2 more years. So you need to wait 2 more years. So here you see you are not eligible to vote. You need to wait 2 more years. So this is how we're going to have the output. So now if I want to have another input, for example, can vote, and in parentheses, I write down, for example, 10. So we want to check to see if someone with the age 10 can actually vote or not. So here we're calling the function 10. Is it larger than 18? No. So this part of the code is not executed and we fall into the else part. And we see this message. You're not eligible to vote. You need to wait 18 minus 10. It's 8. 8 more years. So when I run the code, you see that we are having this message. You're not eligible to vote. You need to wait 8 more years. So this is how we can actually combine the concept of functions and if conditions in Python to check a simple condition. If the person is older than or older than 18 years old, or the person is 18 years old, the person can vote. Otherwise, it's not possible and they need to wait. And how much they need to wait, the difference between their age and the number 18. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a function. And this function is called factorial. This function needs to calculate the factorial of a number that is a non-negative integer. So whenever I call this function, I need to have an argument being passed. So here I'm calling the factorial function and I'm having one number, for example, number 5. It means that I would like to calculate the factorial of 5. So here, when this function is called, n equals 5 in this part, and 5 is it lower than 0? If it's lower than 0, show this message, invalid input. Please enter a non-negative integer, okay? However, if it's not lower than 0, do the following. Assign a new variable, initialize a new variable called result, and it is equal to 1. And define an iterating variable, which is I. So for each I that is in range 1 and n plus 1, and we know that the ending point is exclusive, so we are having the range, starting point, ending point. And the ending point is exclusive. This is why we are having n plus 1, okay? So actually it is going to go start from 1 and goes up to n. And in each iteration, we are going to have the results equal result multiplied by I. So this formula exactly equals this formula. So if you think that this one is easier to understand, you can simply write it down. The results will be the same because they are the same thing. So in the first iteration, I equals 1, we are going to have result equal 1 multiplied by 1, and therefore result equals 1. Why 1 multiplied by 1? Because we are multiplying result by I, so result is 1. And in the first iteration, I is also 1, so result is 1. Then we are having I equals 2. So result will be 1 multiplied by 2. Result will be 2. Why? So we are having result multiplied by I. So result is 1 because from previous iteration it's 1. And I equals 2. So it will be 2 here. Then we are having I equals 3. For example, we are having result equals 2 multiplied by 3. 2 multiplied by 3. So now result will be 6. But how? Because we are having result multiplied by I. So result is 2 from the previous iteration. We have it. And also I equals 3. So we are having number 3 here. 2 multiplied by 3, it's 6. Then we are having I equals to 4. Result equal 6 multiplied by 4. So result is 24. And finally, in the last iteration, we are having I equals 5. So result 24 multiplied by 5. And the result will be 120. So result will be 120. So in the last iteration, we are having result multiplied by I. So result from previous iteration is 24 and I is 5. So we are having 24 multiplied by 5. It means that we are going to have the result equals 120. And because now I equals 5, we wanted to continue up until n plus 1, and n plus 1 is exclusive. So n was 5. Oops, sorry. So n was 5. We were supposed to go from 1 to 5 plus 1, which is 6. So 6 is exclusive. So we are going to go up until 5. So I is going to start from 1 and it is going to continue up until 5 because we wanted to calculate the factorial of number 5. Okay, so after finishing this loop, we are going to return the result, which is 120. So we're going to return it and therefore print this because we called this function with the argument 5. So it is going to return the result. So we're going to have the print 120 in the output. And next time I call this function with number -3. So when I call this function with number -3, it comes here. We check first of all to see if -3 is lower than 0. The answer is yes. So we are having this message being shown in the output. Invalid input. Please enter a non-negative integer. So this is why we see this message in the output. So basically in this code, we learned that we can have the calculation of different numbers factorial. For example, we can have factorial of, for example, 3. And when I run this code, we see that the factorial of 3 is 6. The factorial of, for example, 10. Let's calculate this one. So this one is this number, okay? We can have the calculation of factorial of 6. It's 720. So this is how we can have the factorial of any positive number using this factorial function. Thank you for watching. Welcome back. In today's video, we would like to write a Python function that takes two Boolean values as input and return the logical and or of those values. So here is my example. I have my two Boolean variables a and b. One of them is true, the other one is false. And we want to define a function that checks the relation between these two, the and or. Okay, so here is my logical operations function. So this is a function called logical operations. It requires two arguments, a and b. So whenever I call this function, I need to have two arguments, a and b. So here I try to call this function logical operations, a and b. Then we are assigning the result of this function to AND value and OR value. So we are having two variables on the left hand side, meaning that this function is going to return two values for us. Here you see this is the function output. So the first output, the second output. So the first output is going to be assigned to the AND value. The second output is going to be assigned to OR value. So this is how this function works. We're calling the function with two variables. On the right hand side, we are having the call of function. On the left hand side, we are having two variables. It means that this function is going to return two values for us, and OR. Okay, so it is returning also two values. After doing the calculation by this function, these two values are assigned to AND and OR values. Finally, we are showing the AND value and OR value. So what does this function do? Logical operations. Two variables, let's say two arguments are required for this function. So A and B. First of all, we are checking the relation between A and B. So A and B, the relation is either true or false. It is assigned to AND result. A or B, the output can be true or false, and it is assigned to OR results. But the question is when it is going to be true, when it is going to be false. So when we are having A equals true, B equals false, when we are having the AND operator, both conditions must be true to have an output of true. Okay, so when we discuss AND operator, if both of them are true, the result is true. So let me write it this way. True and true, it's true. True and false, it's false. False and true, it's false. And we are having false and false, it's false. So when we are discussing the AND operator, both of the conditions must be true so that we can have the output to be true. You can see it here. So true and true, so the output is true. But if one of the conditions is false, for sure the output will be false. So when we are having true and true, the output is true. But when we are having true and false, the output is false. When we are having false and true, the output is false. When we are having false and false, the output is false. So when using the AND operator, the only situation in which the output will be true is when we are having both conditions to be true. Okay. But what about the OR operator? So when we are having the OR operator, when we are having true or false, the output is true. When we are having false or true, the output is true. When we are having false or false, the output is false. And finally, when we are having true or true, the output is true. So, however, when we are discussing the OR operator, at least one of them must be true to have an output of true. Okay, at least one of them must be true. So we are having true or false because we are at least having one true, the output is true. False or true, the output is true. False or false, the output is false. And true or true, the output is true. So this is the review of AND and OR operator. Now we are having the A equals true, B equals false, and we would like to check A and B. So true and false. So true and false, the output is false. So the output of this will be false because one of them is true and the other one is false. And in order to have the true answer, we must have both of them as to be true. So now one of them is false. Therefore, the output is false and it is assigned to AND result. Then we are having A or B. We are having A or B, true or false. And this one is like this, true or false, because at least one true is there. So the output is true and it is assigned to OR results. Then we are returning these two values, AND results and OR results. We are assigning to AND value and OR value. And then we are printing the output. And in the output, we see the AND result is false as we expected, and OR result is true. So this is how we can have a function that takes two Boolean values as input and return the and OR logical and or of these two values. Thank you for watching. Welcome back. In today's video, we would like to write a Python function that accepts a string and counts the number of upper and lower case letters. So here is my string, hello world, and I'm calling a function called count upper lower. This is the name of the function, and I'm passing my string as argument. And this is the right hand side. On the left hand side, I'm having two variables. This again shows that we are having a function that is going to return two values. Okay, so when looking at this function, this is my function, this is what's happening inside the function. As we see in the return part, we are having two variables as the return part. So the first one, upper count, is assigned to upper, and the lower count is assigned to lower. And finally, we are printing the upper and lower letters. So in the output, we see for the hello world string, we have two uppercase letters, which is H and W. Then we are having the lowercase letters, which is 8. But how can we do that? So this place is where we call the count upper lower function, and we pass the string as argument. So when this function is called, we are having two variables being initialized. So upper count and lower count, both of them are initialized to be 0. Then we are having a for loop in order to count the uppercase and lowercase letters. We can do it manually, but it's hard, so this is why we use for loops. In order to do that, we are having a for loop iterating over s, which is the argument, which is here the text, and text is holding our string. Okay, so we are iterating over this string character by character. In the first iteration, we are having H. In the second iteration, we are having E. In the third iteration, we are having L, etc. until the end. So in the first iteration, let's say, let me write it here. First iteration, character equals H, okay? And we are checking to see if that H is uppercase letter. Using the isUpper function, we can understand that. If this statement is true, add one value to the upper counter, which was initialized to be 0. So H is an upper letter, so add one value to the upper count. Therefore, the upper count now is 1. Upper count is now 1. Okay, so we continue with the rest of the letters. Now that we want to continue with the rest of the letters, in the second iteration, we are having the char equals to E. Okay, so now char equals to E. Here we check if E is uppercase letter. Is it true? No, it's not, because it's not uppercase letter. It's lowercase. Therefore, this part is not executed. We go here, so we check if E is lowercase letter? Yes, the answer is true. So we are adding the one value to the lower count variable. So lower count is now equal to 1 as well. Okay, so this is the lower count now. So we go for the third iteration. For the third iteration, we are having the char equals to L. Yes? Okay, so char equals to L. We check L, is it uppercase? No. So this part is not executed. L, is it lowercase? Yes. So now that it's lowercase, we are going to add another one value to lower count. So it was initially 1. Now we're going to, initially it was 0, then it was 1, and now we added another one. Now it's 2. And this way we are going to continue the iteration over the remaining characters of this string. Therefore, we are going to keep track of the uppercase letters and lowercase letters. And finally, that we finish the for loop here, we are having the updated upper count variable and lower count. So basically, the upper count should be 2 because we are having only H on W, and the lowercase letter should be 8. So in the end, it will be 8. And finally, we are returning these upper count and lower count variables, which are assigned to upper and lower variables respectively. Finally, we are showing them in the output here. Thank you for watching. Welcome back. In today's video, we would like to write a Python function to check whether a number falls within a given range or not. So here is my number, num equals 10. We are here calling the isInRange function here, and we are passing 3 arguments. First of all, we are passing our number, which is 10, then starting point and ending point of our range. So we would like to see if this num is inside this range or not. And again, I call this function one more time, and I would like to check the same num to be if it's inside this range or not. This is how we're going to proceed with the program. So isInRange function is called with 3 arguments, number, starting point, and ending point. And finally, in this function, we're going to do a work that is very straightforward. We're going to check if this number, which is the first argument, okay, is larger than or equal to the start, which is the second argument, the starting point, and at the same time it is lower than or equal to the ending point, which is the third argument. Okay, so this is going to return either true or false. If this statement is true, meaning that the number is between these two ranges, so it is going to return true for us. If this number is not passing these two conditions, so it means that it's not larger than or equal to start or and lower than or equal to end, it is going to return false. So when I run the code, first of all, we see true. So we are passing number 10, 5, and 15. Basically here we are checking to see if number 10 is lower than or equal to 15, and it is at the same time larger than or equal to 5. This is what we are checking here. Okay, and the answer is true. Indeed, 10 is larger than 5 and lower than 15. So it is going to return true. This is true for us. Then we are having the same number being checked being checked to see if it's between 11 and 20. So here we are saying 11, and this is 10, and this is 20. Okay, so here we check if 10 is larger than 11 and lower than 20. It is lower than 20, but at the same time it must be larger than 11. So it's not, therefore it's not going to return true, so the output is false. It's like AND operator. Both of the conditions must be true to have a true output. For example, we could have another example here is in, for example, 21 and 30. So when I run the code, the answer is false because we check to see if 10 is larger than 21 and lower than 30. Yes, it is lower than 30, but it's not larger than 21. This is why the answer will be false again. So this is basically how we can check to see if a number is actually is falling within a given range or not. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the occurrences of each word in a given sentence. So here is my sentence. Hello world, hello everyone. This is a word of coding. This is my sentence. And in the output, we see hello is being repeated 2 times, word is being repeated 2 times. So hello and hello, word and word is being repeated 2 times. And the rest is being repeated only 1 time. So everyone, this is a of coding. Everything is being repeated once, apart from hello and word. But how can we count that? In order to count that, here I'm creating my string called sentence. I call the count words function and pass sentence as its argument. Then here we are creating a new variable, let's say a new string, and it is assigned to the argument that we passed, and we use the lower function and a split function. So the argument that is passed is my sentence. So this sentence using the is lower is first of all converted to lowercase letters. All of them are converted to lowercase letters. Then we are having the split function to convert this sentence into words. Okay, they are separated now by a space. So we are using the split function to have a list of words instead of having one sentence. This way we can count to see if one number is being one word is being repeated or not. Okay, so first of all we are doing the lowercase. Second of all we are splitting the sentence into words. So this is and then it is assigned to words here. Okay, so now in the words I'm having a list of words, a list of my strings. Okay, and for example, one element is hello, the other one is word. Hello everyone, this is a word of coding. Each of them is a different and unique element in these words. Now we are creating one dictionary called word count. We learned that the dictionaries are having the key value per. So key value per, this is the dictionary logic. For each key, we are having its corresponding value. For example, if we are having the word count, we are having, for example, first key is hello, and its value is 1, for example. It means that for the key hello, we are having its corresponding value 1. And here in the output, for example, we are having the key hello, and its corresponding value is 2. Why? Because 2 represents the number of repetition of hello. So we need to create a dictionary that is created of key value per. So it is going to help us to understand how many times a word is being repeated. So now we are having a for loop. For each word in words here, okay, so word is my iterating variable, words is my variable here. We are iterating through each word of this sentence. So we are, first of all, this is hello, then in the second iteration, my word is word, then in the third iteration it's hello, then it's everyone, etc. Okay, So let me write it down in the first iteration. Word equals hello. Second iteration, word equals word. Then third iteration, it is equal to hello again until the end. Okay, we are going to iterate through each of these words one by one. So in the first iteration now, hello equal word equals hello. We are going to see if this word, which is hello, is in the word count dictionary or not. It's not, because we just created it and it's an empty dictionary. So it's not. This one is false. This part is not executed. Therefore, we are creating the key in the word count dictionary and assign its value to be 1. So our dictionary was empty. Now we are adding the key, which is hello, to the word count dictionary, and its corresponding value is 1 now. Why it is hello? Here is word. Why it is hello? Because in the first iteration, word equals hello. Okay? So this is how. Then we go for the next iteration. In the second iteration, word equals word. So we check to see word, is it in the word count dictionary? No, in my word count dictionary, I just have hello and its corresponding value. So this part is not executed because this part is false. Then we come here. When we come here, we see that, okay, we need to create a new key with its corresponding value. So a new key is our word in the word count dictionary, and its value is 1. So it means that we are going to have word and its corresponding value is 1. Okay. So we are having the iterating variable being inserted as the key, as the next key of the word count dictionary, and its value equals 1. Its value equals 1. Because, and why we are having the word here? Because we are iterating in this, we are in the second iteration, and this word equals word in the second iteration. So we go up back. So we go for the third iteration. The third iteration, we are having the third word, which is hello again. So we check to see if this word is already existing in the word count dictionary. Here, do we have hello? Yes, we have one hello. Okay, we have one hello. So this part is true. And we are going to add one value to the key of the word count dictionary. And what is that key? That key in the third iteration is hello, and hello is already there. So we are adding one value to its value. So value is already 1. We are adding one value, it will become 2. So we are adding one value to the word key, which is in the first iteration hello of the word count dictionary. Okay. So this is how we are having now hello 2. Then we go up. Then the next word is everyone. So everyone, its value is 1. This is, for example, then counted, and then until the word. So when we are having the word again, so we already had one word, we are going to increase this word to 2. And then we are going to continue with the rest of them as this logic. So we learned that in this video, first of all, we lowercase all the letters, and the reason is because if we are having one hello with capital H and one hello with lowercase h, it is going to consider both of them to be equal. So now we are going to lowercase everyone. So this one is also hello now. So the compiler will see them as one similar word. But when we are having one h which is large, which is uppercase, the compiler differentiate this one with this one, because the compiler is sensitive with the capital or small letters. So this is why we had the lowercase. Then we have the split, because we want to split this sentence into words. We assign it to words now. We create a dictionary which is empty. We loop over the words inside the words. For here we check and we remove the punctuation. So whatever that we are having, question mark, comma, the period, etc., all of them are removed, and we are updating the word here. Then we are going to check to see if that specific word in the first iteration, hello, already exists in the word count dictionary or not. So it's no. We are going to insert it for the first time and assign the value 1. Then in the next iteration, when we encounter hello, for example, we see that, okay, hello was already there, and we are going to simply add one value to its value. Now it's 2, etc. So until the end, we can count the number of occurrences of each word in a given sentence. Thank you for watching.
Welcome to this video. In today's video, we would like to write a program that sum all the items in a list. So here is my list. The name of my list is numbers. It has 5 elements: 10, 20, 30, 40, and 50. Here we would like to calculate the sum using the sum of all the items in our list using the sum function. In order to do that, I define a new variable called total. Then it is assigned to be the sum of the list called numbers. So basically, I'm using the sum function to calculate the sum of all the items in the numbers list. And when I run this code, in the output, when we print the total, it's 150. So this is one way to do it. Another way to do it would have been to write a for loop, for example. And using a for loop, we could do that. For example, I'm having a variable called total1 equals 0. And we could say for num in numbers, we could have total1 plus equals num. And then we were printing the value of total1. So when I run the code, we see that the output is the same. So there are two ways to do that. The first one is to simply use the sum function. So this sum function is going to add 10 plus 20 plus 30 plus 40 and plus 50 and assign the output to variable called total. And we print the total in the output here. Or another way to do that is to use a for loop. For example, here, in order to use a for loop, we need to initialize a variable to 0. Then we are having for each num is my iterating variable here. For each num that is in numbers, we are going to add that element to our total1 variable. For example, in the first iteration, num equals 10 because the first element in numbers is 10. Then we are going to have total1 equals total1 plus num. And this means that total1 is initialized to be 0, so it's 0 plus num is 10, so the total1 equals 10. Okay, so this is the first iteration. In the second iteration, num equals 20 because the second element of numbers list is 20 and we are iterating over each element of this. So it is 20 and we are having total1 equals total1 plus num. And we know that from previous iteration, we calculated total1. Total1 is 10. So we are having 10 plus 20. Why 20? So 20 is the num in this iteration, and 10 is the previously calculated total1. So 10 plus 20, it will be total1 equals 30. Then we have num equals 30 in the next iteration. And this means that total1 equals
total1 plus num, meaning that we are going to have 30 plus 30, and we are going to have total1 equals 60 this time. Why 30 plus 30? Because total1 is 30 from the previous iteration, and num is 30 also. So we are having it equals 60. Then we are having num equals 40, meaning that total1 equals total1 plus num, and we are going to have 60 plus 40, so it is 100. Then we are going to have the next iteration, which is 50, num equals 50, so total1 equals 100 plus 50, which is 150 in the end. So we see that we are having 150 in the end. So in order to address this problem, uh, there are uh, there are two methods here that we explained. There may be many methods to address a problem. It depends on you. So the easiest way, I think, is to use the sum function, and simply it is going to do everything itself, and we are assigning it to total, and total is being printed. But otherwise, you can also have a for loop, which is not so hard to be done. For each num that is inside the numbers list, we are adding num to the total1 variable, which is initialized to 0, and then we are printing it out. And we could test it on many different lists. For example, I could have a list, numbers 1, for example. I could have 10, 50, 100, 150, 200. Then here I could have my new total equals sum. What was the name of the list? Yeah, numbers 1. Okay, so we're going to use that. And then we are going to print this message saying that the sum of the second list is, then we are having my new total. So when I run the code, this time we see that the sum of the elements that are inside this list is 510. So this is how we can use the sum function. We could get the same result using a for loop as well. So if I wanted to do a for loop, I could say total2 equals 0. First, this is my variable. Then we are going to have this code, meaning that we are having my iterating variable num iterating over the numbers 1 list. Then in each iteration, we are adding the value of that element to total2, and we are printing it out. So we see that using a for loop, we can also do that. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to multiply all the items in a list. So here is my list. It has 4 elements, 2, 3, 4, and 5. We would like to know what would be the output of this. 2 multiplied by 3 multiplied by 4 multiplied by 5. What is the output of this? Of course, we can do it ourselves manually, but how can we do it using Python? Here, first of all, we are going to initialize a variable to store the product. So it is called product, and it is initialized to 1. We are having the loop that we need to iterate over all the elements of this list. And in each iteration, we are going to multiply that element by the product, okay, which was initialized to be 1. So what we mean here is the following. So in the first iteration, we are going to have num equals 2. So product equals product multiplied by num, meaning that we're going to have 1 multiplied by 2, meaning that product equals 2. Okay, so this is what we're going to get. Why? Because this product multiplied equal num is exactly this formula. So it depends on us. If this is easier for you to follow up, you can simply write this instead of that. They are the same thing. So here I'm having the product equals product multiplied by num. So product is 1 because it is initialized to 1. Then num is 2 because it's the first iteration and the first element in the list called numbers. It's 2, so the product equals 2. Then in the second iteration, we are having num equals 3, meaning that product equals 2 multiplied by 3, which is 6. So why 2 multiplied by 3? Because the formula says product multiplied by num. So product is 2 and num is 3. In the second iteration, num is 3 because it's the second element of the numbers list. So the output of the product is 6 after this iteration. Then we are having the third iteration, and here we are having num equals 6. So product equals 6 multiplied by 6. So we are having 36 as the output here. Why? Because the first number is the product from the last iteration, and the second 6 is the third iteration, which is our value. Sorry, this is number 4. So this place should be 4, and 6 multiplied by 4, it's 24. So here 6 is the last value that we have for the product in the last iteration. So the value for the product variable is 6. We calculated in the previous iteration. So product equals product multiplied by num. So 6 comes from the last iteration of product multiplied by 4. So 4 is my variable num, and it is because it's the third element and we are in the third iteration. And finally, we are having the fourth iteration equals num equals 5 because 5 is the fourth element of the numbers list. And here we are going to have product equals 24 multiplied by 5. And the output of this will be 120. So when we run the code, we see that here, when we calculate this over the iteration, we are assigning everything to product. After the for loop is finished, we have done all the iterations. So we are having the value of updated product, which we expect to have 120 when we calculate it manually. And we see that here, when we are having the product of all items in the list and we're printing product here, it's number 120, exactly what we expected here. And if we have another list, for example, numbers 2, it's like having 1, 5, 10, 20, and we are having a list like this. We are going to have for num in numbers 2, and we are going to have product, for example. Let me initialize another variable, product 1 equals 1. So product 1 multiplied equal to num. Okay, and in the end I'm going to print this value. So the product of the second list is, we're going to have its print, which is product 1. So now I defined a new list called numbers 2. I have a new variable to store the product, which is called product 1. It is initialized to 1. I'm having a for loop over the elements of numbers 2, which is my list. So for each num in the numbers 2, we are going to multiply that element by the product 1 variable. And the output will be stored in product 1, and we are going to show it here. So we see that the output is 1000. And if we do the calculation, we will see that it's correct. Actually, 20 multiplied, So 20 multiplied by 10, the output is 200, and it is multiplied by 5, the output is 1000. So we see that the output is correct. So this is basically how we can have a program in Python to multiply all the items in a list for us. We need to have one variable to be initialized to 1 and a for loop, and in each iteration we are going to have each element being multiplied by this product, and this product in the end is going to have the multiplication of all the elements in our list. Thank you for watching.
Welcome back. In today's video, we would like to write a program that finds the second largest number in a list. So here is my list. It is called numbers and it has certain elements, like 7 elements are there. So we see that one element is 10, 25, 36, 45, 36 again, 25, and 50. So 50 is the largest number, and 35 is the second largest number. So how can I find the second largest number here? In order to do that, I defined a function called second largest. Here, after declaring my list, I'm calling this second largest function and using the argument of my list. So this list called numbers is passed to this function second largest as argument. So in this function, we are having the first line when it is called, the numbers is converted to a set and then again converted to a list. But why do we need to do that? So if you see here, we are having number 36 2 times and we are having number 25 2 times. So we are having duplicates. In order to find the unique list, it is good to remove the duplicates. So here we are talking about the second largest number. When we are having duplicates here, it can provide some problems for us. For example, here is my numbers 2, and just assume that we sorted our list here in descending order, and we are having, for example, 50, 50, 46, 26, and 2. These are the elements of my list called numbers 2. Okay, but there is a problem here. So now if I'm looking to find the second largest number when the list is sorted in the descending order, the second largest number is the second element. Okay, so the first largest number, the largest number is the first element because it is sorted in descending order. You see? So the second element should be the second largest number if we have no duplicates. But because we are having duplicates here, we see that the second largest number, which is 46, is in the third place because we are having a duplicate here. So it's important to remove duplicates in order to avoid any mistakes or problems. This is why we need to first remove the duplicates. So if I remove the duplicates, we see that now the second largest number is the second element. And lists can have duplicates, but one of the features of the sets were the fact that they can only have unique elements. No duplicates are allowed in sets. Therefore, we are converting numbers to sets to remove the duplicates. But because we were working with the list and we would like to continue with working with the list, we are then again converting it to a list. So now if I print these unique numbers, you will see that in this new list, we don't have the duplicates that we are having in the numbers. So when I run the code, you see that 36, 10, 45, 50, and 25. So 25 is only one time repeated there, and also 36, it's only one time is being there. That's it. So you see that here also we removed the duplicates. After removing the duplicates, this is how my list looks like. Now I need to sort this list in descending order in order to find the second largest number.
In order to sort it in descending order, we write down the name of our list, then we use the sort function. In parentheses, we are having reverse equals true. So this is going to help us to sort our list in descending order. And if I print my list one more time here, we see that now this unique numbers list is sorted in descending order. So this was the initial print of my new list with no duplicates. Then it is the version that we are having in descending order. Okay, so in descending order, we are having my list 50, 45, 36, 25, and 10. This is the sorted in descending order. Now we see that the second element is the second largest number in this list. And in order to access that, we are going to simply write down the name of the list and then the index 1, which is representing the second element. Why? Because index 0 is for first element and index 1 is for second element. Okay, so this is how it works. Index 1 is for second element and my second element is 45, which is exactly the second largest number in my list. So basically in this video we learned that we can find the second largest number in a list. And if I'm looking for the third largest number in my list, we can simply write down the index 2, which is representing the element 3, which will be 36. So we see that the second largest number is 36 and the third element here is also 36. Thank you for watching.
Welcome back. In today's video, we would like to write a program that removes all occurrences of a specific element from a list. For example, if you look at here, you will see that I'm having a list here. It is called numbers. So the list called numbers has these elements. You see, 1, 2, 3, 4, 2, 5, 2, 6. And I'm having one specific element that I would like to remove it from this list. And that specific element is 2. So I want to have a new list in which we do not have this number 2 as the elements. So I would like to have a new list which contains 1, 3, 4, 5, 6. Okay. So in order to do that, there are many ways that we can do it. We can write down a for loop to have a new list being created, and if while we are iterating through the list, if the element equals 2, for example, we continue and we skip. So we're not going to insert that into our new list, and that way we can have our list being created. But another way is to use set comprehension. For example, here we are having the call of remove occurrences function, and we are having two arguments, numbers and 2, and it is assigned to an updated list which is later on printed. So the output of this function is going to be assigned to updated list. So remove occurrences function, when it is called, two arguments we are having here. One is the numbers, which is my list name. Then the element that we want to remove it. So this is my target element, number 2. So in this function, we are having two arguments, my list and the target. Here, this function is going to return for each item that is in my list. If that item is not equal to my target, which is number 2, we assign it to my new list here. So this is a set comprehension. So we are having the creation of a new list, and for each item that is in my list, which is the numbers, if that item, the iterating variable, is not equal to the target, which is number 2, then assign it to my new list. So this way, for example, item in the first iteration can be
is actually 1. So 1 is not equal to 2 because target is the second element and second element is 2, second argument, let's say, or parameter. So 1 is not equal to target. Yes, it's true. So assign it to my new list. So my new list, let's say, new list equals 1 now. Then in the next iteration, item is 2 because it's the second element. So in the second iteration, we are having the second element. So 2 equals target is 2. So it is not equal to target. This is what it is asking. 2 is not equal to 2. So it is basically saying item is not equal to target. And we know that in this case, the item is 2. Here, the item is 2 because we are in the second iteration. So the item now is 2. But we see that the target is always 2 because we didn't change it. So target equals 2. And we are checking to see if 2 is not equal to 2. And so this is false. 2 equals to 2. Therefore, we are not going to assign it to our new list. So our new list remains the same. Okay, so we are saying for if 2 is not equal to 2, then assign it to my list. If it is equal, do nothing. Basically, the set comprehension is doing like that. So we go for the next iteration now, item equals 3. So we say 3 is not equal to 2. It's true, then assign it to my new list. So my new list is now having the 3. Then item equals 4. So we see 4 is not equal to 2. It's true, therefore insert 4 as well. And in the next iteration, item equals 2. 2 equals 2. So it's not going to be inserted here because 2, we are checking 2 is not equal to 2. And this statement is not true. Therefore, we are not going to insert anything. Then we are having number 5 in the next iteration. 5 is not equal to 2. It's true, so add it. Then 2 is not equal to 2 again, so I'm not going to add 2. Then we are having 6. 6 is not equal to 2, therefore we are going to add it. So this way we created our new list. So this function actually is going to create my new list and return it. And the output of this function is assigned to updated list. So this is my updated list, which is a list that contains these elements. And basically here we are simply printing this list. So the updated list is 1, 3, 4, 5, and 6. 1, 3, 4, 5, and 6, and 5 and 6. So this is exactly what I expected. But now the target was 2. So what if the target is 5? So it means that I want to create a new list without having number 5 in it. So when I run the code, we see that now 1, 2, 3, 4, 2, 2, and 6. So 5 has been not considered to be inserted in my updated list, but number 2 has no problems now because I chose simply to remove number 5. And if I wanted to have number 1 as the target element to be removed, so when I run, we see that number 1 is not there anymore. Basically, this is how we can remove all occurrences of a specific element from a list. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get the largest number from a list. So here is my list. As you see here, the list contains these elements. So there are 6 elements in this list: 10, 25, 78, 45, 89, and 23. So when I run this code, we see that it says the largest number in the list is 89. So basically, here we are finding the maximum number in the list. And this is what we wanted to do. But how can we do it in Python? So there is a built-in function in Python that is called max And this function can help us to find the maximum number. We are having the max, and in parentheses, we are having numbers. So we are having our list being in the parentheses. So this max function is going to find the maximum number that is there in the list numbers. And then it is assigned to largest variable. So variable is called largest, and that max number that is found from this numbers list is going to be assigned to the largest. And basically here the largest number is 89. So 89 is assigned to this variable, and then 89 is being printed here. So this is the easiest way to do it. However, there are other methods that we can do this. So another method that we can think of is the following. So here I am having my list called numbers being converted to a set. So if there is any duplicate, it is going to be removed. Then it is going to be assigned to, it is going to be converted to another list again, because we were working with a list. We would like to keep it with list. And this is going to be assigned to my new list. Okay. So now why did I do that? So this way, because sets are having this feature that they cannot have duplicates, and it's very important. Because, for example, we are having a list, and this list is having, for example, number 20, 20, 13, 15, and these are my numbers. And usually when we are having a set, we are not going to have a duplicate. So it's one of the features. They are not going to allow you to have duplicates. So now if I want to find the second largest number in my list, it should be, when I sorted it in descending order, it should be the second element. But because I'm having duplicates, there is a problem there. So duplicates should be removed before finding any numbers in my list. If I'm looking for the third smallest element or the fourth largest element, etc., duplicates must be removed. So now I see that the second element is the second largest number, for example. No, because now it's not sorted. We need to first sort it as well. So now I would have the sorted list, and now it is equal to 20, 15, and 30. So we see that now the second element, after removing the duplicates and then sorting it, we see that here we are having the second element being the second largest element in this list. So it's important, if you are looking for the third largest number or second smallest number in a list, it's very important to first remove the duplicates and then sort it. And in order to remove the duplicates, the easiest way is to convert it to a set, because sets cannot have duplicates, and then convert it back to lists and assign it to a new list. So now my new list is called my new list. This is the name. And if I print my new list here, when I have my new list, for example, in the print, so if I print it here, so let me comment these parts. So you see that this is my new list, and this list has no duplicates. Actually, the original list here was not having any duplicates, but I can have these duplicates. So I'm having 223. So there is a duplicates here, and I'm having 2 number 1. So if I run the code, you see that 23 is only there one time, and number 1 is also there only one time, and it's not repeated anymore. Okay, so duplicates are now removed. This is the print of my new list after converting it to set and then converting it back to list. So duplicates are automatically removed. Then because I'm looking for finding the maximum number, I need to sort it in descending order. And now that I'm sorting it in descending order, in order to do that, first I write down my name, then the sort function is called. So in the parentheses, I'm having reverse equals true, meaning that it is going to sort the list for me. So now if I print one more time my list, Here you see that after sorting, we are having 89, 78, 45, etc. until the end. So it's sorted in descending order. And finally, if I'm looking for the maximum number, so we are here looking for the largest number in the list. Here, we can write down the name of our list and index 0, because index 0 represents the first element, and because we are having a sorted list in descending order with no duplicates, the first element is the largest element. So when I run the code, you see that number 89 is being printed in the output. But if I was looking for the second largest element, I could simply write down index 1 here. And because we already removed everything, the duplicates, we shouldn't be worried about it. So 78 is there. So if I write down number 2, it's going to give me the third largest number, which is 45, which we see here. So this is how we can find the largest number in a list, or any other largest number, for example, the second largest, the third largest, etc. And if in case you're looking for the smallest number, you can simply use the -1. It is the last element in our list, and because we are having a list in descending order with no duplicates, the last element is going to be the smallest element. So -1, if you write it down, you're going to have the smallest number. If you write down, for example, -2, you're going to have the second smallest number. You see number 10 is being printed in the output. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the number of strings from a given list. For example, the criteria is to have the first and last characters to be the same. For example, here I'm having a list of strings. Here are my elements. A, B, C. This is my first string. So the first character is A, the last character is C, and they are not equal. So A is not equal to C. So this is not something that I'm looking for. Again, here, X, Y, Z. X is the first character, Z is the last character, and they are not equal. So this is not also what I'm looking for. But here I'm having A, B, A. So the first element is A, the last element is A, and the first element equals the last element. So this is what I'm looking for. Okay, so I would like to count the number of strings that are having the first and last characters to be the same. So this is the first one, this is the second one, and this is the third one. And in the output, we see that there are 3 strings in my list that are having the first and last characters to be the same. So this is what I'm looking for. When I run the code, I would like to get this number. So number of strings meeting the condition is 3, and 3 is meaning that I'm having 3 elements in my list that are a string, and their first character and last characters are the same. So 1, 1, M, M. Okay. In order to write that, first of all, I need to initialize a counter. So my counter equals 0. Then we need to loop through our list, which is called words, and my iterating variable is word. So here I'm having the iterating variable word for each word that is in my list called words. If the first element and the last element are equal, okay, if both of them are equal, increase the value of count by 1. So count equals 0 initially, it is going to increase this value. And finally, we're going to print this count in the output. So if I want to show you the indexing here, this is my list, and this is having index 0, this is having index 1, index 2, index 3, index 4, and index 5, okay? Then I'm having the reverse indexing as well. So we can call this -1, -2, -3, -4, -5, and -6. So this is also the indexing if I start from right. In Python, we can have that. So this last string could either be called with index 5 or it could be called by index -1. The same thing with the first element. So it is the index 0 or -6. Okay, but when we are looking from left to right, it's not easy to understand that, okay, this one is -6 or -5, etc. So index 0 is the best way to understand the first element and to print the first element, for example. So whenever we are dealing with the first element, we are going to use the index 0, and whenever we are working with the last element, simply we are going to use the -1 index. And why did I mention that? Because now here we are checking this condition. So if the first element, this 0, equals the last element, you please increment the value of 1. And here, this is the indexing of my elements in my string. But what I am actually looking for is the indexing in each individual string. So in this string, we are having 1, 2, 3. So 0 is the index of A, 1 is the index of B, and 2 is the index of C. Similarly to the above rule that I just explained, we can have -1 for the C, -2 for B, and -3 for A. Okay, so A could have the index 0 or -3. C also could have the index 2 or -1. And based on this law that I just explained to you, we could have the call for the first element simply using the index 0 and the last element to have -1. Okay, so here when we are iterating over each string, so here word in the first iteration equals word equals ABC. Okay, and we are checking to see if A equals C. So the answer is no. The answer is no. So it's not going to increment the count. Okay. In the next iteration, word equals XYZ. If X equals Z, the answer is again no. Then we are having word equals ABA. If A equals A, so the answer is no. Word equals 1221. If, sorry, here the answer was yes. I made a mistake, sorry. So here we are saying that the word equals ABA, and we are saying if A equals A, so yes, because this condition is true, this condition is true, we are going to increase the value of count. So now count equals 1, okay? So count equals 1 now. Then we are having this next, in the next iteration, the word equals 1221, and we are checking to see if 1 equals 1, and the answer is yes. So because the answer is yes, this statement is true, and then we are going to increment the value of count. So now count equals 2. Then in the next iteration, we are having word equals hello if H equals O. The answer is no, so they're not equal, so we're not going to do anything. We go for the next iteration. And finally, word equals mom, and we are checking to see if M equals M. So the answer is yes. Because the answer is yes, we are going to increase the counter one more time. So now the counter equals 3, and we reach the end of our list. So we iterated through all the elements, and finally here we are going to print this message, number of a string meeting the condition. This is exactly what is being printed here, and we are having the count, which is here. Okay, so it's 3. If I add another element, for example here, for example RSH, we see that there should be again the same number of repetition. The count is 3 because here the first element R and the last element H, they're not equal. But if I have, for example, oops, sorry. So if I have, for example, R, H, R, for example, now I expect to see this to be 4 because we added another element to the end of my list, and it has R as the first element and R as the last element. Therefore, they are equal when we are iterating and we are incrementing the value of count, so it will become 4. Basically, this is how we can understand how many string in my list of a string are there that are having the first element and last element to be equal to each other. Thank you for watching.
Welcome back. In today's video, we would like to write a Python program to remove duplicates from a list. So here is my list called numbers. We are having 1, 2, 3, 4, 2, 5, 1, 6, 3, and 7. As you see in my list, there are some duplicates. For example, number 3 is repeated 2 times. Number 2 is repeated 2 times, for example. Number 1 is repeated 2 times. And yes, these are the duplicates. These are the only duplicates that we have. But we would like to remove the duplicates. Well, how can we do that? So the first way to do that is to simply convert my list to a set, and then from a set back to a list. Okay, so one of the feature of sets is that they do not allow duplicates, and they do not allow to have, for example, 2 elements with number 2. And you cannot have this in a set. For example, you cannot have these many number 2s. You can only have unique values. You can have number 2 but one time only. That's it. So in order to benefit and profit from this feature, we can simply convert our list to a set. So automatically the duplicates are removed, and then convert it back to a list again here and assign it to a new list called unique numbers. This is the new name of my list, which contains the unique elements of the numbers list. And here I'm printing it out. So print list after removing duplicates, and we're printing the unique numbers. So when I run, you see that this new list is exactly this one without duplicates. So we see that number 1 is only there one time, number 2 the same, 3, 4, 5, 6, and 7. So we have no duplicates. So the easiest way to remove duplicates from a list is to simply convert it to a set and then convert it back to a list. But there is another way to do it. So let me comment this part. The second way to do that is the following. Here is my list. Okay, so you see that it's the same list. I'm having a list called numbers with the same elements here. Okay, now I am initializing an empty list to store only the unique elements of my numbers list. Okay, I say it one more time. Here I am initializing an empty list. You see it's empty, to store the unique elements of the numbers list. So if there is any duplicates, I'm not going to insert into my new list called unique numbers. Only the unique elements are inserted. But how can we do that? We need a for loop. We are going to loop through the original list, which is called numbers, and then in each iteration we are checking to see if that number is already inserted in the unique numbers or not. If not, we are going to append it. Otherwise, we're not going to do it. So let me illustrate it with an example here. Here we are checking, we are iterating for each number in numbers list. So in the first iteration, for example, num equals
1 because the first element is 1, for example. We are checking to see if 1 is not in unique numbers. Because it was empty, it was not. So 1 is not already existing in the unique numbers because it is empty. So now that it's empty, and number 1 is not already there, we are going to take that number and append it to my unique numbers. So now the unique numbers has been updated and it has the number 1. Okay. In the next iteration, num equals 2. Num is not in unique numbers. Is it true? Yes, because it only has one element and that is 1. Now that it's true, append that number to my unique numbers list here. Okay. In the next iteration, we are having the number 3. So in the next iteration, we are having number 3. Number 3, we are checking if it's not already in the unique numbers. This is my unique numbers. Number 3 is not there. So I'm going to append it as well. So we are going to append that number into my unique numbers list. And then we are having the next iteration. In the next iteration, we are having num equals 4. So num equals 4 here. We are saying that 4 is not in unique numbers. And unique numbers is having 1, 2, 3. And it's not having 4. So we can append that. So we are going to append number 4 into unique numbers. Okay. Then in the next iteration, we are having number 2 again. So number 2, now num equals 2. So we are saying 2 is not in unique numbers. Is it true? No, it's not true because it's already there. Therefore, this condition is not true and we are not going to execute this part. We are going to for the next iteration. Now num equals 5. Now num equals 5. We are having 5 is not in unique numbers. Is it true? Yes, 5 is not there actually. So I'm going to add 5, appending 5 here. Then in the next iteration, I'm having element 1. Element 1 is there. 1 is not in unique numbers. This is unique numbers. Is it true? No, it's not true because 1 is already there. So because this condition is not true, we are not going to execute this part. We're going to go for the next iteration. Now element 6. So num equals 6. We are checking 6 is not in unique numbers. Unique numbers. Yes, it's not having the number 6. So we are going to append number 6 into the unique numbers. Okay. The next element is number 3. We are going to have num equals 3. So 3 is not in unique numbers. 3 is not in unique numbers. Is it true? No, it's not true because we already appended number 3. So we are not going to insert that. So because this condition is not true, because 3 is not in unique numbers, this is what it says, but it's not true because 3 is already there. Therefore, we are not going to execute this part. We are going for the next iteration. In the next iteration, the num equals 7. And here we are checking to see if num is not in unique numbers. So 7 is not in unique numbers. Yes, this statement is true. We are going to write down 7 there and we are going to append 7 into the unique numbers here. So this is my unique numbers list that I created here. And as you see, when I run the output, that after this for loop is having, so after this for loop is finished, the unique numbers list is updated like this, and simply we are having the list after removing duplicates and we are printing it 1, 2, 3 until 7, and this is what we expected, 1 until 7, 1 to 7. So this is how actually we can create a new list using by removing the duplicates using for loops. But the easier way, the easier method, as I mentioned there, was to use the conversion to set and conversion back to list. But this is another method that it's good to know about. So you can use for loops and use if conditions to only append the unique elements. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to print the numbers of a specified list after removing even numbers from it. So here is my list.
it has these elements. See 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we are intending to remove the even numbers. So in order to remove even numbers, we can simply use the list comprehension to filter out the even numbers. So here we are saying that for each num that is in the numbers, okay, if num is divided by 2 and the remainder of this division is not equal to 0, we're going to create a new list called filtered numbers. Okay, so in each iteration, basically what is happening here is that it says, for example, num in the first iteration equals 1. It says num if it's divided by 2, the division, the remainder of this division is not equal to 0. Is it true? Yes. So add it to filtered numbers. So filtered numbers is having number 1. So before discussing that, we know that the definition even number. A number is even only if it is divided by 2 and the remainder of this division equals 0. This is a definition of even number. If it's not true, that number is odd. So if a number is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Otherwise, it's an odd number. Okay, and in order to find the remainder of a division, we are going to use the modulo operator. So in the first iteration, number 1, if it's divided by 2, the remainder is not equal to 0. Yes, it's true. Therefore, we are going to add that number into the filtered numbers. Okay, and 1 is there actually when we are printing the filtered numbers. In the next iteration, num equals 2 because the next element is 2. So we are checking to see if 2 is divided by 2, the remainder is not equal to 0. It's not true because when 2 is divided by 2, the remainder equals 0. Therefore, 2 is not going to be inserted in the filtered numbers. Okay. Then we are having the next element, which is 3 in the next iteration because we are having a for loop here. Yeah. So in the next iteration, we are saying 3, if it's divided by 2, the remainder is not equal to 0. Is it true? Yes, it's true. Therefore, add that to the filtered numbers. And we see that in the end, when we are printing it out, we see number 3 there. Then the next element is 4. 4, if it's divided by 2, the remainder of this division is not equal to 0. Is it true? No, it's not true. 4, if it's divided by 2, the remainder is 0 indeed. So it's not going to pass this condition. Therefore, it's not going to be inserted into the filtered numbers. You see that 4 is not there. In the next iteration, we are having number 5. Number 5 is there. So we are checking to see if 5 is divided by 2, its remainder is not equal to 0. The remainder of this division is not equal to 0. Yes, that is true. Therefore, 5 is added to filtered numbers. Okay. Then the next element, because we are having, I'm saying that the next element because we're in this for loop. Okay. So for each num in the numbers, and this num is my iterating variable. So it is going to start from 0 here. Start from here with element 1 and it is going to continue up until 10. So it is iterating through these numbers. So now num equals 6. 6, if it's divided by 2, it's not equal, the remainder of this division is not equal to 0. Is it true? No, it's not true. This sentence is not true. This sentence is wrong. Therefore, 6 is not entered into the filtered numbers because 6 is divided by 2. The remainder is 0. So when 6 is divided by 2, the output is 3. Okay, the output of this division is 3. But when the remainder of 6 divided by 2, it is equal to 0. Okay, this is the output. So here, after that, we are going to iterate again over the next element, 7. 7, if it's divided by 2, the remainder is not equal to 0. Yes, it's true because the remainder of 7 divided by 2 is 1. So therefore, this statement is true. So it is inserted in the filtered numbers, you see.
Then for number 8, 8 is if it's divided by 2, the remainder is not equal to 0. It's wrong. It is indeed equals to 0. Therefore, it's not going to be added to the filtered numbers. And finally, here for the last element that will be inserted in the filtered numbers, 9, if it's divided by 2, the remainder of this division is not equal to 0. Yes, it's true. So filtered numbers is number 9 is added to the filtered numbers. Finally, number 10 there, if it's divided by 2, the remainder of this division is not equal to 0. It is not correct. So indeed, the remainder of this division equals 0. Therefore, 10 is not added to the filtered numbers. And we see that we don't have it here. So in this video, we learned that we can write a Python program to print numbers of a specific list after removing even numbers from it. So this is how we filtered the even numbers from the original list, and we created our new list called filtered numbers, and the filtered numbers is being printed here in the output. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to multiply all the items in a dictionary. So here is my dictionary called NumDictionary. We see that here in dictionary, as we remember, we were having key value pairs. So here the key is A, the value is 2, the key is B, value is 3, the key is C, the value is 4, and the key is D and the value is 5. So we would like to multiply all the values here. So 5 multiplied by 4, multiplied by 3, and multiplied by 2. So 5 multiplied by 4, it's 20. 20 multiplied by 3, it's 60. Multiplied by 2, it will become 120. So when we run the code, we see 120 in the output. But how can we do that? First of all, in order to do that, we are initializing a variable called product to 1. Now that we are initializing product to 1, we are having a for loop and we are iterating over the values of this dictionary. Okay, only the values. And in order to iterate through the values, I write a for loop. So value is my iterating variable. For each value in the dictionary, NumDictionary, we use the values function. So whenever we want to access the values of a dictionary, we should write down the name of the dictionary dot values. Okay, so here it is possible now for us to access the values that are inside this dictionary. So now we are having an iterating variable that is iterating over the values of my dictionary. Okay, and the values are 2, 3, 4, and 5. And in each iteration, that iterating variable is added to the product. So it is multiplied by product and it is added to the product. So for example, in the first iteration, so first of all, we are having this. So product star equal value. It's the same as this one. Okay. Product equals product multiplied by value. Okay. They are the same. Okay. So in the first iteration, value equals 2. Why? This is value, my iterating variable. In the first iteration, it takes the first value, okay, in the dictionary, and it is equal to 2. Therefore, we are going to have product multiplied by value. So product is 1 multiplied by 2. The result is 2. So the formula is this one. Product equals product multiplied by value. So product is 1 because we initialize it to be 1. And then value is 2, and we see that number 2 is the value because we are in the first iteration and the first value in the dictionary is 2. So 2 multiplied by 1 is 2. Then we are having the second iteration. So value equals 3. We are going to have 2 multiplied by 3. Okay. So why 2 multiplied by 3? Because we are having product multiplied by value. So 2 is the product number, which is here, and 3 is the value in the second iteration. In the second iteration, we are having the second value there. So it means that 2 multiplied by 3, it is 6. Okay. Then we are going to have the third iteration. So value equals 4 now. Why? Because we are in the third iteration and the third value in my dictionary is 4. So 4, we are having it here. So 6 multiplied by 4, we are going to have 24. Okay, 6 comes from the product multiplied by value. So 6 comes from the product in the previous iteration, and 4 comes from the value that we are having in the third iteration, and this is the value, so it will become 24. And finally, in the fourth iteration, we are having value equals 5. Why? Because we are in the fourth iteration and the fourth value is 5. So first value, second value, third value, and the fourth value. And therefore, we are going to have 24 multiplied by 5, and it will be 120. So we had an iterating variable iterating over all the values of this dictionary, and in each iteration it was multiplying that value by the product. Initially the product was 1, but in each iteration we were updating the product. So then it became 2, 6, 24, and finally 120. So 120 is stored in the variable called product here, and here we are printing the product. So we are saying that print, we are using the print function, the product of all values in the dictionary is, then we are typing down the name of the variable product, which is 120. So this is how we can compute the multiplication of all the items in a dictionary. This is one way. Also, there is another way to do so. So let me comment this part. So in order to do that in an easier way, we can do this. So let me comment this part also. Okay. So another way to do that is this. So first of all, we are going to import the math library because we are going to use some of the functions. So here is my dictionary. It's the same dictionary. It's A2, A with 2, A2, B3, C4, and D5, as you see here. So there, it's an exact same dictionary. Instead of having a for loop here to calculate the multiplication of all the values in my dictionary, there is another easier way to do that. We can use the product function. So if we want to use the product function, we are going to import the math library. So we are going to write down math.product, meaning that call the product function from the math library. Then in parentheses, we are going to write down this. So name of the dictionary dot values. Values meaning that we are going to have access to the values associated to this dictionary. And these are the values of my dictionary. You remember we said that in dictionaries we are having key value per. Okay. So key, its value, key value, key value, key value. So we are going to access the values of the dictionary called numDictionary, and we are going to call the product function from the math library to calculate the multiplication of all the values in this dictionary, and the output of this is assigned to product. Then we are printing the product. So if I run the code, we see exactly the same number in the output. So it's easier to use this built-in function if you find it interesting. Otherwise, you can of course use the for loop in order to have your calculation. So it depends on you. If you find this method more interesting, you can use this one. Otherwise, you can use this method. But remember that you need to import the library math. Thank you for watching. Welcome back. In today's video, we would like to write a program that finds the key with maximum value in a dictionary. So here is my dictionary. It is called scores. We see that in my dictionary, as always, we are having key value pairs. Okay, so this is one pair, this is another, this is another pair, this is another pair, and this is another pair. Okay, so Alice is my first key. Its associated value is 85, Bob 92, Charlie 88, and David 76. So this is my dictionary that has 4 key value pairs. My aim in this coding exercise is to find the maximum value in the dictionary. So you see that these are the values: 85, 92, 88, and 76. I would like to find the key that corresponds to the maximum value in the dictionary, and the key is Bob. Okay, so this is the maximum value. I would like to print its key, which is Bob here. Okay, so how can we do that? In order to do that, I'm creating a variable here called highest scorer, and then it is assigned to the call of function max value key, and as the argument I am passing the dictionary. So dictionary is passed as a dictionary to call max value key function. This max value key function is called and it is initialized and created using the def keyword, and it has one argument, which is the dictionary here that we have. We call it in the dictionary, we call it data. So this function is going to find the maximum value of this dictionary and return its key for us. How? We need to use the max function. So in order to do that, we use the max function. And in parentheses, first of all, we are having the name of the dictionary, and we call it here data. We can call it whatever. It can be data, data2, my data, my dictionary, anything. It's your choice. So we are going to use the max function, and we are going to call this max function with 2 arguments. The first one is the name of the dictionary, and the second one is this key equals data.get. So we are going to get the key, the maximum key of the data dictionary. Okay, so we are going to get the maximum key in the data dictionary. Okay, so this is how this max function is going to work. And then it is going to return us the key. For example, here the maximum key, the maximum value is 92, and it is going to first of all find the maximum value in this dictionary, which is 92, and here we are going to say the maximum value is 92, get me the key to this 92, and it is going to return Bob, and Bob is returned as the output of this function, and the output of this function is assigned to highest scorer, and here we are printing it out. So person with highest score, it's highest scorer. So highest scorer is being printed here, and we see that Bob is the highest scorer. But if I have, for example, Charlie to have the score of 100, and when I run the code one more time, we see that person with highest score, it is Charlie. Why? Because now the highest value in this dictionary is 100, and we are going to get the corresponding key to the maximum, we are going to get the maximum value, finding the maximum value, and return the key that is associated with the data dictionary. Okay, and basically we are first of all finding this 100, and it is going to return us Charlie, its associated key, and Charlie is returned. Therefore the output of this function, when we are calling it using this dictionary, is scores, is we are calling the max value dictionary and passing scores as the argument, and the output of this is assigned to highest scorer, and highest scorer is being printed out here in the output. So if I have another function here, another dictionary, for example, if I call it scores2. Oh, so here Reza is, for example, 92. Bob is still there. Bob is 90. Charlie is still there. Charlie is 67, for example, and David is there. And David is, for example, this time 80. So here, who is the person who has the highest value? So Reza is the one who is having the highest value. Okay. Now I would like to call the max value key function, but pass this scores2 dictionary and not the first dictionary. Okay, now I'm calling the function using the scores2 dictionary. So if I run the code, we see that now the answer is Reza, because now I am calling this function using this dictionary, which is scores2. And you can have many different dictionaries, and you can have different calls for the dictionary. Now I can have, for example, dictionary number 3, where, for example, David has, for example, 99, the score of 99. And here I am calling the function using the score3, and I am calling it highest score3. So here, highest score3 in the third dictionary. So if I run the code, you see that we are having David being printed because we are having a third dictionary in which David has the highest value, and we are calling the max value function with this dictionary and assigning it to highest scorer 3 variable, and this variable is being printed out here. So the person with the highest score in the third dictionary is David, because David has 99. So basically in this video we learned how we can find the key with the maximum value in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a program that merges two dictionaries. If a key exists in both, sum their values. So here is my first dictionary. It has 3 key value pairs. Key A has value 100, key B has value 200, and key C has value 300. Then we are having the dictionary 2, has 3 again key value pairs. Key B has the value of 100, key C has the value of 50, and key D has the value of 400. Now we see that here it says if key exists in both, sum their values. So now we would like to create a third dictionary in which, for example, here dictionary 3, we would like to have a third dictionary in which we are having A, it's 100. We are having B, it's 350. Why? Because we are having B here and here, and the program says if key exists in both, sum their values. So it's 200 and 150, so it will be 350. So, and then we are going to have C, which is 300 in the first dictionary and 50 in the second dictionary, so it will become 350. And finally, we are having D, we are having D, which is 400. Okay, so we would like to create a third dictionary merging these two dictionaries. And if one key exists in both of them, we are going to sum their values. But how can we do that? Manually, of course, we can do it very easily. But how can we do it using Python? In order to do that, we are having a function called merge dictionary, and we are passing two arguments. first dictionary and the second dictionary. And what we are doing here is the following. When this function is called, first of all, we are copying everything of the first dictionary into a new dictionary called merged. Okay, so here we are creating a dictionary called merged, and it has all the values of the first dictionary. So we copied everything there. Okay, so and now I created the merged dictionary. Now the main part is here. So we are going to have two iterating variables, key and value. We are iterating through the items of the second dictionary. And we know that when we are using the items function, it means that we are going both through the key and values. So this key is iterating over the keys of the second dictionary, and this value is iterating over their corresponding values in the second dictionary. Okay, so now we are having two iterating variables. We are iterating over all the key value pairs of the second dictionary using the items function. Now when we enter this loop, we are going to check and see if the key is already inside the merged dictionary, which we created here. If this is true, get the value of that key from the merged dictionary and add the value of the same key from the dictionary too. What do I mean? So here, let me illustrate it with an example. In the first iteration, key equals B, value equals 150. Do we agree? Why? Because key and value, they are iterating over the second dictionary. Okay, second dictionary is this one, and here we are having the key value pair. So the first key and the first value are B and 150. So we are having in the first iteration key equals B, value equals 150. Okay, this is the first iteration. And here we check to see if we already have that key, which is B, in the merged dictionary. Do we have it here? Yes, we are having it here. Okay, so now that we are having it already here, get this 200 value for the key B, which is here, from the merged dictionary. Okay, so get that 200 and add it. So we're going to have 200 plus, add it to the value, which is 150. Okay, which is 150. Now, by doing this, the value of the key B, okay, which is B here in the first iteration, in the merged dictionary is updated. Now it is 350. Okay, so in the second iteration, what is happening here? Second iteration, the key equals C, value equals 50. Yes, do we agree on that? So in the second iteration, we are having two iterating variables, key and value. Key equals C. Why? Because the second pair in the dictionary 2 is C and 50. So key is C and its value is 50. Okay. Now, what we are doing here is the following. We are checking to see if the key, which is C, already exists in the merged dictionary or not. Yes, already exists because we are already having a key C there. So now that it exists, get the value of that key from the merged dictionary, okay, and add it to the value, which is 50. So we are going to have 300 plus 50. Okay, so we are going to use the get function to find the value of that key from the merged dictionary and add it to the value, which is the value from the same key in the second dictionary, and all of that is assigned to the same key of the merged dictionary. Okay, and the merged dictionary is this one, and the key is C. So basically, this get function is getting the value of the key C from the merged dictionary, which is 300. So this part, and add it, okay, and add it to the value, and value is 50. Okay, so 300 plus 50, it will be 350. Okay, so it will be 350. Now it is going to be updated on 350. And in the last iteration, so third iteration, we are having key equals D, value equals 400. So here in the dictionary 2, in the last iteration, the last pair is D400. So D400. Okay. So we are having here, we are checking to see if we are having this key, which is D, in the merged dictionary. Do we have it here? No. Now that we don't have it here, we are going to by default assign number 0. This is why we are having it 0. So if that key exists in the merged dictionary, we are going to return the value. Otherwise, we are going to return 0. So in the previous iteration, if you remember, we were discussing the key C. So key C, was it existing already in the merged dictionary? Yes. So return its value. So it was 300 plus the 350. So it was 300 and it added to 50. So it became 350 that we updated here. Okay. But if we are investigating a key that already is not existing in the merged dictionary, using the get function, we are going to assign number 0 by default. This is why we are having number 0 here. So we use the get function to get the value of that key, which is D here, from the merged dictionary. Because it's not there, we don't have the key called D, we are returning 0. And we are therefore adding 0 plus 400, which is the value of the key D in the second dictionary. In the second dictionary, the value is 400. Okay. So therefore, we are having a new key being created, D, with the value 400. So 400 plus 0 is assigned to the key D in the merged dictionary. Okay, so we created a new pair here, the merged D, and here we were getting the value of that key from the merged dictionary. Because we were not having that key, we returned 0. And basically this is how the get function works, and we added to the value, which was 400. So now we added the last pair as well. So this function, basically using one line in the for loop, we could complete the merged dictionary. And finally, in the end, after this for loop is finished, this function is going to return the merged dictionary. And the output of this function, when it is called, is the merged dictionary, and it is assigned to the variable called result. So result is my new dictionary. That is the output of the merged dictionary function, and we are here printing out the results. So merged dictionary, and here exactly what we expected. So A is 100 because A is only there in the first dictionary. D is 400 because D is there. And B is 200 plus 150. It's 350. C is 300 and this is 50. So this is 350. So this is how we could write a program that merges two dictionaries, and if a key exists in both, we are going to sum their values. So this function was there to help us doing so. First of all, we copied the first dictionary in the merged dictionary, and then we iterated over the key and values in the second dictionary, and we added them to the merged dictionary. In each iteration, we updated it. Thank you for watching.
Welcome back. In today's video, we would like to write a program that removes keys with a specified value from a dictionary. So here is my dictionary. It is called products and it has 4 key value pairs. The first key is apple. Its value is 50. The first key is banana. Its value is 0. The second key is banana, sorry, and its value is 0. The third key is cherry. Its value is 75, and the fourth key, sorry, is date, and its value is 0. So this is my dictionary. Now I would like to create a new dictionary from this dictionary and remove the key value pairs when a value has the value of 0. So we see that here banana and date are having value 0. I would like to simply remove them because they are equal to 0. I don't want to have them, and I would like to update my dictionary with only having the keys that are having some value, some meaningful value. So the filtered dictionary is apple 50 and cherry 75. Apple 50 and cherry 75. So these two are removed. How can we do that? In order to do that, I call a function called remove keys with value, and 2 arguments are passed. So the first one is my dictionary and the second one is 0 because I would like to remove any keys that has a value of 0. This is why I'm passing 0 there. Then in this dictionary, as we mentioned, we are having 2 arguments, data and target value. So data is the name of my dictionary in this function. We can name it as we want. And target value is number 0 that I don't want to have keys with this value. So here we are using the dictionary comprehension. So we are saying that create a new key value dictionary for me for each key and value that is inside the data dictionary, which is my product dictionary. And in the function, simply I call it data because it's the first argument. And we see that the first argument for the call is product dictionary. So we see that this is the dictionary. So for each key and value in the data dictionary that we are iterating using the items function, meaning that we are iterating over the key and value. So the key is going to iterate over the keys and value is going to iterate over the values. Okay, so for each key and values that are in the data dictionary, if the value is not equal to the target value, then insert it into my new dictionary, meaning that in the first iteration, key is apple. Okay, in the first iteration, key is apple, and its value is, let me write value, its value is 50. So key is apple, value is 50. We are saying that if value, which is 50, is not equal to the target value, what is that number? It's 0, the second argument, okay? So 50 is not equal to 0. Yes, it's true. Therefore, insert it to my dictionary, okay? Key value. So apple and 50 is added to the dictionary. So we are having apple and 50. Then in the next iteration, we are having the key equals to banana and the value equals 0. So now we are saying if value is not equal to the target value, the value is 0, the target value is also 0. 0 is not equal to 0. Is it true? No, this statement is not true. Therefore, we are not going to insert this key and value pair to my dictionary. So we go for the next iteration. In the next iteration, the key is cherry and the value is 75. Okay. So we say key is cherry and value is 75 in the next iteration. We check the if 75 is not equal to 0. Is it true? Yes, it's true. 75 is not equal to 0. Therefore, insert them into my dictionary, key and value. So now I'm adding cherry with the value 75. So this is the next one. And in the next iteration, the key is date now because this is the next iteration. So it is date. And its value is 0. So in the next iteration, we check the 0 is not equal to 0. Is it true? No, it's not true. 0 equals 0. So we're not going to, because it's not true, we are not going to insert the key and values. So we created a dictionary with two pairs of keys and values, so apple and 50 and cherry and 75, and return it. So this is the place that we call this function with two arguments. So we are going to return the output, which is this is the dictionary that is output of the remove keys with value dictionary, and this is assigned to the filtered dictionary. Okay, so the filtered dictionary is now having these two key value pairs. So filtered dictionary equals. Okay, so filtered dictionary equals. So the filtered dictionary is now created. And simply we are saying that filtered dictionary, and we are printing it out in the output. Basically, this function can help us to create a new dictionary and avoid any key value pair with a specific value number. For example, here I was calling the function. The first argument was the dictionary. The second argument was 0, meaning that I don't want to have any keys in this dictionary to be there anymore if its value is 0. But if I want to remove the for example, if I want to remove the keys that are having the value 75, so I pass number 75. So when I run the code, we see that in the filtered dictionary, we have everything but cherry. Cherry has the value 75, and I didn't want that because I put 75 there. So we see that in the filtered dictionary, we are having everything. Apple is 50, we are having it. Banana is 0, we are having it. And date is 0, and it's there. But cherry is not there because the criteria for filtering of the dictionary has changed now. Now I want to exclude keys that are having value 75. So this is basically how we can filter a dictionary with a specifically with a specified value. Thank you for watching. Welcome back. Here we would like to write a program that swaps the keys and values in a dictionary. So, for example, here is my original dictionary. We see that there are 3 keys and 3 values. Okay, so 3 pairs are there, 3 key value pairs, let's say. Okay, here is that. So for Alice, we're having manager. For Bob, we're having engineer. For Charlie, we're having the designer. Now I would like to swap the value with the key in each element. So the keys must be swapped with the values. So in the output, we see that instead of having Alice manager, we are having manager Alice. Instead of having Bob engineer, which is key and value, now we are having the new key is engineer and the Bob is the value. So instead of having Charlie designer, we are having designer Charlie. Okay, so this is basically how we want the output to be. So how can we do that? We can use dictionary comprehension. Here we are having the original dictionary, and then I'm calling a function called swap keys values, and we are passing one argument only, and that argument is our dictionary. So this function is going to help us to reach to this dictionary. But how can we do that? So this function is going to have the creation of a new dictionary, and here we see that we are iterating over the key and values of this dictionary. So the keys
and values of the data dictionary. The dictionary, which was named original, in the function it is called data. We can name it whatever. So we are iterating over the keys and values of the data dictionary, okay? And what we are returning here is that instead of having the key values, we are having value key, okay? So let me illustrate it with an example. So in the first iteration, key equals Alice, value equals manager. Okay, so key equals Alice, value equals manager. So we are iterating through this in the data dictionary. So key, which is Alice, and value, which is manager. Now return it instead of having the key value, return it in a value key. So we are swapping their place. So now we are creating a new dictionary where the key is manager, and the value is Alice, because we learned that in dictionaries we are having key value pairs. Okay, so key and value pairs. So key and value pairs. So key iterating variable is going to iterate over the keys Alice, Bob, and Charlie. Value iterating variable is iterating over the values of my dictionary: manager, engineer, and designer. Now in the first iteration, key equals Alice, value equals manager, and then we are returning them in the vice versa format. So we are not saying the key value, we are saying value key. If I write down here key, and if I write down here value, when I run the code in the output, we see the same dictionary as the original dictionary. But now I want to reverse their place. So I write down value and key. So this Alice is going to be here, and this manager is going to be here. Okay, so now you see. So now I reversed them. So in the first iteration, we reversed the manager with Alice. Now we go for the second iteration. So second iteration, we are having key equals Bob, and value equals engineer. Okay, so we are saying that for each key and value that is in data, so the key is Bob and engineer is the value. Now return the value and key. So instead of having Bob engineer, we are going to have engineer Bob. So here, the second one is also now set. So we are having engineer and Bob. Okay, so we swap their place. And in the next iteration, in the third iteration, which is the last iteration, we are having this third iteration, key equals, we are having Charlie, and the value equals designer. Okay, the value equals designer. We are saying that, okay, key is Charlie, value is designer. Now reverse their place. So put value and key instead of having key value, put value and key. So here, it will be designer and Charlie. Okay, so now the iteration has finished because we iterated over the three pairs here. So this was the first pair, this was the second pair, and this was the third pair. So we iterated over all the pairs. Now this was the place that we called the function, right? And we passed one argument, which was the original dictionary, and we returned all the output of this iteration, and this is what the output looks like. And this output, because it is on the right hand side, the call of the function, when we return this output is assigned to swapped dictionary. So we are having a dictionary called swapped with these keys and values, okay, with these key value pairs, where we are having manager as the first key and Alice as the first value as but in the original, we saw that Alice was the first key, not the value, but manager was the first value and not the key. Okay, so we see that everything is swapped. Everything is swapped using the function, and it is assigned to swapped dictionary. And here we are printing it out simply. Swap dictionary is this, and this dictionary that you see here, you see exactly is the dictionary that we expected to see in the output. So in this video, we learned how to define a function that can help us to swap the place of keys and values in a dictionary. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to get the maximum and minimum values in a dictionary. So here is my dictionary. This is my dictionary. As you see, there are 1, 2, 3, 4, and 5 key value pairs. The first pair is here. This is the first pair, separated by a comma from the second pair, separated by a comma from the third pair, separated by a comma from the fourth pair, and separated by a comma from the fifth pair. Okay, so this is my dictionary. We are having 5 key value pairs. Now I would like to find the maximum and minimum values in the dictionary. So one value is 10, 25, the other one 5, 42, and 18. So these are the values. So the minimum value is 5, as we see here, and the maximum value is 42. So when we see it, it's easy to find it. However, if you have a very large dictionary, it's not easy to find it manually by looking at it. So we need to have a code, a function that, does the job for us. This is why we use programming, to improve the efficiency, okay, and save some time for ourselves. So in order to do that, we are having some built-in functions in Python. We are having the max and min function. So this is the max function, and here is the min function. Here is the min function. So these are the two functions that we are having it here. So the max and the min. So these are going to help us to find the maximum value in the dictionary and the minimum value in the dictionary. But in parentheses, I would like to have the values, yeah? So I would like to have the maximum values. So I write down the values. So I'm using the values function. Then the values from which dictionary? My dictionary, yes? So I use the value function to access the values of my dictionary. This is the name of my dictionary, and find its maximum value. So using the max function, I'm accessing the maximum values of my dictionary. And this is when it is found, it is assigned to a new variable called max value. And here, similarly, we are having the minimum function to help us. So I'm finding the minimum values, okay, minimum values of my dictionary, So using the minimum function and values function, I'm finding the minimum value in my dictionary. Okay, when it is found, it is assigned to mean value variable that we are having it here. And finally, we are using the print function to show our output. We are having the maximum value and minimum value. So max value, this variable, and the mean value, which is this variable, are being printed, both of them in the output. So we see the max value is 42, the mean value is 5. So if I change it, for example, the 42 is the max value. If I make it to be 80, for example, when I run the code, we see that the max value is now 80. But if I make it to be like 20, this one is now 20. So D is having the 20. Now, what is the max value? So 25 is the max value, right? So if I run the code, we see that 25 is now having the maximum value. And also for the same goes for the minimum. So for the minimum, if I have, instead of having 5, I have 2 and I run, we see that the minimum values is 2. If I have, instead of having 80, if I have 1, the minimum value is now 1. So this is how we can see that by changing even the values, whenever we run the code, we are able to easily and very fast find the maximum value in our dictionary and minimum value. Thank you for watching.
Welcome to this video. In today's video, we would like to write a Python program to unpack a tuple into several variables. So here is my tuple. As you see here, it has 3 elements. So we know that in tuples, we need to declare them within parentheses. Okay, so when we want to declare the tuple, we need to define the elements within the parentheses, inside the parentheses. Okay. So here is my tuple. It has 3 elements, 10, 20, and 30. Now I would like to unpack this tuple into several variables. Because it has only 3 elements, we can only unpack it to 3 variables. In order to do that, on the right-hand side, I write down the name of the tuple, and on the left-hand side, I type down 3 variables that I would like them to get the values of the elements of this tuple. So here I have a tuple with 3 elements. Therefore, on the left-hand side, I have to put 3 variables. So the first element the first element 10, is going to be assigned to A. The second element of my tuple is going to be assigned to B. And the third element of my tuple, which is 30, is going to be assigned to C. And then when I'm having the print and display of my variables here, so when I run the code, we see that the value of variable A is 10, exactly the first element. The value of the variable B is 20, exactly the second element, and 30 for the third element. So what if I have a tuple with 4 elements here? And here I'm having 3 variables. So when I run the code, you see that we are having errors. Why? Because we are having a tuple with 4 elements, but it is being assigned to 3 elements only. So it's necessary to have 4 elements on the left-hand side when we are having, 4 variables on the left-hand side when we are having 4 elements in my tuple. So we can conclude this. The number of variables on the left-hand side must be equal to the number of elements in my tuple when we are unpacking. Okay, unpacking. So here now, when I have 4 elements and I have 4 variables, everything should be okay. I'm going to also print the variable d here so we can see d. So when I run the code, we see that A is 10, B is 20, C is 30, and D is 40. So D is getting the last value in my tuple. So in this video, we learned how we can unpack a tuple into several variables, and we learned that we need to be careful about the number of elements and the number of variables that we are having on the left-hand side. And we learned that the number of variables on the left-hand side must be equal to the number of elements in the tuple if we are unpacking a tuple into several variables. Thank you for watching. I'll come back. In today's video, we would like to write a Python program to create a dictionary from a string. So here is my string. So my string is hello, and it is assigned to a variable called text. Then here is my empty dictionary. Now I would like to have a dictionary being created from the string. But how do I want this dictionary to look like? So I would like to have something like this in the output. We learned that for dictionaries, we are having the key value pairs. Okay, so here you see that I'm having one pair here, one pair here, one pair here, and one pair here. So I'm having 4 pairs. H has the repetition of 1, E has the value of 1, let's say, L has the value of 2, and O has the value of 1. So this is my string being inserted into a dictionary, each character of it. So we see H is repeated once, so we are having its value to be 1. E is repeated once, we are having its value to be 1. L is repeated twice, so we are having its value to be 2. And O is repeated once, so we see that its value is 1. So how can we do that? In order to do that, we need to write a for loop. So we are having an iterating variable called char, and we are saying that for each character in my string called text, if that character is inside my dictionary, then increase the counter, one value, the counter. And if it's not in this dictionary already, insert it in the dictionary and assign the value to 1. Let me illustrate it with an example. So here my string is hello. Okay. In the first iteration, we are having char equals h. Yes, we are having something like this. So char equals h because we are going through each character of the text variable, and the text variable is hello. So the first character is h. So in the first iteration, the character equals h. And we are checking to see if h is inside my dictionary. Is it inside my dictionary? No, because it's an empty dictionary. We just created it. So this statement is not true. We are not going to execute this part. We go to the else part. When we go to the else part, what we are doing here is the following. So we are inserting that character h into my dictionary and assign the value 1 to it. So now my dictionary would look like something like this. So char count, we're going to have it like this. Now after the first iteration, h is inserted and value 1 is assigned to this key. So my key is h because we said that it's a key value pair, and my value is 1. Okay, so now we are going for the second iteration. So second iteration, char equals e. Why? Because the second character in my text is e. So here char equals e, we are saying e, is it inside my dictionary? This is my updated dictionary from the last iteration. Do we have a key called e? No, we only have one key and it is h. It's not e. Okay, so this statement is not true. We're not going to execute this part. We are going to the else part, therefore. Because this part is not true, we are going to the else part. Now here what we are doing is that we are creating a key with that character, which is e, in the char count dictionary and assign its value to be 1. So it will be something like this. Okay, so it is something like this. Now we updated our dictionary. In the next iteration, in the third iteration, we are having char equals L. Why L? Because the third character is L. We see L, is it inside my char count dictionary? Char count dictionary is not having the L. So this statement again is not true. We are not going to execute this part, and the else part is going to be executed. And what we are doing here, again, we are creating a key with that character, which is L, and we are assigning the value 1 to it in the char count dictionary. So it will be L equals 1 now. L, its value is 1. Okay. So now we updated the dictionary. We are going for the fourth iteration. For the fourth iteration, char equals L again. Why? Because the fourth character is again L. So we are checking to see if L exists in my char count. So char count, do we have L here? Yes, we just inserted it. So we have a char count. So this statement is indeed true. Now that this statement is true, we are going to do this. So what we are going to do is that for that character L, which is our key in the dictionary and in the char count dictionary, we are going to increment its value by 1. So its value is already 1. I'm going to increment its value by another 1, so it will become 2. Then we go up and we go for the next iteration. So the fifth iteration, this iteration is going to continue until we reach the last element of the string, last character of the string. And now char equals O. Now char equals O. Why O? Because this is the fifth element. Char equals O, so we are checking O. Is it in the char count dictionary? No, we don't have any key called O. We have H, E, and L. So this statement is not true. We're not going to execute this part. We go to the else part, and we are going to create a key with that character, which is O in the char count dictionary. Char count is the name of our dictionary, and assign the value, its value to 1. So it will be something like this. So we updated our dictionary here. So the iteration has finished because we had 5 letters in my string. And here you see that we had 5 iterations. So this has been finished now. And now we are going to print the char count dictionary. And when we run this code, we see that H, the key H has the value 1, as we are having here. The key E has value 1, that we are having it here. The key L has value 2. The key O has value 1. So basically in this video we learned how we can create a dictionary from a string, and we can have a longer string. For example, we could have hello world. So if I run this code, you will see that things will change. So H is 1, E is 1, L is 3, O is 1. We are having 1 space. We are counting the space also. So it's 1, W is 1, etc. We could have another thing. For example, this is the Python coding class with Dr. Reza Shahin. So when I run this code, you see that we are having a long dictionary, and we see that, for example, H has been repeated 6 times. We are having 9 space. We are having the Y only 1 time. We are having T 4 times, etc. So this is a very nice way to create a dictionary from a string with its character. Thank you for watching.
Welcome back. In today's video, we would like to write a Python program to check if a given value is present in a set or not. So here is my set. As you see, I am defining my set with 5 elements, 1, 2, 3, 4, and 5. Now here is my given value. So I would like to check if this value is present in the set or not. Okay, obviously we know that it's not present. 10 is not present in the set, but how can we write a Python code to do this checking for us? In order to do that, I am calling a function called check value in set, and I'm passing 2 arguments. The first argument is my set. The second argument is the value that we would like to check its presence. When this function is called, we are defining our function using the def keyword. When this function is called, 2 arguments are there, my set and value. Now here we are checking to see if this value is inside this set. So if value is in set, we are going to print this. That value, which is 10, is present in the set, and if this statement is not true, it means that that value is not inside the set. So we go for the else part and we print this part. 10 is not present in the set. So now let us do the analysis with the numbers. So we are having the value 10. We would like to check its presence in the set. So we are having this check 10 is in this set. Is it there? No, it's not there. So this statement is not true. Therefore, this part is not executed. And this else part is executed, and we are having the print 10, which is our value, is not present in the set, is not present in the set. So this is what we get. But if we are checking number 5, for example, so here we would like to check if number 5 is in the set or not. So 5, is it in the set? We check the set. Yes, the 5 is there. Therefore, this statement is true. Yeah. So the program is going to be executing this part. So the compiler is executing this part, and it is going to print 5 is present in the set. And we see that when we run the code, we are having 5 is present in the set. Basically, this is how we can consider it. And we can have, for example, another set here. I would say my set 2, and it is equal to 2, 4, 6, 8, and 10, for example. Okay, this is my new set, and my value 2 is number 5, for example. Now, when I call the function, the check value in set, I'm using the second set as the argument, and also I use the second value as the second argument. So now I call the check value in set function, and I'm having two arguments, my set2 and value2, instead of this one. So if I run the code, we see that we would like to check if 5 is present in this set. Is it present? No. Therefore, this statement is not true. We're going to see this message. 5 is not present in the set. So we see 5 is not present in the set. But if I check to see if number 6 is there, we see that 6 is present in the set. 6 is present in the set. So this is basically how we can check if a number, a given value, is present in a set or not. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to count the elements in a list until an element is a tuple. So let us look at this list. This is my list. I'm having different elements here. So I'm having number 1, 2, 3. I have a string here, hello. I have a float number there, 4.5. I have a tuple inside my list, and I have number 8 and number 9. I would like to have a Python program to count the elements in the list until an element is a tuple. So they count the elements in the list until an element is a tuple. So how many elements do we have here? 1, 2, 3, 4, and 5. Before we reach the tuple, which is this part, we are having 5 elements. And when I run the code, we see that count of elements before a tuple is 5. So we would like to get that 5. Okay, but how can we compute that? Here is my list. I'm having integers, I'm having float numbers, we are having a string, and we're having also a tuple inside this list. We are initializing a variable called count to 0. So it is initialized to 0. Now, in order to understand how many numbers are there as the elements before that tuple, we are going to have a for loop. So we are having a for loop for each item. Item is my iterating variable. For each item in my list, if the type of that item equals tuple, break. Okay? Otherwise, if it's not like that, just simply increase the counter. So for example, if I want to illustrate it in another way, in the first iteration, item equals 1. And we check the type of the item. So we are checking in the first iteration, we check the type of 1. Is it equal to tuple? No, because it's integer. Okay, so nothing is going to happen. Simply the counter is increased. Counter was initialized to be 0. Now it is initialized, it is increased to be 1. Okay. Then we are having the second iteration. So item equals 2. So item 2, here it's an integer again. So we are checking the type of the item, which is 2. And the type of the item is integer. Is it equal to tuple? No, it's not. Therefore, we don't have to break. We are going to increase the count one more time. So count equals 2 now. Then we are having the third iteration. So item equals 3 now, because in the next iteration, third element. We see that here count will be 3. Why? Because number 3 is again an integer. We're checking its type, so it's an integer. Is it equal to tuple? No. We don't do the breaking. We increment the count, so it's now equals to 3. Then we are having the fourth iteration. So item equals hello. This time hello. So now item equals hello. We check the hello type. It's a string. Is it equal to tuple? No, string is not equal to tuple. We don't do the breaking. We increment the count. So the count equals 4. And the fifth iteration, item equals 4.5. So this time the type of the 4.5, when we are checking it here, it's a float. Is it equal to a tuple? No. So we don't do the breaking. We are going to increment the count one more time. So count equals 5. In the sixth iteration, item equals, you see a tuple. Now we are seeing a tuple there. Okay. We see a tuple there. Therefore, let me also print it here. Print the item. So you see it in the output when I run. So you see that in the sixth iteration, the item is 6 and 7 at the same time, because 6 and 7, they are 2 elements of one tuple, but they as a whole are included in the list as one element. Okay. So 6 and 7 are 2 elements of the tuple, but the tuple itself is only one element in the list. If I have another tuple inside this list, for example, another tuple is there, 2 and 3. Although 2 and 3 are 2 different elements of my tuple, this tuple itself as a whole is only holding one place of elements. Okay, so this is only one element in my list. So this is why we are having it here. So in the sixth iteration, item equals 6 and 7. So 6 and 7. Now we check its type. So this type, when it is checked, it is going to print us the tuple. So the type of this item, is a tuple. So tuple equals tuple. Are they both equal? Yes, they are both equal. Because they are both equal, we are going to break and getting out of the for loop. Okay, so now we are going to break here. Okay, now we're breaking. Why? Because we reached a tuple. We are breaking. Why we want to break? Because we wanted to count the elements in the list until we reach an element. So we were willing to count the elements in a list until an element is tuple. So this element is a tuple, so we don't want to continue, and we were willing to count the number of elements before a tuple show up. Okay, and the number of elements was 5. Because we counted in each iteration, we incremented the value of count 1, 2, 3, 4, 5. In the sixth iteration, we are not going to increase it. Why? Because we are entering this loop, this if condition. We are checking the type of the sixth item, which is a tuple. So this statement is true. We are printing the item, which is 6 and 7, and then we are breaking. So we are getting out of the for loop, and we are not going to increment the value of count because we reached a tuple now. We wanted to know the number of elements before we reach a tuple. Okay, so this is what we are going to get as the output. So the count is 5 because we are printing it here. So when we count also 1, 2, 3, 4, and 5 elements are there in my list before we reach a tuple. And regarding the type, for example, I'm having x equals 10, I'm having y equals 12.5, I have z equals Reza, and I have the type function. So when I have the type function, I can have the type x, type y, type z. So now if I want to print them, print the type, we can have in parentheses the print. So it's print, and it is printing. So we are printing the type. So when I run the code, you see that the first one, the x is integer, the second one is float, and the third one is a string. So with respect to this function, I wanted to clarify how it works. The way that it works is the following. We are having 3 variables, one integer, one float, and one string. In order to understand their type, we use the type function and we put in parentheses the name of my variables. And because I want to print this type, I use the print function as well. So we see that the type of x is integer, the type of y is a float, which is true, and the type of z is a string. Here you see it's in a string. So in each iteration, we are saying integer, is it equal to tuple? No. A string, is it equal to tuple? No. When we were having hello in the fourth iteration, so it was a string. So string, is it equal to tuple? No. So we were incrementing the count. Okay. Or here, in the first iteration, item was equal to 1, so it was an integer. So we were saying integer equals to equals tuple? No. So when the statement was not true, we were not going to enter the if condition, and we were incrementing the value of count because we realized that the item is not a tuple, and we wanted to continue the count until we reach a tuple. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to find the maximum and minimum values in a set. As you see here, here is my set, and we are having a set with 5 elements, 10, 25, 3, 47, and 19. So our set is having 5 elements there, and we would like to find a maximum element, an element with maximum value, and another element with the minimum value. So the maximum value in this set is 47, and the minimum value is 3. We would like to find these two values, and we see that in the output we are having them being printed out. But how can we get that? In order to get that, so here is my first set, my initial set, let's say. I call a function called maxmin, find maxmin, and we are passing my set as the argument. And we see that this is the call of the function with argument on the right hand side, and on the left hand side we are having 2 variables. Okay, on the left hand side we see that there are 2 variables being separated by a comma. We can understand that therefore this function is going to return 2 values. That is why we are having 2 value variables on the left hand side. And when we look at this function, we see the return part, we see yes, there are 2 values that are being returned by this function. The max value, which is the first return, is going to be assigned to the first variable from left. Then we are having the mean value, which is the second return parameter. It is going to be assigned to the second variable, which is mean val. Okay, so this function, whenever it's called, we are passing 1 argument, and we understand that even before reading the function, we understand that this function is going to return 2 values and assign them to these 2 variables, max val and mean val. When this function is called, we are having the execution of this part. We're going to use the max and min function. So this is the function that we are going to use, max and min. Okay. So this function max is a built-in function in Python that can help us to find the maximum value. But we want to find the maximum value in my set, yes? So we are going to put the name of my set in parentheses. So we are going to also find the minimum value of my set. So we are going to put the name there. So when the maximum value of the my set is found, it is assigned to max value. And when minimum value of my set is found, it is assigned to min value. And in the end, we are returning both values, max value and min value. Okay, and these are assigned to max val and min val, because here on the right hand side we are having the call of the function. And finally, we are showing these in the output. So max val and min val, both of them are being printed out in the output. And even if I change the numbers, so you see that if I change, for example, 19 to 80, now 80 is the largest number in this set. So when I run the code one more time, we see that maximum value is 80. Okay, it's not 47 anymore. And if I change 25 to 1, we see that the mean value is 1 now. So everything is updated. So this is the way to find the maximum value and minimum value in a set. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to find repeated items in a tuple. In order to find a repeated items in a tuple, we can define a function in Python to do the work for us. But here we see that this is my tuple. Okay, we see my tuple is there, it's defined there. Then we call this find repeated items function. But let me show you the tuple first. So you see this is a tuple. It has a few elements. So 1, 2, 3, 4, 2, 5, 3, 6, 7, 2. After looking at the tuple carefully, we see that there are two numbers that are being repeated there. So we are having number 2 being repeated and number 3. So these are two repeated items in my tuple. So you see 1, 2, 3, 4. Up until here, there is no repetition. So here we are having the first repetition of 2, then we are having 5, it's okay. 3 again, it is repeating. 6 and 7 are unique, and then again 2. So we are having number 2 and 3 being repeated in my tuple. So I would like to write a function in Python to give me these two repeated items. Okay, so, and this is my tuple. Now, in order to do that, I call a function which is named find repeated items, and I'm having one argument. So there is only one argument when we call the find repeated items function. And this argument is my tuple. So this is the function. Whenever this function is called, we should see the execution of this part. So this is the tuple name in the function. We call it top, but in out of the function, we call it my tuple. So just keep that in mind that top is the same tuple that we are having it here. Okay. So here we are creating a set in order to make sure that the repeated elements are assigned to it. Okay, so we are creating a set here called repeated items, and we are creating a set to check elements that have been seen. Okay, so these are the two sets, seen and repeated items, that we are creating here. Then we are iterating over all of the items in the top. So meaning that we are going to have in the first iteration item equals 1, second iteration item is equal 2, third iteration items equal 3, fourth iteration items equal 4, fifth iteration items equal 2, etc. until the end. Okay, so this is my for loop. here we see that we check if that item is in the scene set. Okay, we are going to track the elements that have been repeated in the scene set. So we check to see if that item is in that set. If that item is in that set, we are going to say add that item to the repeated items set. Okay, so let me illustrate it with a numerical example so it would be easier. First iteration, item equals 1. Okay, so we check if 1 is item in the first is in scene set. Is it there? No, because this set is empty now. Okay, so this set is now empty, so it's not there. So because it's not there, we are adding this item which is equal to 1. That item is being added to the repeated items set. Okay, to the repeated item set. So now we can have the repeated items set equals, now it has the value 1 because we just added it. Let me say it one more time. In the first iteration, item equals 1, which is the first element of the tuple, because we are iterating through the tuple, each element one by one. We check if that item is in scene. Is it in the scene set? No, scene set is empty. Now it has no values. So scene set, it's having no values for the moment. It is empty now. Okay. So is it there? No, it's not there. So sorry, I made a mistake here. So if it's not there, okay, this statement is false because that item equals to 1 is not in the scene. Okay. So now that it's not in the scene, here this statement is false. Therefore, this part is not executed. We are going to the else part. We are going to add that item in the scene set. Okay, so number 1 is being here. So let me say it one more time because there was a fault there. So in the first iteration, item equals 1, item equals 1 because we're in the first iteration. So we check to see if item is in scene. So scene, we just created it and it's an empty set. So it's not in there. So this statement is not true. Therefore, this part is not executed. We go to the else part and we are going to add that item in the scene set. Okay, in the scene set, it is added. Now scene set has the item 1. Okay. Now we go for the next iteration. So now in the next iteration, items equal 2. Okay, items equal 2. This is the second iteration. We check to see if number 2 is in scene set. So scene set has only one element, which is 1. So is it 2? Is it there? No, it's not there. This statement is not true. We go to the else part. We add the number 2 to the scene set. Okay, so now it's added also. We go for the next iteration. So item equals 3. So 3 is in scene set. Is it true? No, 3 is not there. We are only having 1 and 2. So we go to the else part. We add number 3 to the scene set. So number 3 is also added here. Okay. Then we go for the next iteration. Item equals 4. Items equal 4 equals 4. So we see a 4. Is it in the scene? 1, 2, 3. No, 1, 2, 3 is only there. 4 is not there. So this statement is again false. We go to the else part. We add number 4 to the scene set. So number 4 is being printed here. Okay, is being inserted here. Then in the next iteration, item equals 2 again. You see, after 4, we are having number 2. So number 2 is there. Now that number 2 is there, we check to see if number 2 is in scene. When we check the scene set, we see yes, number 2 is there. So this statement is true now. Now that it's true, we are going to execute this part, meaning that we're going to add number 2 to the repeated items. Okay, so the repeated items. This is the set which was empty so far. So now number 2 is being added there. And we go for the next iteration. Now item equals 5. So 5, is it in the scene? 5, we don't have it. So we're going to add it to the scene. So 5 is added here. Next iteration, the value is 3, so item equals 3. We check item if 3 is in the scene set. Yes, 3 is there. So now that the 3 is there, add that item to the repeated items also, meaning that this item was already inserted this in the scene set. Okay, so it's a repeated item. This is why we are adding it in the repeated items set. Okay, so 2 and 3. After that, we are having 6 and 7. Okay, after that, we are having 6 and 7. So 6 and 7 are not already there in this scene set. So scene set is now 6 and 7. Then we are having the item equals 2. So 2 item 2, is it in the scene? Yes. Therefore, you need to add it number 2 and add number 2 to the repeated items. So repeated items is having 2 and 3, but because it's a set, we cannot insert another number 2 there, because one of the features of the sets was that we cannot insert repeated items. Okay, so 2 and 3, we know that it is already being repeated in the original tuple. We don't have to insert it anymore. Therefore, it's not going to be inserted. Why? Because 2 is already there, and one of the features of the set is that they do not allow us to have duplicates. Now, the repeated items set and the scene set, both of them are completed. And now we are here returning the repeated items, which contains 2 and 3. Now, this is the call of the function. So the output was the repeated items set, and that set is assigned to result, and when we run the code, we are printing the result, which is 2 and 3 in the output. So in this coding exercise, we learned how to find repeated items in a set. First of all, we were having the original tuple, and we were having 2 sets. We wanted to keep the unique elements of the tuple in the scene set, and we wanted to have the repeated items of the tuple in the repeated items set. Okay, and we wrote a for loop, and we were iterating over all the elements of the original tuple, and we were checking to see if that item is already in the scene set or not. If it's not there already, we are going to insert it. But if that item was already in the scene set, we realized that it's a repeated item, so we were inserting it in the repeated items set. Thank you for watching.
Welcome back. In today's video, we would like to write a Python program to create a class representing a circle. And we would like to include methods to calculate its area and perimeter. So here is my class called circle. We see that we are having 2 methods, or let's say functions here, and we are having a constructor here. Okay, so this is my constructor. How do I know that it's my constructor? Because we are having underscore underscore init underscore underscore. So double underscore init and then the double underscore again. So this is how I understand that I'm having a constructor. And now that I have a class that has actually a constructor, we can understand that whenever I create an object from this class, the constructor is automatically activated. And when it is automatically activated, we know that when we create an object of this class and we are having a constructor, and if there is an argument for the constructor, we need to have that argument when creating the object. I will explain this in a few minutes. Apart from the constructor in the circle class, we are having 2 functions. One is called area, the other one is called perimeter. So the area function is going to calculate the area of a circle for us. So we are going to have pi multiplied by radius to the power of 2. So star star means to the power. So radius to the power of 2. And this pi is using this number, so 3.14. We can either call the math library to access the pi number, or we can simply write down 3.14 instead of this. Okay, So in order to use the pi number from the math library, just remember that you need to include the math in the header of the program. So this area function is going to calculate the area of a circle, pi multiplied by radius to the power of 2. So all we can say radius to the power of 2 multiplied by pi. Then we are having a function called perimeter. So this function is going to calculate the perimeter of the circle for us. And the formula is this: 2 multiplied by pi multiplied by radius. This is the standard formula for calculating the perimeter. So now in this code exercise, when we run the code, it asks me to enter the radius of a circle. When I enter 5, it is going to make the calculation for the area and also make the calculation for the perimeter. But how can it work like that? First of all, we are showing this message: enter the radius of the circle. So exactly this message: enter the radius of the circle. So we are making an interactive program with the user. We are asking the user, okay, enter the radius that you want to have for your circle. Then I'm going to calculate the area and the perimeter for it. And we are using the input function to show this message. And whenever we are showing this message, whatever the user is going to enter, we are going to store it by default in Python as a string. Okay, so when we are using the input function to get anything from the user, by default, it's a string. And now, because we would like to work with the calculation of the area and perimeter, we need an actual number, for example, a float number. So this is why we are having the float keyword here. So whatever that is whatever that we are getting from the user, we are using the input function to store it. It's a string. We are using the float function to convert it to a float, and then we are assigning it to radius. This is my variable. Now that my variable is having the radius that I would like to enter, for example, I entered number 5, so radius equals 5. Now I would like to create an object of the circle class to access the area function and the perimeter function. How can I do that? So first of all, in order to create an object, we need to choose a name for it. So I choose the name to be C. That's it, capital C. This is the name of my object. It can be anything. It can be my object. It can be hello world. It can be whatever that we want. It's not important. The name is your choice. So I'm choosing it to be C. C equals, then circle, the name of the class, and we are having one parameter here. Why do we have this parameter? Because we're having a constructor, and apart from self, my constructor is requiring a parameter. Okay, and we mentioned that when we are creating an object of this class, because we are having a constructor is going to be called automatically. Therefore, when we are initializing the object, we need to have the radius here. So I'm creating an object from the circle class that is called C, and as the argument, I'm having the radius that we stored the input by the user. So when I create the object, the constructor is automatically called, and this radius is passed as argument. And this radius that we passed as argument is assigned to the attribute of this class. Okay, so this is a self.radius. So we are storing the parameter here using the constructor. We are initializing the radius. Okay, so this is how I created the object, and automatically the constructor is called. Then, in order to call the area and perimeter function to do the calculation for us, now we are having the radius. I can use the object C from this class, because through the object of the class circle, I am able to access the area function and perimeter function. Why? Because this is an object of the circle class, so give me access to all the functions in this class. And you see that in area and perimeter functions, we have no arguments apart from self, so I don't need any argument to call these two functions. So I use the print function, to print the output, simply I write down the area, so the area, this message. Then I use the object C, then I put a dot and I call the name of the function, which is area. So basically it's like that, C dot, the name of the function, which is area, and that's it. The rest, when I have the colon dot to F, means that I want to have only two decimals. Okay, this is what it means. I would like to have only two decimals, an output of two decimals. So I'm going to call the area function with using the object C, and I want to have only two decimals in the print here in the output. Okay, when I'm printing the stuff in the output in the terminal, I would like to have it only to be with two decimals, and as you see, it's with two decimals. If I make it with three decimals, it can go up to three decimals if there is any decimal there for the third part. So now the area function is called. This area function is going to calculate this formula for me, radius I have, because I got it from the user and I store it in radius and I created the object. So the parameter is stored in the attribute of the class circle. So self.radius is holding my radius. So now I call the area function. The pi number is imported from the math library. We are multiplying it by the radius, which is the attribute that we just initialized using the constructor, to the power of 2, and the output of this is multiplied by pi number, and this function basically is going to return the area of the circle for us, and only up to two decimals of this area is being printed in the output because we are having colon point or colon dot 2f. Okay, then I'm having the print function again here, and I write down perimeter. Then I use the object called C that we created, an object of the circle class. So I use that object to call the perimeter function this time. So C dot perimeter, the name of the function, an empty parenthesis. So this function is called, I'm calculating 2 multiplied by the pi number, multiplied by the radius that we stored using the constructor. Okay, we passed this parameter to the constructor, and this was assigned to self.radius, and self.radius is being used here. And we are going to have the colon dot 2f, so it means that we are going to have up to two decimals being printed in the output. Okay, so this is the output that we see here. So area is calculated and perimeter is calculated here again. So when I run the code, again, it asks me to enter the radius. I write down 5. It does the calculation for me for the area and perimeter. So I run the code. This time I say the radius is 13. Now here is the area. Here is the perimeter. I write down, for example, 2.5 as the radius. Accordingly, it is going to calculate the area and the perimeter for us. So this is how we can write a Python program to create a class representing a circle and include functions to calculate the area and perimeter of a circle. Thank you for watching. Welcome back. In today's video, we are going to write a Python program to create a class called person and includes attributes like name and country. So we are having a class called person and it has a constructor here. This constructor is basically going to it's going to be called automatically when we are creating an object of the person class. So this is my constructor. Apart from self, it needs two arguments, name and country. Whenever we are creating an object, we need to know that we are going to have two arguments to be passed to be initialized using our constructor to our public attributes of the class name and country. So let me illustrate it with an example. It says name and input. So we are going to ask the user enter your name. Using the input function, we are going to store it in the name variable. Name is a string holding the name of the, for example, user. Then we are asking the user to enter your country. Whatever the user is going to enter, it is going to be stored in the country. Then I am creating an object called person from the person class, I can rename it to put it P, for example, here. It would be easier to understand. Oops, sorry. So now I'm creating an object called P from the person class, and here I am passing two arguments that in which we stored the name and country that we got from the user. When this object is created, the constructor is automatically called, and it is going to initialize the name to my self.name attribute and the country to the self.country attribute. Okay? So whenever this object is created, the constructor is going to initialize these two attributes. And we can also have a message being shown here. For example, we can have print the constructor is called. Okay, so we know that the constructor is called. Then after having the object, we can use the object to access the attributes that we stored in the person class. How? So I use the object, which is p dot name, the name of the variable, and dot then another name of variable, which is country, to access the information that we stored here using the constructor. So when I run the code, it says enter your name. For example, I write down Reza. It says enter your country. I would say Canada. Then it says the constructor is called. So this is the automatic message because we are building the object. We are creating the object. The constructor is called, and Reza is assigned to the self.name, which is our attribute. Then Canada is also assigned to the self.country, which is another attribute of this class. These are the public attributes. Then we are using the same object to access the name and country attributes. Okay, so name and country attributes. So you see that Reza from Canada is being printed. Using this print function, we are printing Reza from Canada, but using that object, we accessed the attributes of that class called person. So in this coding exercise, we learned that we can create an object of a class that has a constructor with two arguments. And whenever the object is created, these two arguments must be passed. Okay, must be passed. And these two arguments are used to initialize our attributes. And then using the same object, we can access the name and the country. For example, here I'm going to create another object that is called P2. I'm saying person, then name, and for example, I would say name and country, but this time I would like to get another name. So name is now Shaheen, for example. It is Shaheen. And country is, for example, United States of America. So it's USA. Okay. So this is now I call it name 2 and country 2. So name 2 and country 2. So now that I use these two parameters, when I use these two parameters to pass as arguments when creating the second object, the constructor is again called. This time it is initializing this name and this country. So Shaheen, USA. So Shaheen is assigned to the attribute of the class. USA is assigned to the attribute of the class. Then this print is being printed out in the output. This message, the constructor is called. And then I can have this being here, for example. This time I would like to have P2, name2, P2, and country2. So when I run the code, it says enter your name. I would say Reza. Enter your country. This is Canada, for example. And here we are having an error. So what is the error that we are having here, for example? Here it says, okay, so here there was a problem because I was writing down the name of my parameter, not the attributes of the class. Okay, here we should write down the attributes of the class, which is name, and then the attribute of the class, which is here country and not country2 and name2. Name2 and country2 were the parameter that we used here. So we see in the output, it says the constructor is called Shaheen from USA. So let me go through it one more time from the beginning. We are having a class called person. We are having a constructor with 2 arguments. So whenever we create an object of this class, the constructor is automatically called and 2 arguments must be passed. These 2 arguments are assigned to the attributes of our class, and this message is being printed. The constructor is called. Then we are asking the user to enter your name, enter your country. These 2 are information that we get from the user, and we're going to store them in variable called name and variable called country. Then we create an object of the person class. This is the first object, and pass the name and country. Why we pass them? Because we have a constructor, it requires 2 arguments. And then the name and the country is assigned to the attributes of the class. Okay, and this message is shown, constructor is called. Then we access, using the object that we just created, we can access the name and the country that we just stored information in that. Okay, and here we are printing the information. So we see that it says enter your name, this message, enter your country. So I say Reza, Canada, and it says the constructor is called because we are creating an object passing these 2 arguments. The constructor is called, this is the message, and the variables are initialized. Then after that, it says Reza from Canada. So this part is being shown here. So we use the object name, which is P, and then the name of the attributes of the class, which is name and country. Okay. Then I'm having 2 more variables, name2 and country2. So in name2 is Shaheen, the country2 is USA. Then I create another object which is called P2 from the person class, and I pass 2 arguments this time with the second object, name2 and country2. These 2 are passed to the constructor, so name2 is assigned to the attribute and country2 is assigned to this attribute as well. Okay, so this is how. So in order to access the name Shaheen and the country USA, because we pass them using the second object, we need to use the same object, then dot the name of the attribute, which is name, and the name of the other attribute, which is country. And using the print function, we're printing it out. So we see that it says Shaheen from USA. So we use the first object to store the information about Reza and Canada. We use the second object to store information about Shaheen and USA. Okay. So whenever I would like to have access to Shaheen and USA, I need to use my second object. Whenever I would like to have access to Reza and Canada, I must use the first object. Okay, because using that object, we store the information in the attributes of the class. I need to always keep that in mind that if you want to access to the Reza Canada, you must use the first object because you used the first object to initialize them through the constructor. This is the important point of this coding exercise. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a calculator class. And we would like to include some methods, or let's say functions, for basic arithmetic operations. So here is my class called calculator. And here we see that I have 4 methods, or let's say 4 functions. The first function is called add. And apart from self, it has 2 arguments. And basically this add function, whenever it is called, we need to have 2 arguments when we call the add function. And this function is going to return a plus b. Then we are having the second function called subtract. And we are having, again, 2 arguments when we are calling this function. Basically, this function is going to do a minus b, the calculation, and return its result for us. Then we are having the multiply function. It is going to return the a multiplied by b, and we are having the divide function, which is going to return a divided by b. And if by chance, b equals 0, which is the second number, so a is divided by b. if b equals 0, we need to return this error because division by 0 it's not possible, and return this error. So if b equals 0, this error a message is shown. If b is not equal to 0, we're going to have a multiplied by b. Okay, this is the overall idea of my calculator class. So 4 functions: add, subtract, multiply, and divide. Then we are here creating an object called cal from the calculator class, and because we have no constructor, we have no argument also in parentheses while creating the object. So this is the object that I create from the calculator class, and using this object I should be able to access these functions. Okay, now I'm having two variables here. Variable 1, which is called num1, is assigned number 10, and variable 2, which is called num2, and it is assigned number 2. So this is the overview of what's happening here. Now I would like to use the object cal to access different functions like add, subtract, multiply, and divide from the calculator class. In order to do that, here I'm having the print function. I'm printing this message, for example, addition, subtraction, multiplication, and division. Okay. Then I use this cal object to access the add function, the subtract function, multiply function, and divide function. And you see that in parentheses, I am passing two arguments. Why? Because we needed two arguments, a and b, for calling these functions. So whenever I call one of these functions, I must have two arguments. And these two arguments are num1 and num2, num1 and num2. So I use the cal object to call different functions of that class, and every time I'm passing num1 and num2 as the arguments for these functions. So first of all, we're calling the add function with 10 and 2, which is num1 and 2. So basically it is going to return 10 plus 2. So addition 10 plus 2 is 12 is printed. Then we are having the subtract here, num1 and num2. So 10 minus 2, which is a, is 10, b is 2. Why? Because num1 is 10 and num2, the second argument is 2. So here the first argument is a and the second argument is b apart from self. So 10 minus 2, the output is subtraction, is 8. Then we are having the multiply function, which is called here with 10 and 2. So it will be 10 multiplied by 2. It will be 20. And finally, we are having the division, which is here a multiplied by b, and 10 multiplied by 2 is 5. So this class calculator is having some relevant functions inside of it. And then using an object created from the calculator class, we can access different functions of that class and call them using different arguments and variables. So for example, if I change the number from 2 to 0, we should have an error for the divide part. Let me run the code. You see, we have 10 by 0, the addition is 10, the subtraction is 10, because 10 minus 0, it's 10, 10 plus 10, 10 plus 0, it's 10. Multiplication, 10 multiplied by 0, so it's 0. Then we are having the division, so there is an error here, error, division by 0. Why? Because 10 cannot be multiplied by 0. And why this message is shown? Because the second argument, apart from self, the second argument, which is b equals 0, and here we are checking if b equals 0, return this error message, error, division by 0. So this is why this is happening there. And also, for example, if I write down 20 and here I write down, for example, 10, we can have the new results here. You see 30, 10, 200, and 2. So 200 comes from the 20 multiplied by 10. Basically, in this video, we learned that we can create a class, and inside that class, we can have the relevant functions. And we are calling these functions using the object that we created from the class. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a class that represents a shape. And it includes methods to calculate its area and perimeter. And we are going to implement subclasses for different shapes like a circle, triangle, and a square. So here, first of all, we are importing the math library because we are going to use it when calculating the area of a circle, because we need the pi number 3.14. We can simply write down 3.14 here, or we can use the pi from the math library. So we import the math library first of all. Then we are having a class called shape. Here I'm having two functions, area and perimeter. Then we are having a class called circle, which is based on the shape class, so it inherits from the shape class. It has a constructor, so whenever we are creating an object of the circle class, the constructor will automatically activated and called, and we need to pass one argument when we are creating an object of this class. And basically, this constructor is going to initialize my attribute of the class, which is self/radius. Then, continuing with the circle class, we are having a function called area, and we are having the pi multiplied by radius to the power of 2. So radius to the power of 2 is multiplied by pi number to calculate the area of a circle for us. Then we are having another function called perimeter, and this function is going to calculate the perimeter of a circle for us based on the radius that we are going to give to the compiler when calling this function. And basically in the perimeter function, we are having this formula 2 multiplied by pi multiplied by radius. The radius is the number that we are passing as argument when creating an object of the circle class. So the constructor will be automatically called, and that number is assigned to our attribute of the class. So we see that that is used here, multiplied by pi, multiplied by 2. We are going to have some numerical examples to have a better understanding of this. Then we are having a class called square. In this class, we are having a constructor again, and whenever we are creating an object of this class, we see that the constructor will be automatically called, and we need to have one argument when creating an object of this class, because the constructor requires one argument, or let's say parameter, apart from self. So we are having that parameter being initialized to our attribute of the class. And also here we are having two functions, the area and perimeter. So the area is going to be the side to the power of 2. So side we decided when creating an object of the square class, side to the power of 2. This is the formula of the area of a square. And then for the parameter, we are having 4 multiplied by side. This is the formula also for the perimeter of a square. Then we are having another class called triangle. It also inherits from shape class. Square was also inheriting from the shape class. In this triangle, you see here, we are having a constructor, and this constructor requires 4 arguments, a, b, c, and height. So a, b, c are the sides, and height is the height of the triangle, and here these are being initialized to our attributes of the class. So a is initialized to the first attribute, b the same thing, c is the same thing, and height also the same thing. Then we are having the area of the triangle class. So in the area function, we are having this formula. So the height multiplied by b multiplied by 0.5. B is the side of the triangle that lays down on the
horizontal line. Then we are having the perimeter, which is the calculation of this a plus b plus c. So we are having a class called triangle, a class called square, and a class called circle, and all of them inherit from the shape class. Now that we discussed the class, let us go and see how we can have numerical examples here. First of all, we would like to create our object from the circle class. In order to create an object, we write down the name of the object and it equals the name of the class, and in parentheses we put the arguments that we need for the object creation. So here I'm creating an object called circle from the circle class, and I'm passing the argument 5. Why I'm having an argument? Because in the circle class we are having a constructor and it requires one argument to be the radius of the circle. And whenever I create that object, the constructor is automatically called, and that number 5, for example, that we put there for the creation of the object is assigned to the attribute of the class. Okay, so now we created object circle from the circle class, and the radius is 5. Okay, now I can use this object circle to call the functions in the circle. Okay, let me change the name of the object. Maybe instead of circle I could have C, so it's easier to understand. So the name of my object is C from the circle class, and the radius is 5. So whenever this object is created, number 5 is assigned to the self.radius attribute of the circle class. Now using this object, I can call the area function and the perimeter function that we have in the circle class. So this is the circle class, this is the area, and this is the perimeter function. So c.area is going to call the area function in the circle class because the object is created from the circle class. When the area is called, we are using the pi number from the math library multiplied by the radius to the power of 2. What is this radius? This radius is exactly that number 5 that is assigned to the self.radius using the constructor while creating the object. So now the area is calculated. We are having the colon.2f to say that, okay, only print up until 2 decimals. Then we are having the perimeter being printed, being called and being calculated, let's say, using the object c dot perimeter. So this perimeter is called 2 multiplied by a pi number being imported from the math library, multiplied by self radius, which is initialized as the class attribute using the constructor when creating the object. So we are printing all of this information. We see that circle, this is the circle, area, and area, these are the messages. And the area is calculated with 2 decimals, you see 78.54, and the perimeter 31.42. So now the circle, area, and perimeter is calculated and we see them in the output. So now we would like to create another object from another class. So now I would call this S also for the sake of simplicity. So we see that we are creating an object called S from the square class and passing the argument 4. This is the square class. We are having one argument as the side, and side is assigned to the self.side attribute of this class. Then using the same object, we are calling the area function and the perimeter function. So the area function is going to calculate self to the power of 2, self side to the power of 2, and the perimeter is going to calculate 4 multiplied by self side. Okay, so this is the square being calculated here. So the square with the side 4, the area is calculated, the perimeter is calculated, and we see it in the output. So area is 16 and perimeter is also 16. We can have another number here. So for example, we could have 5. So a square with the side 5, its area is 25, its perimeter is 20. Then we are creating an object from the triangle class. So I'm changing the name of the object as well. So the object name is T from the triangle class, and we are having 4 arguments. So A, B, C, and height. Okay, so when I go to the triangle, we are having a constructor A, B, C, and height. So these are the arguments. The first argument is assigned to self.a, the second one to self.b, etc. until the end. So we would like to create an object with these arguments with one side 3, one side 4, one side 5, and the height is 4 as well. Now, using this object, we can access the functions that are in the triangle class, in fact. In the triangle class, we are having the area and the perimeter functions. So the area function is called, we are having this calculation 0.5 multiplied by b, which is 4, multiplied by height, which is 4 again. So we see that the area is 8. Then we are having the perimeter here, which is in the output 12, and it is calculated as to be the a plus b plus c. We see that 3 plus 4 plus 5, it's 12, and it is being calculated and printed in the output. So in this video, we learned, first of all, having multiple classes inheriting from one base class, and then we learned and reviewed how to create an object from a class and access its functions. And we also reviewed that if we want to only have 2 decimals, we can have colon.2f. In the output, we want to have 2 decimals, so we are having 2f. If we want 3 decimals, we can have 3f, for example. And also we learned that whenever the object of a function and the object of a class is created, if that class is having a constructor, the constructor is going to be called automatically and initialize our class attributes. Thank you for watching. Welcome back. In today's video, we would like to write a program that defines a base class with a private attribute and provides a method to access it in a derived class using getter and setter methods. So here we are having a base class, a class called base. Here we are having a constructor, so whenever we are creating an object of this class, the value that we use for the object creation, the parameter, or let's say the argument, is assigned to our private attributes. So how do we know that it's a private attribute? Because we are having double underscores. Okay, when we are having double underscores for our attribute, it means that it's a private attribute. And the name is private attribute, but we could name it whatever we want. So whenever we are creating an object of this class called base, the constructor is automatically called, and that argument that is used for the creation of the object is assigned to our private attribute. Then in this class, we are having a function called getPrivateAttribute, or simply we call it getter function. This function is going to simply return the value of our private attribute. Okay, so when we are having a private attribute, it's important to use a getter function to access its value and use a setter function to modify its value. So this is my getter function to access the value of the private attribute, and here is my setter function by which I can update the value of my private attribute. So whenever the setter function is called, we need to pass one argument, and that argument is assigned to my private attribute. Then this was my base class. I have a class called derived, and it is derived actually from the base class, so it inherits from the base class, and it has only 2 functions. So the first function called show private attribute, and whenever this function is called, this message is shown private attribute value, and whenever this function is called, this message is shown, and then the get private attribute function is called, and this function was supposed to simply return the private attribute value for us. So this function, whenever it is called, this message first of all is shown. Then following by this message, it is going to call the get private attribute function, which is from the base class, and that function was supposed to give us the value for the private attribute of the base class. Okay. And whenever this function update private attribute is called, it is required to have one argument or parameter whenever we are calling this. And basically, this function is going to call the set private attribute function with one argument, which is here, and assign the new value for our private attribute. Okay, so let me illustrate all of this using a numerical example. So here you see that I am creating an object from the derived class. So the object is called D. I'm creating an object from the derived class and passing number 10 as the argument. And whenever that I am passing this number 10 here, we are having the object of the derived class, and we are having one argument as 10, and whenever we are having the number 10 here, because it is derived from the base class, this constructor is called number 10, which is the parameter passed when creating the object, is here. So this is the value here, and it is assigned to my private attribute. Okay, let me review it one more time. So first of all, I'm creating an object from the derived class and passing the argument 10, because we are having an argument 10 and we don't have any constructor here. Therefore, this constructor is called, and the value 10 is assigned to the private attribute of the base class. Okay, so now my private attribute is having the value of 10. Okay, so we are here. We just finished this line. Then using that same object, I call the show private attribute function. So I can call this function because I create an object of the derived class. So this function is called. Therefore, this message is shown, private attribute value, and then the get private attribute function is called, and it is going to simply return the value for our private attribute, which was 10. Okay. So we see in the output private attribute value is 10. Okay, so private attribute value, call it. Then instead of here, we are having the number 10 being printed. Why? Because this function is called, and this function is returning the value for the private attribute, which was 10. So 10 is being printed in the output. And how was 10? How was it possible to have number 10 there? Because we just create an object and we passed number 10 ourselves. Then we use the same object to update to call the update private attribute function. So this function is called, and number 20 is passed as argument because this function requires an argument. So number 10 is passed as argument to call the update private attribute function. Then in this function, we are calling this function again. We are calling the set underscore private underscore attribute function and passing the number 20 as the parameter. And whenever this function with the number is called, that number, which is 20 in our case, is assigned to our private attribute. So the private attribute is now being updated. Okay, we just updated the private attribute. Again, I call the show private attribute function to see if the modification is done or not. So we call the private attribute, we call the show private attribute function. This message is printed, private attribute value. Then this function is called, and simply it is going to return the value for the private attribute, which is 20 now. You see it in the output because we just updated it. So in this video, we reviewed how we can define a base class and a derived class. And also we learned how we can access the functions of a base class through the functions of the derived class. And also we learned how is it beneficial to modify or access a private attribute using functions in the derived class. Thank you for watching. Welcome back. In today's video, we would like to write a program that demonstrates multiple inheritance by creating a class that inherits from two different base classes and calling methods from both parents. So here is my first class called parent1, and it has one function called showMessage1. Whenever this function is called, we are having this print message from parent1. Okay. And then we are having the class called parent2, and whenever this parent2 is called, we are having a class called parent2, and this parent2 class has one function only, showMessage2. And whenever this function is called, we are having this message being printed in the output, message from parent2. So these are two parent classes, parent1 and parent2. Then we are having a class called child inheriting from parent1 and parent2, so inheriting from both parents. Then in this child class, I'm having one function that is called show all messages. And in this function, whenever this function is called, the show message 1, which is a function from parent1, and show message 2, which is a function from parent2, is called. So therefore, whenever this function is called, we expect to see the output of the show message 1. So show message 1 is called, and this print is showing message from parent1. Then show message 2 is called, and this print is in the output message from parent2. Okay, now we are creating an object from the child class, and the object name is C. And using that object, I try to access the show all messages function that is inside the child class. So when I run this code, we see that we are having message from parent1, message from parent2 is being shown in the output. Basically, we created an object from the child class, and using the same object, I called a function inside the child class. Okay. And using that function, we were having access to the message1 and message2 functions. Why? Because the child class was inheriting from these two classes. So if it was not having any inheritance from them, when I run the code, you see that we are having an error because it's not possible for a class to have access to another class functions if they are not having any relationship with them, between them, or with them. So this child class can only access the parent classes, show message 1 and show message 2, only if it inherits from them. So when I run the code now, we see that the output again is working. Thank you for watching. Welcome back. In today's video, we would like to write a program that defines a base class with a method and a subclass that extends the functionality of that method instead of completely overriding it. So here is my class called base. It has a function called showMessage, and it is printing this message whenever this showMessage function is called, message from base class. Okay. Then we are having a class called subclass that is derived from the base class, or let's say that inherits from the base class. In this subclass, we are having a function called showMessage again, but we are using the super function to access the showMessage function from the base class. Okay, so super dot show message, it is going to call the base class function show message. Then we are printing extend message from the subclass. So whenever this function is called, it not only calls the show message function from the base class, but also completes its function and do some further work. Here we are just printing this message. We can do some further work. So whenever the show message function in the subclass is called through the super function, it is going to call the show message function from the base class. Therefore, this message is shown message from the base class. And whenever the execution of this line is finished, it is going to go to this line saying that print extended message from the subclass. So this is how we can have the use of super function to call the show message from the base class. So this was the explanation. So let me create an object. So now I am creating an object from the subclass. Okay, so using that object, I'm calling the show message function, which is inside the subclass. Okay, when I run the code, first of all, we see this message from the base class. We see that this message is being shown, and then this message is being shown, extended message from subclass. Okay, extended message from subclass. So in this video, we learned that if we want to not completely override a function from the base class, we use the super function to call that show message function from the base class, and then we can continue performing whatever we would like to do. For example, we can have the print here, we can have some mathematical operations in the show message function here, etc. So we learned how to use the super function. Thank you for watching.
Welcome back. In today's video, we would like to write a program that uses operator overloading to redefine addition, subtraction, and multiplication operators for custom class, demonstrating polymorphism in action. So here is my class. It is called point. It has a constructor and it requires 2 arguments. So whenever an object of this class is created, the constructor is called automatically, and it is going to initialize our 2 attributes self.x and self.y. Then we are having the overload of addition operator here, and here it is going to basically have the x plus x and y plus y. So the first one is self.x plus other.x, self.y, and other.y. Basically, the addition operator, so when we are overloading in 2 objects, for example, we are having 2 objects and we would like to create the third object using the first 2 objects. And each object is having an x coordinate and a y coordinate. You're going to add their x and their y. I'm going to give you a numerical example so it will be more tangible. Then we are having the subtraction overload when we are having the x minus x and y minus y. We are having the multiplication x multiplied by x and y multiplied by y. Then we are having an str overload here that defines the string representation of for the prints when we are using the objects. So let me illustrate it with an example. Here we are having 2 objects being created. So the first one is P1, the second one is P2. The first one is having the points 2 and 3. So the x is 2 and 3 is y for the object P1. Okay. Then for object P2, we are having the x that is 4 and the y that is 5. Now that I'm creating the P1 object, its x and y, 2 and 3, are initialized to be attributes of the point class.
Then we are having the P2, which is an object of the point class here. And it's the X and Y that P2 represents. So 4 and 5 are initialized to be attributes of the point class when using the P2 object. Okay. Now I would like to create a third object using the information of the P1 object and P2 object. In order to do that, I have the object called P add, and it is equal to P1 plus P2. When it is equal to P1 plus P2, the addition overloading operator is called, and basically it is going to calculate the X and Y. But how is it going to calculate? So the P underscore add needs to have a X coordinate value and a Y coordinate value. Okay. In order to calculate that, the X of P1 and X is added to the X of P2. Y of P1 is added to the Y of P2. Okay. So here exactly the same thing is happening. In the add overloading operator, we are having the x self.x plus other.x, okay? Then self.y plus other.y. So it is going to add the x of P1 and P2 and y of P1 and P2. They are going to be calculated, and therefore the P add is going to have one x and y. Okay, so this x is calculated based on the x of P1 plus P2, and this y is calculated based on the y of P1 and P2. So we can do it only because we are using the overloading operator here. Otherwise, if I comment this part, we're going to have errors, because otherwise it's not possible to add two objects to create a third object. Okay, so now that I run the code also, we see that here, for example, for P underscore add, we are having the X and Y 6 and 8. 6 is 2 plus 4, which is 6, and 3 plus 5, which is 8. Okay, we did the calculation for addition. For the subtraction, we are having P1 minus P2. Again, the same thing is going to happen. The 2 is going to be subtracted from 4, and 3 is going to be subtracted from 5 using the subtract overloading operator. Then we are printing this fourth object, which is P underscore sub, and we see that -2 and -2 is being shown there. Why? Because 2 minus 4, it is going to be -2, so the x is -2. Then 3 minus 5, it is going to be -2, so -2 is being printed in the output there. Then we are having the another object, which is for the multiplication, P underscore mul. And basically it is going to have P1 multiplied by P2. So the 2 is multiplied by 4, their x is multiplied, and 3 is multiplied by 5, and their y is being multiplied. So now this calculation is done using this mul operator, and we see that, for example, x multiplied by x and y multiplied by y. Okay, so it's a coordinate wise multiplication, and also it's a coordinate wise subtraction, coordinate wise addition. Okay, so this multiplication is also calculated. So 2 multiplied by 4, it's 8, and 3 multiplied by 5, it's 15. Okay, and it is exactly what we expected here. So in this video, first of all, we learned how to use the operator overloading. We created two objects that are P1 and P2 from the point class, and each of them was having x coordinate and y coordinate. Okay, so P1 was having 2 and 3, P2 was having 4 and 5. And then we created the third object using the addition operator, and that was going to help us to have the x's being added to each other and y's to be added to each other. So 2 plus 4, it's 6, and 3 plus 5, it's 8, and this is assigned to p underscore add, and here we printed it out and we see that 6 and 8 is being there. Then we were having the subtraction, which was having the subtraction of p1 from p2. So 2 minus 4, it's minus 2. 3 minus 5, it's minus 2, is being printed in the output because we were having this line. And finally, we did the multiplication of P1 and P2. So 2 multiplied by 4, it's 8. 3 multiplied by 5, it's 15. And we are using this line to print the multiplication in this object P underscore mul. Thank you for watching. Welcome back. In today's video, we would like to write a Python program to create a counter of the letters in a string Python exercise. So here is my string. It is assigned to a variable called text. So text is a string which holds the Python exercise string. Okay. So now I would like to count the number of letters in this string. For example, I would like to know P how many times is being repeated, Y how many times it is being repeated, T, H, O, and etc. E, for example, here, etc. So in order to do that, first of all, I import the counter from the collections. Then I use the counter function, and in parentheses, I write down the name of my string, which is text. And it is assigned to a new variable called letter counts. And in order to display the result, I use the print function and put the letter counts in parentheses. When I run the code, we see this is the output. So it says E, small e, let's say lowercase e, has been repeated 2 times. P has been repeated 1 time, for example, Y 1 time, T 1 time, etc. But we see that the E, the capital E, is also there, and it is repeated 1 time only. So it distinguishes between the lowercase and uppercase letters. Now I have another one, for example, here, and this, for example, we can say this is Reza Shaheen from the Python coding class. Okay, so this is my second variable, and this is the phrase, or let's say the string that I save in text2. Now letter count2 equals counter text2, and here I print the letters underscore counts2. Okay, so letter count2. So when I run the code, we see this. This is the repetition that is used in this phrase, or let's say the string. First of all, we see 8 spaces. So you see this is the spaces 8 times. We are having 8 spaces. Then we are having H being repeated 5 times in this string. Then we are having I being repeated 4 times, S being repeated 4 times, T being repeated 3 times. So in this video, we learned that we can count the number of letters in any given string. If we want to do that, we can use the counter function, and in parentheses we write down the name of the string variable and assign it to another variable, and then print that another variable, so it will give us a number of letters that are occurring in that string. For example, here I was having the first string variable called text, and this was having Python exercise. I use the counter function, and in parentheses I put the text to count the number of letters, the number of occurrences of each letter,
and assign it to letter underscore count. And then here is when I print letter underscore counts in the output. We have E, P, Y, etc. until the end. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a counter from a list of elements. So here is my list called elements, and there are these elements inside of this list. For example, we are having apple being repeated 3 times, we are having banana being repeated 4 times, we are having orange being repeated 2 times, and we are having the grape being repeated only 1 time. So this is the list that I have. Now I would like to count the number of occurrences of each unique element. So I use the counter function, and in parentheses I'm having the elements. Okay, so we are going to count the elements of my list called elements and assign it to elements count. Finally, I'm going to print the elements count. Now when I print the output, we see that for banana we are having number 4, which makes sense because we were having banana being repeated 4 times. Then for apple, we are having number 3. So apple, we see that 1, 2, and 3. Orange, we see it's being repeated 2 times. And grape, we see that it's there only 1 time. So this is how we can use the counter function to count the number of occurrences of unique elements. So for example, we could have another list, for example, elements 2. And there we could have, for example, pizza. So here is pizza, here is pasta, here is pizza again. I'm sorry, pizza again. We are having, I don't know, we can have burger, we can have pasta again, we can have again pizza, we can have, for example, another food that we can name here. I don't know, we could have, for example, cola, let's say cola, and we could have burger, let's say burger, and another food that we could have here, for example, again, pasta, and then we could have, for example, chicken here. Okay, so this is my new list. There are some elements there. So you see that we are having pizza being repeated 3 times, we are having pasta being repeated 3 times, we are having burger 2 times, 1 cola, and 1 chicken. Okay, so it's a drink. Then here we are having the element counter 2, and we are using the counter function to count the number of occurrences of each unique element, and assign it to elements count 2 and print it in the output. So we see that it says pizza is being repeated 3 times, pasta is being repeated 3 times, burger is being repeated 2 times. We are having 1 cola and 1 chicken. So this is basically how we can use the counter function to help us count the number of unique elements in a list, for example, or in a string, etc. Thank you for watching. Welcome back. In today's video, we would like to write a program that creates a food name tuple. Why do we use name tuple? So they provide immutable and lightweight structures like tuples, but with named field. So it's better for readability of the code. And also it improves the readability, but allowing access via names like food.name instead of indices like food, and we are having the index 0. So it's more readable and understandable to anyone that food.name means what. For example, we're talking about the name of the food, but instead food with the index 0, we need to think, okay, what was the name that we put, what was the name of the food that we put for the first index, for example. So it's more readable, okay, this way. So now here, in order to use the name tuple, we need to import it from the collection module. and here we are defining a name tuple for food. So each name tuple is going to have a name and a price, and the name of the name tuple is food that we are having it here in my code in this line. And this is the keyword for name tuple. So whenever we want to create a name tuple, we need to use this keyword. Then we are going to create a dictionary with food names as keys and food name tuple as values. Okay. So here the name is burger, for example. The name is pizza, pasta, salad, and sushi. And we see that different prices are there. So different prices. For burger, we are having the price 5.99. For pizza, we are having the price 8.99. For pasta, we are having the price 7.49. Again, for salad, we are having the price, and for sushi also, we are having the price here. So this is a name tuple that we are having here. So the food names are the keys and the prices are the values that we are seeing it here. Okay. So here we created the name tuple with names and prices, and here we are creating a dictionary with different food names here with their corresponding prices. Then we are having a for loop. So we are iterating through the food menu dictionary. In order to iterate through food menu dictionary, we know that in dictionaries we are having key value pairs. So food menu dot items will help us, the items function will help us to go through that dictionary with the key value pair. So food name is going to take the name, which is the key, and food info is going to iterate through the values. So food name is going to iterate through the keys, which are burger, pizza, pasta, salad, and sushi, and food info is going to iterate over the prices. So 5.99, 8.99, etc. until 12.99. So this is the iteration. So for example, in the first iteration, we are going to have the key equals to burger, and here we see that value equals to 5.99. So it means that in the first iteration, food name equals the burger and food info equals 5.99. Okay. Then in the second iteration, instead of having the key, I'm going to write down food underscore name. This one equals pizza. Okay. And instead of value, I'm going to write down food info because they are our iterating variable. So, and food info is 8.99. In the third iteration, we are having again the food name. This time it is pasta. And then the food info equals 7.49. Fourth iteration, we have the food name equals sushi, then food info equals 12.99. Okay, so this is what happens in different iteration here. So in the first iteration we are having the burger, then we are having the pizza, then we are having the pasta, then we are, okay, I missed the salad. So the fourth iteration is salad. This is the fifth iteration for sushi. Yeah. So fifth iteration, fourth iteration, food name equals salad, and then the food info equals 4.99. So the fourth iteration, this is a salad and its price, and then sushi and its price. So we learned here that we are iterating through the food menu dictionary using the items, meaning that we are going to go through the key value pairs, and this is the iterating variable for keys, food name, for example, pizza, pasta, salad, sushi, burger, and food info, which is the value that is for 5.99, 8.99, 7, etc. until the end. So when I run the code in the output, we see exactly what we estimated here. In each iteration, we are printing the food name and its price with a dollar sign. For example, it's $5.99. So we see that in the first one, we are having the burger, then pizza, pasta, salad, and sushi exactly as we expected. So this is how we can have the access to the names and also to the prices. And it's very good that we are using the name tuple because we are having the, for example, food.name instead of having the index 0, meaning that, okay, we need to remember the name of the food is stored in the index 0. And when you're having like hundreds of lines of code, it's very hard to remember which dictionary or list was having the food name, for example, in which index, etc. So it will become very complex. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that defines a named tuple with fields like name, age, and marks. And for the marks, we would like to have a list of subjects and marks. So here we see that we are having a class called student, which inherits from named tuple. So in Python, when defining a class that inherits from named tuple, the class itself acts as a structure immutable tuple. For example, writing a class student here with the inheriting from the named tuple means student inherits from named tuple automatically gaining tuple-like behavior without needing an explicit constructor method. So we don't need to have a constructor here when we are having the inheritance from the named tuple because it is going to automatically gain the tuple-like behavior. So here is my class. I have the name, age, and marks. And the name is a string. The age is going to be an integer. And we are having, for the marks, we are having the list as we were asked to. So a list of subjects and marks. So we are having the list. And here is the subject and marks. So a string and also the marks as an integer. So a string is for the subject. So it is going to be a list of tuples containing subjects and marks. Okay, a list of tuples that contain subjects and marks here. Okay, so now I would like to create an object of the student class. And here is called student1. So student1 is the name of my object, which is created from the student class. And because the student class inherits from a named tuple, we need to have these information in parentheses. So the name, age, and marks. So name is there, Alice, it's a string. Then age is there, we're having 20 as the integer, and then the marks is there. And we said for the marks, we're having a list of tuples. So a list of tuples, for example, math 90, this is one tuple. This is the second tuple, science 85, English 88. Okay, and all of them are in a list here. Okay, a list of tuples. So we created the student1 object with all these information, and we see that here, if we want to print the details, we can see the student1 dot name to access the name, which is Alice. Then we can have student1 dot age to access the age, and student1 dot marks to access the marks. So in the output, because we are using the print function here, we can see the student details, this message. Then the name is Alice, age is 20, and marks, you see that math 90, science 85, and English 88. And we can have another, for example, object from the student class, student. We can have the name, for example,
to be equal to Bob. The name equals Bob, age is 22, marks, math is 85, science is 92, and English is 89. Now if I want to print the information for the Bob, we can simply print here the student details, and then we are having the age student2 dot name. This time we are using the second object because we want to access the Bob's information. Then we are having the student2 dot age student2 dot mark. So when I run the code, we see that the student details again, Bob age is 22, and the marks are math 85. Then we are having the science 92, then we are having English, which is 89 here. So in this coding exercise, we learned how to have a class that inherits from named tuple library. And there we are having this information like the name, age, and marks. And marks is a list of tuples. We see that it's a list of tuples. So one tuple, the second tuple, the third tuple, etc. until the end. And then we created different objects for different students to store different information of each student individually. So we see that then we using the first object, we can access the name, age, and mark. We see them in the output. Using the second object, we can access the name, age, and the mark as well. So in this video, it was a good example to review name tuple and student and a class called student, and use a class in Python to inherit from the named tuple. Thank you for watching.
Welcome back. In today's video, we would like to write a Python program that creates an ordered dictionary and adds some items. We would like to, in the end, print the ordered dictionary content. In order to use the ordered dictionary, first of all, we need to import this library from the collection module. Then here is how we can create an ordered dictionary. So now I am creating an ordered dictionary called ordered dictionary. And in order to create it, we need to assign it to ordered dictionary function with empty parentheses. So on the right hand side, I'm having ordered dictionary function, and on the left hand side we are having the name of our ordered dictionary. So the name of our dictionary could be anything. It could be, for example, my dictionary. For example, we could have it like this, and now I need to replace it everywhere else here. Okay, so now the name of my ordered dictionary is my dictionary, and in order to create that, I'm using the ordered dictionary function. Now I would like to add some items to my ordered dictionary. And we know that because the dictionaries are key value pairs. Okay. So whatever we are going to have in our dictionary, it is going to be like the key and then the value. Okay. Another key, another value, etc. Okay. So now if I want to add items to my ordered dictionary, we should have the key and its associated value. Now, in order to add a new item, I'm writing down the name of the item, the name of my dictionary, sorry. So my dictionary is the name of the dictionary, then the name of the item. On the right-hand side, we write down the name of the value. So here now I am adding apple. So apple, and we are having number 3 as its associated value. Okay, so this is apple is the key and 3 is its value. So we are having the key apple and value 3 being added to the ordered dictionary called my dictionary. Then we are having this line, so we are having the banana here, and we are having number 5 being added to it. Then we are having another key called cherry, and its value is number 2. Then we are having the date, and its value is 7. So we see that we are adding these keys with their associated values to my dictionary. Okay, so this is my order dictionary after doing all of these addition that we did here. So here we learned how we can add keys and the associated value to my dictionary, which is an order dictionary. Okay, so now if we want to print the content of my dictionary, I show this message saying that order dictionary content, and this is it. Then, because we are having a dictionary which has key value pairs, we are going to have two iterating variables. So the variable key is going to iterate over the keys, which are apple, banana, cherry, and date. Then the value, which is another iterating variable, is the variable that iterates through the values 3, 5, 2, and 7. Okay, so the key is going to iterate over the names here, and the value is going to iterate over the values. So for each key and value in my dictionary, because we are using the key value per iteration, we use the items function to make it possible to have the key value per iteration. So for each key and value in my dictionary, we use the item function to iterate over them, and then we are having simply the key in each iteration and its associated value. So in the first iteration, for example, we are having the key to be apple and its value is 3. Why? Because we added the first apple and then its value is 3. Okay, so this is what we added. Then we are having the second iteration. Then we are having banana and number 5. Okay, in the third iteration, we are having cherry and number 2. In the fourth iteration, we are having date and number 7, meaning that, for example, we are going to have 3 apples, 5 bananas, 2 cherries, and 7 dates. Okay, so and we know that in order dictionary, it can when we have an order dictionary, it can remember the order in which we inserted the data and the keys and the values. This is why when we are inserting first apple, apple is the first key in our order dictionary and its associated value is 3. Then we inserted banana, so banana is the second key with its associated value in our order dictionary. So we see the order dictionary in the output here as well. So in this video, we learned how we can create an order dictionary, insert items with their associated value to our order dictionary, and also we learned how we can iterate through an order dictionary for the key value pairs. Also, we reviewed that we know when we are working with order dictionary, they are going to remember the order in which we insert the key value pairs. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that assesses an item in the order dictionary by its key. And we would like to check if a specific item exists in the order dictionary as well or not. So first of all, we're going to import the order dictionary from the collection module. Then here is the creation of my order dictionary. So we are having an order dictionary called order dictionary. And we can change the name for the sake of simplicity. We can say, for example, uh, ordered dictionary 2, for example, just for the sake of simplicity. And we can give it any name that we want. It's not an issue. So I create an order dictionary using the order dictionary function, and the name of my order dictionary is order dictionary 2. Then it has certain keys with associated value. For example, we're having apple, For with the value 3, we are having banana with the value 5. We are having cherry for the with its value, which is 2, and we are having the date with its value, which is 7. So 4 keys and the associated value. Then, in order to access an item by key, we can say, for example, we see that banana is already there. We are having a new variable or a string called key to access, and it is assigned to banana. Banana is assigned to this key to access variable. We would like to check to see if this key to access, which is banana, exists in the ordered dictionary too or not. So we write down if key to access in ordered dictionary, or in other words, we can say if banana exists in our ordered dictionary. If so, if this statement is true, print this line for me. The value of the key to access, which is banana, the value of banana is, and in order to understand its value, we are going to write down the name of the ordered dictionary and the name of the key. Okay, so here we are saying that the value of banana, because banana equals key to access, is, then because we want to extract its value, we're going to write down the banana from the ordered dictionary too, so it is going to give me its value. So when we see the output, we see the value of banana is 5. So we see that we are having 5 bananas here, and we are accessing it here easily. So we check first of all to see if that key to access, which is banana, is in the ordered dictionary. If so, we simply the value of banana is, then here we are going to execute it and access its value. So the value of banana in the ordered dictionary 2 is being printed. And if the key is not in the dictionary, we are going to say this message. We are going to print this message, simply saying that that key to access is not found in the ordered dictionary. For example, if we are talking about, for example, pineapple, and we don't have the pineapple here, you see, and key to access equals pineapple now. And then we are checking to see if pineapple is in the ordered dictionary. Is this sentence true? No, it's not true. Therefore, we go for the else part and we write down pineapple is not found in the ordered dictionary. So pineapple is not found in the ordered dictionary. But if there is something that is already there, this statement will become true and this line is executed. Then we would like to check if a specific item exists or not. For example, here we can say in this line we were trying to check if an item exists. If so, I would like to know its associated value. But here we simply want to just check to see if grape already exists in the ordered dictionary too or not. So we check here if grape is in the ordered dictionary too. If this statement is true, we don't have the grape here. But if this statement is true, we are going to print this message saying that grape exists in the ordered dictionary. Else, we are going to say grape does not exist in the ordered dictionary. Okay, so we are going to say if grape is in the ordered dictionary. Is this a statement true? No, it's not true because grape is not there. We are only having apple, banana, cherry, and date. Therefore, this statement is not true. We go to the else part, and here we are going to have this message. The grape does not exist in the ordered dictionary, which is exactly the message that we are having here. Grape does not exist in the ordered dictionary. So this is how we can also check to see if, for example, certain item exists in our ordered dictionary or not. Then in order to have all the items of the ordered dictionary to be printed, we can simply use a for loop. So for each key and value in the ordered dictionary, we're going to use the items function to access an iteration for both keys and values in the ordered dictionary too. In each iteration, we are going to print the key with its associated value, which is apple and 3, banana and 5, cherry and 2, and date and 7. So in this video, we learned that how we can check if an item exists or not, and if so, how we can have access to its value. Also, we learned that how we can have an iteration over the key value pairs in our order dictionary. And here we see that the key and value in each iteration is being printed. For example, in the first iteration here, key equals apple, and we are having the value equals 3. Okay, so key equals apple, value equals 3. Then we are having key equals banana, its value is 5 in the second iteration, third iteration, and finally the fourth iteration. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates two counter objects and find their union, intersection, and difference. So in order to work with the counter, we are going to import the counter from the collection module. Then we are having two counters here being created. So two counter objects are being created here. The first one is called counter1, and it has 3 apples, 6 bananas, and 5 cherries. And in the counter2, we are having 1 apple, 4 bananas, and 2 dates. So this is what we have here. Then this is what we were required to do. So create two counter objects. Then we would like to find their union. So this is the first thing that we are asked to do. In order to find their union, we need to write down the name of the first counter, which is counter1, then pipe operator, then counter2. So this is going to calculate the union, and they're assigned to union counter. Okay. So this way, for the union, we are going to have the maximum count of each element. Let me go to the results. So first of all, we are printing counter1 and counter2. So this line is counter1, this line is counter2. So we see here 3 apples, 6 bananas, 5 cherries, 6 bananas, 5 cherry, and 3 apples. And we see that 1 apple, 4 bananas, and 2 dates, 4 bananas, 2 dates, and 1 apple. So counter1 and counter2, they are being printed here. Okay. Then we are having the union counter being printed here that we created here using the pipe operator. So it is going to return the maximum count of each element. The union counter, we see that here we are having the maximum elements, count of each element. So banana, we are having its value 6 because we are having 2 bananas, 1 6, 1 4. So the maximum is the 6. So we are going to report banana 6. Then we are having cherry, which is 5. Then we are having the date, which is 2. And also apple, which is 3. So among all these elements, we're going to report the maximum. Cherry, what is the maximum? We are only having 1 cherry. I mean that the cherry is only in counter 1, it's not in counter 2, and the maximum is the 5. So we are having 5 cherries. This is why we are reporting it here. Regarding the date, do we have any other dates here in another counter? No, so the maximum number is 2. And with respect to banana, we are having 6 bananas and 4 bananas in counter 1 and counter 2. So we are going to report the 6 bananas, which is from the counter 1 because we report the maximum count of each element. And also with respect to apples, we are having in both counters, we are going to have 3 apples, which is here, and it is coming from the counter 1. So this is how we are calculating the union. So basically for union, we are going to use the maximum count of each element. So this is union. Now we would like to discuss the intersection. Now that we would like to discuss intersection, we can have counter 1 and operator and then counter 2. Okay, so counter 1 and operator counter 2 in order to calculate the intersection, and it is assigned to intersection counter. Basically, it is going to calculate the minimum count of each element. So intersection is being printed here. We see that here when we are having the intersection counter, the minimum count of each element is shown. So banana, we are having 6 and 4. So what is the minimum? It's 4 bananas. So 4 bananas is there.
We are having apples that is shared between both counters. So we are having 3 apples and 1 apple. So we are going to have 1 apple only. One thing that we need to be careful about with the intersection is that we are going to discuss the elements that are shared between both counters. And now this is why we don't have cherry and date in the output, because they are not shared in both counters. Only banana and apple are shared, and we are going to report the minimum elements. So banana 6 and 4, we are going to report 4. Apple 1 and 3, we are going to report 1, because in intersection we are working with the minimum count and we see it here. Okay. And finally, they were asking us to have difference as well. So we are going to have the difference. So it means that elements that are in counter 1 but not in counter 2. So we are having the difference counter 1 minus counter 2. So counter 1, we are having 3 apples. Here we are having 1 apple. So 3 minus 1, it will be apple that it will result in having 2 apples. We are having 6 bananas and 4 bananas. 6 minus 4, we are going to have 2 bananas. And finally, we are having cherry that is in the first counter and not in the second counter. So we are going to have cherry in the output as well. So in this video, we learned how to create 2 counter objects that we are having it here. And we reviewed about the finding their union, intersection, and difference. We learned that if we are working with unions, we need to use the pipe operator. If we are working with intersection, we are going to use the AND operator. And if we are working with the difference, we are going to have the subtraction sign or operator. And something to mention here is that the elements that are in counter 1 but not in counter 2 is going to be calculated like this. Thank you for watching. Welcome back. In today's video, we would like to write a Python program that creates a counter of the vowels in the word Python exercises. So here is my phrase, here is my string. It is called phrase, and we are having this string Python exercises. This Python exercises is assigned to the phrase string. Then we are calling the count vowels function and passing that phrase as the argument. So when the compiler sees this code, it is going to call the count vowel function and start executing it. So first of all, we are having the vowels here. We are defining our vowels both in uppercase and lowercase. Then we are having our counter being initialized to be 0 because we are going to count how many vowels are there in this phrase. So the counter is initialized to be 0. So in the beginning, we assume that there is no vowels inside this string, but we are going to check and update the vowels using for loops. So now our phrase that is holding our string, okay, Python exercise is a string assigned to the variable called phrase. That phrase is passed as argument to the count vowels, and here we call it word. We can call it whatever. So we are iterating that word for each character that is inside that word, meaning that there are different characters. So in the first iteration, we are having, for example, in the first iteration, we are having P. In the second iteration, we are having Y. In the third iteration, we are having a T. In the fourth iteration, we are having H, for example, etc. until the end. So in each iteration, we are going to move character by character from our string P, T, H, O, N, E, X, E, R, C, I, S, E, and S. So these are the characters we are going to loop through, character by character that is inside this word string. Okay, so And we are going to check in each iteration if character is in vowel or not. So in the first iteration, we are having the P, and we check to see if P exists in vowels or not. P, is it there? No, it's not there. Because it's not there, nothing is going to happen. Therefore, this counter is not going to be increased. So we go for the next iteration. Then we are having the Y in the second iteration. So here in iteration, we are checking to see if, for example, Y is in the vowels or not. So in the second iteration for the for loop, we are having character, which is Y, and we check to see if Y is inside the vowels. Is it there? No, it's not there. We go up. Then we are having the third iteration, which is T here. Okay. So T we are having, we check to see if T exists here. No, it's not. We go up again. We go for the next iteration. Then we are having the H. We check to see if H is there. No, it's not there. Then the next character in iteration, in the fifth iteration, is O. So we check to see if O is there. Yes, O is there actually. In the fifth iteration here, we are having the O. And here we check to see if O is in the vowels. Okay. Is it there? Yes, it's there. So we are having the lowercase o here and we are having the lowercase o here. So it's there. So this statement is true and we are going to increase the counter. So now the count equals 1 after this update. So we go up again. We go for the next iteration. We are having N. N, is it there? Is it in this vowel? No, it's not there. So we are going to repeat, etc. until the end. And in each iteration, we check to see if any of the characters here is already inside this vowel strings or not. So for example, here we are having the E. We check to see if E is in vowels. Yes, it's in vowels. So we are going to increment the count. And whatever the output of this function is, we are going to have the count. So as the output of this function, after doing all the iteration, we are updating in each iteration the count, and we are going to return the count here in the count vowels function. Okay. The count vowels function, we are going to have the return of the count. So it is going to count how many vowels do we have in our string. And this was the place where we called the count vowels function, and the output of this function, which is the counter, is going to be assigned to vowel count, and finally we are printing the vowel count, and we are saying that the number of vowels in our phrase here, the Python exercise, is 5. We could have, for example, the shorter string. For example, we are having Reza here. So when I run the code, we see that the number of vowels in Reza is 2 because we are having one E and one A. So in this iteration, we are looping through all the characters in this string, which is REZA. So R is not there. E is in the vowels. So E in the next iteration, we see it's in the vowels. So we increase the counter to 1. Then Z, is it in the vowels? No. So we are going for the next iteration. Then in the next iteration, we are having A. A is already in the vowels, and therefore we are going to increase the counter one more time. So basically, this function is work in a way that we are having a string called vowels, and we are having a counter initialized to be 0. We are going to loop through the character of this string. So we are going to character by character and we check to see if any of the characters in our phrase is inside the vowels string or not. If it's inside there, we are going to increment the counter by 1, meaning that we found one vowel in our string. Otherwise, we are going to go for the next loop, etc. until the end. And finally, in the end, we are going to have the count variable, which has a number representing the number of vowels that we have in our code. Thank you for watching. Welcome back. In today's video, we are going to have an inheritance with a school system with teachers and students.
Here is my base class called person. In this class, we're having a constructor, and in this constructor, there are two arguments, name and age. And basically, whenever we are creating an object of the person class, we need to pass two arguments, and these two arguments are going to be used to be assigned to the attributes of our class, which are self.name and self.age. Also in the person class, we are having a function called display info. And whenever this function is called, basically it is going to show the name attribute and the age attributes. Then we are having a derived class or a child class, let's say, called student from person. So it inherits from the person class, or it's derived from the person class. So person class is a base class for the student. Here we are having a constructor, and for this constructor, we are having three arguments, name, age, and student ID. So whenever we are creating an object of the student class, the constructor is going to be called automatically, and three arguments are needed to create an object from the student class. We're going to have some exercises with respect to this, but first of all, I'm explaining what's happening in my code. So we need three arguments, name and age and student ID. So we are going to have the student ID being assigned to the attribute self.student ID. However, with respect to the name and age, we are going to use the super function to call the constructor of the base class. Okay, when using the super function, we are able to call a function from a base class, from our base class. So I use this super function to be able to call a function from the base class, and that function is my constructor. So I'm calling the constructor of the base class using the super function and passing two arguments, name and age. So the name and age that were passed as arguments when creating an object of the student class, they are going to be used to call the constructor of the base class with these two variables arguments, and these two are going to be assigned to the attributes of the function. So whenever I'm creating an object of the student class, the constructor is automatically called. We need three arguments. The first two arguments are used to call the constructor of the base class using the super method. And there we explained that the name and age are going to be used to uh, be assigned to the attributes of the function. And the third argument here is going to be assigned to the argument of the person class, which is student ID, self.student ID. Also, we are having a function here called display info. And whenever this function from the student class is called, it is going to say student name and then show the name, the age, and the ID. Finally, we are having another derived class called teacher. It inherits from the person base class. And whenever we are creating an object of the teacher class, again, the constructor is called. It needs three arguments, name, age, and subject. Again, name and age, the first two arguments are used to call the constructor of the base class person using the super function. Without super function, it's not possible, so we use super function to be accessible, so we can access and call this constructor of the base class. And then the third argument, which is subject, is assigned to our attribute here. Finally, we are having a function here called display info, and whenever this function from the teacher class is called, it is going to show this message, teacher name, age, and subject. Okay, so this was an overview of what's happening inside my three classes. One of them is the base class, and the other two are the derived class, or let's say the child class. Then we would like to create our objects. So first of all, I'm creating an object called student from the student class. So student is the name of my object on the left-hand side, and this one is the name of the class. And as we discussed, we are having three arguments, name, age, and student ID. Why three arguments? Because we mentioned that here, because we are having a constructor in the student class, apart from self, we are having three arguments. Sorry, three arguments we are having here. And therefore, these three arguments
are required when creating an object of the student class. So Alice 20 and a student ID is passed. Alice and 20, name and age, are used to be called the constructor of the base class using the super method. And whenever this is called with two arguments, these two arguments are assigned to the attributes of the class. Okay. And the third argument, which is the student ID, and the student ID, when it is used, so here is the student ID and here is my student class. So a student ID is passed as the third argument and it is assigned to the self.student ID attribute of the class. So now I created an object. The constructor automatically was called from the student class and all the initialization have been done. Now I want to create an object from the teacher class. So the name of my object, which is written on the left hand side, is teacher, and from the teacher class, and we are having three arguments here as well: name, age, and subject. So Mr. Smith and 40, the name and age, are used to call the constructor of the person class, the base class, using the super method. So Mr. Smith and age are initialized to our attributes, are assigned to our attributes, and the subject, which is mathematics, is assigned to the self.subject attribute of the teacher class here. Okay, so now we created two objects of two different classes, one from the student and one from teacher. Now we would like to access this information and see the information in the output. This is why we are having the display info functions in our classes. So I use the first object, which is a student dot display info, to access the display info function from the student class. Then we are having the teacher object, which is my second object, to call the display info function from the teacher class. So basically, and we are calling them inside a print function. Therefore, we are going to see them in the output. So we see that here we are having the student name Alice 20, and this is the ID, and we are having the teacher name Mr. Smith, the age is 40, and the subject is mathematics. So in this video, we first of all reviewed the concept of classes, derived classes, or let's say the child classes or inheritance, we can say that. And then we also reviewed how we can benefit from inheritance and use the super method to access a function that is inside the base class. And also we reviewed how we can create an object of our classes and use them to have access to the functions inside the classes. Thank you for watching.
Hello everyone, welcome to this section. In today's video, we are going to talk about for loops. So a for loop is used to iterate over a sequence or a range of numbers. So the for loop iterates through each element in a sequence, performing an action for each element. The range function in Python is often used to loop over a sequence of numbers. Later on in higher level classes and courses in Python, when we are going to learn about list, tuple, dictionary, and set, then we can also integrate for loops with them as well. So a for loop can iterate over a list, a tuple, a dictionary, or a set. But this is something that we're going to discuss in higher level courses. For now, we are going to learn how to use the range function in Python to iterate over a range of numbers. Let me illustrate it with an example. So now we would like to write a program that prints numbers from 1 to 5 using a for loop. This is the statement of our program. So in order to use the for loop, we have the keyword reserved in Python for. Then we are having the I. It could be anything that we want. We choose our iteration variable to be I. And then we are going to use the in keyword reserved for this. Range is the function of the Python that we are going to use, and the range is divided by a comma. So there are two ranges in parentheses that we are going to have when using the range function: the starting point and the ending point. So let me run this code. When we run this code, this I is going to iterate over this range for us. One thing to mention is that the starting point in Python for range function is inclusive, but the ending point is exclusive. It means that it is going to iterate over for all I in the range between 1 to 6, but it is going to iterate over 1, 2, 3, 4, and 5, and not 6, because the end is exclusive. So it is the start point that is inclusive, okay? And then we are going to print I. So in the output, we are having number 1 to 5 being printed out. But how does it work? So let me put some comment here. So for the first time, we say that we are using this range function. And when we are having the range function, we need to choose the start point and the end point, okay? Start point, end point. And when we are going to have the range function, for example, here we would like to go over numbers from 1 to 5. So the starting point is 1, and it is going to include 1 because it's a rule in Python. So the starting point is inclusive. So it is going to start from 1 and it is going to iterate until it's 5. But because if I write down 5 here, because the end point is exclusive, it is going to iterate over 1, 2, 3, and 4, and not 5, because the end point is exclusive. Okay, so I'm going to put 6 here, therefore it is going to go until 5. So this is how the range function works. And if I want to explain further, we see that for the first time I get the value 1. Okay, when I equals 1, it is basically having this print function being implemented, because we are having print, and in the parentheses we are having I, and I equals 1, so we are going to print 1 in the output, and we see it here. Okay, and then it goes up back again, and I now equals 2. I now equals 2, and it is going to print 2 for us, and we are having it here, and it goes up again. I is incrementing, and we are having the I equals 3, print 3, I equals 4, print 4, and finally I equals 5, print 5. So this is basically what happens in each iteration in this for loop, that we are having this output here. So in this lesson, we learned how to write a for loop. We are having a for keyword and one variable to be defined here, then using the in keyword and providing the range, a starting point and an ending point. Starting point is inclusive and the ending point is exclusive. So if I type down until 6, it is not going to go for the 6th one, it is going to go until 5, okay, until the end of 5, including 5. And for this loop, I am printing I. So I, the first, when it starts, because it starts from 1, I equals 1, it is printing 1. Then I is 2, I is 3, printing 3, I is 4, printing 4, I is 5, printing 5, and that's it. It is finished. The for loop is finished, and these are the output of our program. And one thing to mention here is that this is the range function that we are using to iterate over a range of numbers, and it has two parts in the parentheses, starting point and ending point. They are separated by a comma. In the next videos, we are going to discuss further practical coding exercises, so you would get used to the syntax of loops, of different types of loops, including for loops. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to talk about nested loops. So a loop inside another loop is called a nested loop. A nested loop is useful for working with multi-dimensional data like matrices. The inner loop runs completely for each iteration of the outer loop. Let me illustrate it with an example. Here I'm having a for loop for variable I iterating between range 1 and 3. I'm having another loop which we call inner loop. So the first one, the loop for the I is outer loop, the loop for the j is inner loop. So we are having another loop here that ranging from 1 to 4, okay? And we are going to print I and j. So if I want to illustrate this, so I equals 1, it enters, when I equals 1, it enters this part. And when it enters, j equals 1 as well. So it is going to print 1. So it is printing 1 and 1, okay, as you see here in the output in the first line, okay. Then I still equals 1, but j is going to increase its value. So j equals 2. Why? Because we are in the outer loop. So when we enter the inner outer loop, the outer loop is 1. So I equals 1. However, when I equals 1, we are going to iterate over all the values that j can take first. And when that is finished, we are going back up again to the outer loop and then increase the value of I. Okay, let me illustrate it with this explanation. You will get what I mean. So I equals 1, j is going to increase from 1 to 2. Therefore, it is going to print 1 and 2 as you see here in the output, the second line. Then I equals 1, j equals 3. It is going to print 1 and 3 in the output as you see here, okay? So the maximum number that I can get is I can be equal 1 and 2. J can be equal to 1, 2, and 3. Because the starting point is included, this is why I gets the value 1, but the ending point is excluded. So it is going to exclude number 3, so it is going to iterate over 1 and 2. The same logic goes for j, so it is going to iterate over 1, 2, and 3. So when I equals 1 in these three scenarios, we are going to iterate over j equals 1, j equals 2, and j equals 3. As you see here, I equal 1, j1, I1, j2, I1, j3, okay? And we are going to print I and j using this line. And when all the values for the j is tested for the inner loop, we are going to go back up again and increase the value of I one time. So I equals 2 now. So now I equals 2, j starts from 1 again. J is 1. So 2 I2 J1 I2 J2 I2 J3, okay? So we're going to print 2 and 1. I equals 2, J equals 2. It is going to print 2 and 2 for us. And finally, I equals 2, J equals 3. It is going to print 2 and 3 for us. So this is what we see exactly in the output. So let me go back over the code one more time. So we are having one outer loop and one inner loop. So the outer loop is iterating over different values between 1 and 3 for variable I. The inner loop, it is iterating for variable j between 1 and 4. Okay? And in each iteration, we are going to print the value of I and j. So the first time when we enter the outer loop, I equals 1. However, when I equals 1, we are going to iterate over all the j's. So one time I1, J1, I1, J2, I1, J3. Then we are going to increase the value of I when all the values of j are tested. We are increasing the value of I from 1 to 2. So we are having 2, 1, 2, 2, and 2, 3. And we are printing them in the output as you see here. Basically, this is the concept of nested loop in Python. Thank you for watching. Hello everyone, welcome back. In this video, we're going to talk about while loops in Python. So a while loop repeats as long as a specific condition is true. So the while loop requires a condition to be true, and if the condition becomes false, the loop stops. So we need to be careful to avoid infinite loops by ensuring the condition eventually become false, okay? For example, here we're going to print numbers from 1 to 5 using a while loop. Exactly the same exercise as the previous video, but here instead of for loops, we are going to use while loop. So I'm initializing I variable to be 1 before starting the loop, and then I'm having the while keyword, and then the condition here and colon here. Okay, so three parts: the keyword while, the condition here, and the colon. Okay, so I'm going to write down while I is lower than or equal to 5, do these things for me. Okay, while I is lower than and equals to 5, print I, and then increase the value of I by 1. Okay, this sign, let me plus equal, it means that when I'm typing down I plus equal 1, it means I'm typing down I equals I plus 1. So they are basically the same in Python. So I equals I plus 1 is exactly, it is going to do the exact thing as I plus equal 1. Okay, but because it is more concise and more and shorter, we're going to use this way of writing it. But whenever you see this, it means this. Okay, you can type it down somewhere in comments for yourself for a while to get used to it. So let me illustrate it with an example. Initially, I equals 1. And when we are going to enter this condition, it checks to see 1 is lower than 5. Yes, it's true. So print I. So it is going to print 1 for us. And then in the next line, we are having I equals I plus 1. It means that I equals 1 plus 1. Therefore, I equals 2. Okay, so this line is exactly like this line. And basically, it means that I equals 1 plus 1. Why? We already have 1 here, so this one is that one. And we also have this I here, and I initially equals to 1. So when it equals to 1, we are typing down here. So now I equals to 2, okay? So we incremented the value of I by 1 value. So now I equals 2 at the end of this loop, and it is going to check the condition again. 2 is lower than 5, yes. So it is going to print 2. Then it is typing down I plus 1. Okay, so it means that I equals 2 plus 1, therefore I equals 3. But why 2 plus 1? Because we are having this formula, I equals I plus 1. So I equals 2 plus 1. This plus 1 is exactly the same thing here, but we are having 2 because we entered this loop initially using I equals 2, because this is why we were printing 2. So 2 plus 1, now I equals 3. I equals 3, we are going up here again and we are checking the condition. 3 is lower than 5. Yes, it is lower than 5. So print 3 for me. Print 3, sorry. And then I equals 3 plus 1. I equals 4. Okay. And here 4 is lower than 5. Yes. So print 4. I equals 4 plus 1. I equals 5. 5 is lower than or equal to 5. Yes. So print 5. And then I equals 5 plus 1. I equals 6. So I equals 6 now. 6 is lower than or equal to 5? No. It's not, therefore it is not passing this condition, and thus it is not going to enter this loop anymore. So this is not an infinite loop, because we mentioned here we need to ensure that the condition eventually becomes false here, and now it becomes false because I equals 6 and 6 is not lower than 5, therefore the condition becomes false. And now when I run this program, you see here I'm printing 1 to 5 here. So let me explain it one more time. If we want to have the while loop, we need to initialize the variable a priori to the while loop. So I'm initializing this I here, then I'm having the keyword while, then the condition and one colon, sorry. And as long as I is lower than or equal to 5, I'm going to print the value of I and increase the value of I by 1 unit. And when I'm having I plus equal 1, it means that I plus equal 1, it is exactly equal to this equation, I equals I plus 1. But because it is shorter, we are going to use this one. But we could use this one as well, okay? So when I equals 1, I print 1 and I increase the value of I by 1 value. So 1 plus 1, it's 2. 2 is lower than 5, yes. So print 2, and 2 plus 1 is 3. So 3 is lower than 5, yes. Print 3 for me, and 3 plus 1 equals 4. So 4 is lower than 5, print 4. 4 plus 1 is 5. 5 is lower than or equal to 5, yes, print 5. Increase the value of I by 1 value, so 5 plus 1 is 6. And 6 is lower than or equal to 5, no. So it's not going to enter this while anymore. But what happens if I comment this line? So if I comment this line, it is going to have I equals 1. It is going to say 1 is lower than 5, yes, print 1. And go up again because we commented this line, okay? I still, it is 1, okay? 1 is lower than 5, yes, print 1. Again, it goes up back again. 1 is lower than 5, yes. So we are not changing the value of I, so it becomes an infinite loop. So when I run this code, you see it is simply printing 1 again and again. So it is not going to finish because it's an infinite loop. So I need to stop it, okay? So I need to interrupt it. You see how many 1 it has been printing? Let me go up again. It's not going to finish. So when I go up, oh la la. Okay, so we need to make sure that it is not an infinite loop and it is going to end at some point. This is the important part when we are having the while loop. Thank you for your watching. Hello everyone, welcome back. In this video, we are going to talk about break statement. So a break statement is used to exit a loop, even if the loop's condition is still true. It is useful when we want to stop the loop based on certain conditions. So let me illustrate it with an example. We would like to stop the loop when the number equals 5, okay? So we are going to have a for loop. It is going to iterate over I in the range 1 to 10, and we are having the colon here, and we are having one if statement. So if I equals 5, break. If I equals 5, break. Otherwise, print I. Okay, so when I run this code, it is printing 1, 2, 3, and 4. So let me illustrate what's happening here. So I equals 1 in the first time, and it checks to see 1 equals 5. No. So when I say no, it is not going to break because it's not going to enter this part of the if condition. So this is the if condition. This is the statement that is going to be executed if this condition is true. So in the first run, I equals 1. 1 equals to 5. No. Therefore, it is not going to do anything here, and it is going to jump here and print 1 in the output for us. Okay. So print 1. Then I'm having I equal 2. It checks to see 2 equals 5. No, so print 2. I 3, print 3 because 3 is not equal to 5. And I equals 4, print 4. However, when I equals 5, it checks here. 5 equals 5. Yes? Yeah, that is true. So when 5 equals 5, it is going to execute this part of the code. So it is going to break. When it breaks, it means that it exits this for loop. Okay, so it is going to exit this part and it is going to come here where we have nothing more to execute. So this is why when I equals 5, it is not printing anything for us because this print comes after the break. But if this print comes before the break, it is going to also print the 5 for us. But it is now, let me put it here. So when I put the print here and I run the code, you see that 5 is also printed because when I equals 5, it is going to first print 5 and then checks to see if 5 equals to 5 and then it is going to break. Okay, so it's important for you to know where to put the break and how the output of the program could be different based on where you're putting the break. So when I have the break before the print, when I equals 5, it is not going to print 5. But when the print is before the if condition, it is first going to print 5, then break the loop, so it is not going to go for the I equals 6, 7, 8, and 9 because this loop was supposed to go from 1 to 9. I'm saying 1 to 9 because the endpoint is exclusive, so 10 is not going to be considered. It is going to go from 1 to 9. So it is when we are having I equal 5, it is breaking, so it is exiting the loop. Therefore, I equals to 6, 7, 8, and 9 are not executed here. Okay? So this is how we can use the break statement. When certain conditions are met, we can have the break and exit the loops. Thank you for watching. Hello everyone, welcome back. In this video, we are going to talk about continue statement. So the continue statement is used to skip the current iteration and move to the next one. It allows the loop to continue running but skips executing the rest of the code for the current iteration. Let me illustrate it with an example. So we would like to write a program that skip even numbers. Okay. For that, we are looping over all values for variable I in the range between 1 and 6. And if this I variable is divided by 2 and the remainder of this division equals 0, we're going to continue. Otherwise, if this condition is not passed, we're going to print I. So let me type down this I equals 1, I equals 2, I equals 3, I equals 4, and I equals 5. Okay, so these are the values that I is going to iterate over. So for the first time, when I equals 1, it basically mentions, sorry, let me put this. Okay, 1, if 1 is divided by 2, the remainder would be equal to 0. It is checking this condition. Is it true? No, because it's not true. It is going to print 1 for us. So in the output, we will have the print 1. Okay. Then it moves to the next number. So I is incremented by one value. So we are having if 2 divided by 2, the remainder of this division equals 0. Yes. So when it is yes, it is going to continue. So this condition is passed. Therefore, it is going to skip this iteration. So it is not going to print anything for us in the output. So it is going to skip, it is going to continue. Nothing happens. Skip this iteration. Okay. Then it is going to increment the value of I one more time. So I equals 3 now. So 3, if it is divided by 2, the remainder of this division, is it equal to 0? No. So it's not equal to 0. Therefore, it is going to print 3 in the output. Then I equals 4. 4, if it is divided by 2, the remainder would be 0. No. The remainder would be 0. Yes, sorry. So therefore, it is going to skip this iteration again. And finally, when I equals 5, 5 is divided by 2. The remainder, is it 0? No, so it's not 0. Therefore, it is going to print 5 for us. So looking at the output, we see that it is skipping the even numbers. It is printing 1, 3, and 5. So let me run the code one more time. So we are printing 1, 3, and 5. You see here in the output, we are having 1, 3, 5. As we expected, we are printing 1, nothing happens, printing 3, skip this iteration, and printing 5. Let me go through the analyzing of code one more time. So we are having a for loop starting from I in the range between 1 to 6. So I is going to take values between 1 to 5, okay, between 1 and 5. So in case that when we are entering this loop, if I is divided by 2 and the remainder of this division is equal to 0, do nothing and go back up and increase the value of I. Continue is doing basically this thing. Otherwise, print the value of I. So 1 divided by 2, the remainder is 0? No, because it's not an odd number. It's not an even number. So the definition of even number is when it is divided by 2, the remainder must be equal to 0. Therefore, when this does not happen, the number is odd. So by having this line, we can understand if a number is odd or even. So if one number is divided by 2 and the remainder of this division equals 0, it means that that number was an even number. So we are saying that 1 divided by 2, the remainder equals 0. No, so it's not 0, therefore it is not going to continue, it's not going to enter this condition, and it is going to print I, and I was 1, so it is printing 1 in the output, okay? Then I equals to 2. 2 is divided by 2. The remainder equals 0. Yes. When the answer is yes, continue. When the answer is yes, so this condition is passed. So it is entering this part. Okay. When entering this part, it says execute the continue statement. And continue statement means that do not execute the rest of the code for the current iteration. Okay. So for the current iteration, it does not execute the code. It goes back up and I is incremented by one value. So I equals 3 now. 3 divided by 2, the remainder equals 0. No, because the answer is no. It is going to print I here. It is not going to enter the continue part, okay? Because the continue part is going to be executed whenever this if condition is true and whenever the statement of the if condition is going to be executed. So printing 3 here, and then for the 4, when I is equals 4, 4 divided by 2, the remainder equals 0. Yes, so continue and do not execute the rest of the code for current iteration. It goes back up, so nothing happens here as you see. I equals 5, 5 divided by 2, the remainder equals 0. No, so if the answer is no, print I for me, which is 5 here in the output. So this is basically how we can use the continue statement to skip the current iteration when certain conditions are met. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that asks the user to enter the price of 3 items one by one, and we would like to use a loop to collect the prices and calculate the total cost. To do that, we are initializing a variable called total cost to be 0. Then I'm using a for loop starting from I. So the I variable is initialized starting from 1, and ends at 3, because the start is inclusive and is exclusive. So if I type down the range between 1 and 3, I is going to take values 1 and 2, because the end, that 3, is exclusive. So therefore, if we want to ask for 3 items, we need to ask for the range of 1 to 4. So for any I in the range 1 to 4, we are going to ask the user to show the message saying that enter the price of the item 1, for example, item 2 and item 3, and whatever the user is going to enter is going to be converted to float and then be assigned to the price variable here. Okay, and the price variable here is going to be added to the total price. When we are having the plus equal sign, it means that total underline price variable equals to total underscore price plus price. Okay, so this equation equals to this one. They are doing the same thing, but it is a way to write it more concise. So you can write it down like this if it's a bit complex for you or confusing. So it means that the total price, the new total price, equals to total price plus the price. So in the first iteration, the total price equals 0, and the price is whatever the user is going to enter. So imagine that the user is going to enter prices are 20, 25, and 10. Okay, these are the prices. So when I equals 1, price equals 20. So the user is going, we assume that the user is going to enter 20. So total price equals 0 plus 20. Why? Total price, this is the formula, equals total price plus price. So the total price in the first iteration from before that, we know that total price equals 0. And then 20 is the number that we assume that the user is going to enter for the first product. So this means that total price equals 20. Okay. And in the next iteration, we are having this. For example, when I equals 2, price equals 25. This is just an assumption. And then we are going to, I'm assuming these assumptions because I want to give you a hint and a detailed examples, a detailed explanation of how this total price is being calculated. So total price equals total price plus price. So here it is total price plus price, and total price was 20 from the previous iteration, and the newly entered price is 25, so it is equal to 45 now. And in the last iteration, when I equals 3, price equals 10, because we assume that the user is going to enter number 10, and total price is calculated as the previous total price, which is 45, plus the newly price that is added by the user, which is 10. Therefore, the output will be 55. And we mentioned that in the output, after doing the calculation, we mentioned that total price is 55. So when I run this code, sorry, I'm having an error in this part here. So when I run this code, it asks me enter the price of the item. So I enter 20 first. Okay. When I enter 20, it says enter the price of the item again, because there are 3 items that we are going to enter. So the second item price is 25 based on my assumption here, and it again says that enter the item. I'm assuming that the third item price is 10, so it is going to calculate the total price item is 55. 5. Why it asked me 3 prices here? Because we were having a range from 1 to 4, and 4 is exclusive. Therefore, it is going to ask 3 times to enter the total price. And whenever I'm entering the price, it is adding the price to the total price variable, which was initially set to be 0. And in each iteration, we added the price that we entered here to this total price variable. So the sum will be 55. So in this example, we learned how a for loop can help us to work as a calculator. For example, in shops, when you're going to a shop and you're giving several items to the cashier, the system of that cashier is using the same mechanism and logic to calculate the total price for you. Thank you for watching. Hello everyone, welcome to this lecture. In this video, we're going to do a coding exercise using while loop. We would like to write a program that counts down from 5 to 1. To do that, we are initializing a variable to be 5, and then we are using while loop. So the while loop is going to continue as long as count variable is larger than 0. So the first time that it is initialized to 5, 5 is larger than 0, then it is going to enter this loop. When it enters this loop, it is printing countdown and the number of the count. So in the first time, count equals 5, so it prints 5 in the output. After that, it is decreasing the value of count by one value. We explained that when we are having, for example, these signs, it is equivalent to this count minus 1. Okay, so here it means that count equals 5 minus 1. Why? Because it is already initialized to 5 and we are decreasing its value by 1. Okay, so after this equation, count will be 4. So basically, in the first iteration, we are saying that count equals 5. 5 is larger than 0. Yes, it is true. Therefore, it enters the loop. It prints the value 5 for us, as we indicated here, and it decreased the value of count by 1 unit. So count is now 4. It goes back up. It checks the condition again. 4 is larger than 0. Yes. So count equals 4. So it prints 4, and now count equals 4 minus 1. Therefore count equals 3. Why? Because it was 4 already in this equation here. It was already 4 from the previous iteration minus 1, which is here. 4 minus 1, now count equals 3. So now it goes back up again to check the condition. 3 is larger than 0. Yes, therefore it enters the loop. It is saying that count is 3, so it is printing the value 3, and it is calculating 3 minus 1. Therefore count equals 2. And in the next iteration, 2 is larger than 0. Yes, it enters the loop again, so it prints number 2 and calculate the count again and reduce it by one value, 2 minus 1, so count equals 1. And now 1 is larger than 0. Yes, so count equals 1, print 1. And we are having 1 minus 1 equals, now count equals 0. So it goes back up again. It checks count is larger than 0. So count in the final iteration, it is 4. So 4 is larger than 0. No, it's not. Therefore, it's not going to enter the loop. Therefore, these two lines are not going to be executed, and it is going to print the last message in the terminal blast off. So when I run the code, we should see the same output as we anticipated here. So 5, 4, 3, 2, 1,
and blast off. So 5, 4, 3, 2, 1, and blast off. As you see, we can use while loops in many practical examples in real world. For example, countdown. Thank you for watching.
Hello everyone, welcome back. In today's video, we are going to learn how to print the words of a string one by one using a for loop. To do that, we are initializing a string called word and we are assigning the Python string to this word. And we are writing down a for loop and we are initializing a variable called a letter, and letter is going to iterate using the in keyword the word string. Okay, and then for each iteration it is going to print this letter for us. So in the first iteration, letter equals p. In the second iteration, letter equals y. In the third iteration, equal it is going to be equal to t, then letter will be equal to h, then letter will be equal to o, and then letter will be equal to n. So this letter that we are having here is going to iterate over this word string and it is going to print the letter here using the print function. So in the first iteration, letter is taking the P letter, then Y, then T, then H, then O, and then N. So when I run this code, I expect to see Python this a string, but one by one, letter by letter, it is being printed. And we already learned if we want to print this string in one line, we can simply use this syntax and we can say print and the word variable that is called word, it is going to print us the output of our string. So in this lecture, we learned how to iterate over a string and how iterating over a string can help us to print all the letters of a string one by one. And from before, we reviewed that if we want to print the whole string itself in one line, we can use the print function and put down the name of our variable that is containing that string and simply print out that string here for us. So here you see that the Python is being printed. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program that prints the multiplication table for a given number. So my given number in this example is 5, and I'm looping over variable I ranging from 1 to 11. So it loops through numbers 1 to 10. And in each iteration, I'm printing out number multiplied by I equals number multiplied by I. So when I run this code, you see in the output, we are looping through 1 to 10. So we are looping from 1 to 2, 3, 4, 5 until 10. And my given number is 5. So we are having a multiplication table, sorry, of number 5 here. As you see, 5 times 1. So number times I, 5 times 1, 5 times 2, etc. equals, and the output is number times I that is being printed out here. So 5 times 1, it's 5, 5 times 2, it's 10, 5 times 3, it's 15. But how it is happening? So we know that number equals 5, okay? It's a fixed number because we are not changing number. It's just a number that we set to be 5, and we can change it for another example if we want. But I is changing from 1 to 10. So when I equals 10, y equals 1, we are having 5 times 1 equals 5. Okay. Then we are having I equals 2. 5 times 2 equals 10. Then I is incremented to 3. So 5 times 3, it's 15. Then I equals 4. So 5 times 4 equals 20. I equals 5. 5 times 5 equals 25. I equals 6. we are having 5 times 6 equals 30. We are having I equals 7. So 5 times 7 equals 35. I equals 8. 5 times 8 equals 40. I equals 9. So 5 times 9 equals 45. And finally, the last value for I is 10. So 5 times 10 equals 50. This is how this loop is being executed. So I starts from 1 and it ends at 10. So we started from 1 and it ends at 10. And in each iteration, the number equals 5, this variable number. Okay, it is a fixed value 5, so 5 is fixed, but I is changing and it is looping through 1 to 10, and the output is being printed out here using this formula, number times I. So this is basically is how we are printing out the multiplication table for number 5. So if I have the number to be 6 here, so when I run the code, I have the multiplication table for number 6. This is a fixed number. We can change it as we wish. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates and prints the sum of all numbers from 1 to 10. To do that, I'm initializing a variable called total to be 0. I'm having a for loop and I'm iterating over variable I between the range 1 and 11. So it loops through numbers 1 to 10. Okay. And for each iteration, I'm having total plus equal I. So we are checking, we are having the summation of i's into the total variable. And basically here, I'm printing out the total. So let me run the code. It says that the sum is 55, but how this 55 is being printed? I mentioned earlier in another coding exercise, when we are having a plus equal sign, it means that we are having this formula, total plus I, okay? So this is the formula. So the first time I equals 1, we enter. It means that total equals, so total is initially set to be 0, okay? So new total equals 0 plus I equals 1 plus 1. So total equals 1, okay? Then I equals 2, total equals 1 plus 2. Why? So this one comes from this formula. So this is total plus I. So this one is the value of total which we calculated in the previous iteration to be 1. And this 2 comes from this I that is coming from this I. Okay, I equals 2 in this iteration. Therefore, now total equals 3. We have I equals 3. Total equals 3 plus 3 equals 6. Okay, why 3 plus 3? So this 3 comes from this 3. So we calculated the total in the previous iteration, and this 3 comes from I equals 3 because the formula, the new total, is total plus I. Okay, the already value of total plus the current I. And then when I equals 4, we are having the total equals 6 plus 4. Therefore, total equals 10. Then I equals 5. We are having total equals 10 plus 5. So total would be 15. Then we are having I equals 6. Total equals 15 plus 6. So total equals 21. Then we are having I equals 7. Total equals 21 plus 7. Therefore, total equals 28. Then we are having I equals 8. We are having total equals 28 plus 8, it equals 36, if I'm not mistaken. 26, yeah. 28 plus 8 is 36, and then we are having I equals 9. So total equals 36 plus 9. So the total is now 45. And finally, I equals 10. And total equals 45 plus 10. So total is 55, which is this number that we got here. So basically, in this code, we are iterating over values for I between 1 and 10. We are looping through numbers 1 and 10, and we are calculating and adding the current number to the total number. So total initially equals 0. In the first iteration, total is 0. We are adding the first iteration, I equals 1. So total is now 1. Then I equals 2, 2 plus that previous one. Then I equals 3, 3 plus the previous 3 of the total. So we are increasing the value of 1 to 10 in each iteration to total. So we are having one total, which is summing over all the values that is being iterated between 1 and 10. So it is going to give us the sum of all numbers from 1 to 10. This is how it works, because total starts from 0, and we are increasing the value of the I in each iteration. As you see here, I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And these are added to the previous value of I. So you see, to previous value of total, because total was 0, so I equals 1, 1 plus 0, it's 1. Then this old value is here, and in the second iteration, number 2 is added to that, so it is 3 now. And the I is 3, we are adding it to already existing total, which is 3, so it's 6 now. 6 is added to number 4, their summation is added to number 5, their summation is added to number 6, their summation is added to numbers 7, 8, 9, and 10. So we reach the output of sum of all numbers from 1 to 10 is 55. Thank you for watching. Hello everyone, welcome to this section. In this section, we're going to talk about functions in Python. So a function is a block of reusable code that performs a specific task. Functions can help us to organize our code, make it more readable, and reduce repetition. In Python, there are two types of functions: built-in functions that are predefined functions like print, len, input, that so far we've worked with many of them in the previous sections, and user-defined functions, functions that we create ourselves. This is the function that we are going to learn in this section. So how to define and call a function. A function is defined using def keyword followed by the name of the function and parentheses. Here, I want to show how to create a function. We use the def keyword and we name the function. For example, this function name is greet, and then the parentheses. In the parentheses, we will learn later in this section that we can pass some arguments to these parentheses later on in this section. But for now, we just know that we need to put parentheses. Then a colon. After that, we are having this print function here. So this is the built-in function, and this is the user-defined function. And this function is going to print hello world message for us in the terminal. So when I want to call this function, I simply just type down the name of the function followed by parentheses, and then this function is called and this function is executed. So when I run this code, you should see hello world message in the output. So now it's compiling because it's for the first time. It may take a bit of time. Okay, now we're having hello world in the output. We saw that
we only had this function call here one time, and one time this function executed, and this function is simply typing down hello world. So if I call this function more than once, this function is going to be executed. Oh, sorry, greet. So when I call this function twice, this function is being called twice, therefore this part is executed twice. So whenever we call the function, the compiler goes up here, starts with the first line of the function, and this function is only have a single line, so it is going to print hello world. So we saw that how we can create a function and how we can call a function. And there are three parts for function to remember: the def keyword, the name of the function, and parentheses. And later on, we'll learn about some arguments that we may want to include in the parentheses. So here we could, instead of calling this function, I could type down print hello world. And if I wanted to have it twice, I could type it down twice. Okay? And then run the code. It was going to do the same thing. However, we are using the function to avoid repetition. Now I'm repeating this line twice. Instead, I'm having this code being executed here once and avoiding the repetition. Okay, and it is increasing the readability. So this is why we use functions. And this is just a very tiny example here. For example, we want a function to do some mathematical operations for us. Whenever we call the function, that function is going to execute a certain block of codes to do the mathematical operations for us. And calling a function is much easier, like twice, three times, four times. If you want to call a function four times, it's much easier to repeat all those mathematical operations in the code four times. So it increases the readability of the code as well. So in this section, we're going to focus on functions, and we're going to have more examples of functions later on in this section. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we are going to talk about parameters and arguments. Functions can take parameters to make them more flexible. So a parameter is a placeholder inside the parentheses in the function definition. When calling the function, we provide arguments which are actual values. Let me illustrate it with an example here. So I'm using the def keyword. The name of the function is greet, and then inside the parentheses, I'm having one argument or a parameter, let's say. Okay, so this parameter is called name. This function, when it is called, it is going to execute this line of code. It is going to print hello message followed by the name that is passed to this function as an argument. Okay, so this function is going to type down hello message and then type down the name. But what is this name? So when in the main part I'm calling this function, in the parentheses I'm passing Alice. Okay, and this Alice, when the greet function is called, this Alice is going to be passed to the greet function as an argument. And here in the greet function, Alice is stored in the name parameter. And here when I'm printing the hello and then putting the name there, here it is going to print out Alice. So when I run this code, here I'm having hello Alice. So hello is the default message of this function. And whenever I'm calling this function, I'm passing one name, and this name is going to be executed and placed here after hello. Okay. And then I'm calling the function one more time, and this time I'm passing Bob as the argument. So when I pass the Bob here, the greet function is going to be executed, and Bob is going to place in the name parameter, and the name parameter now holds the Bob value, Bob string, and then it is going to print the message hello and then the Bob here. So we saw
that how we can call a function with an argument. But in this case, because this function is having an argument in the parentheses, can I just call the function without any arguments? So let us run. It should be, the answer should be no. So when I run, I'm having an error here. In the previous video example, we saw that there was no error. But why we are having an error here when I'm calling the function with empty parentheses? The reason is that in the definition of the function, we are having the name parameter declared here. So whenever we are calling this function, we are obliged to pass an argument here, okay? And that argument is going to be printed out in the output of this function. So this function requires to have one argument to be called, and we are passing no argument here. This is why there is an error. But if I have a message here when I'm calling the function, I'm having the Reza Shahin, a string to be passed as an argument for the greet function. Reza Shahin is going to be placed for the name, and then it is going to print hello, and instead of name, because now I'm calling the function with this string, it is going to say hello Reza Shahin. You see here? So this was a coding exercise of how to declare a function, how to call a function, and also how to use parameters or arguments when calling a function. Thank you for watching. Hello everyone, welcome back. In this video, we are going to talk about a scope of variables. So each variable has a scope. They are either local or global. In this video, we are going to talk about local variables. So variables that are declared inside a function are local variables, and they can be only accessed within that function. Let me illustrate it with an example. I'm having a function called greet, and I'm using the def keyword, and there is no argument for this function. So when I call this function, a local variable is initialized to be equal to hello world string, and then it is going to print this variable for me, which is called message. Okay, so I'm having the greet function being called here. So when I run, I see that I'm calling the greet function. The compiler goes up here, initialize the message variable, and then it prints the message variable. So we see the message variable in the output, hello world. Okay, but can I access this message variable? So can I print it directly here? So when I run, I see an error. Why? This error comes from the fact that this message variable is a local variable for the greet function, and it's not a global variable, so it would be accessible outside of this function. So this message variable, because it is declared and initialized in our greet function, it is only accessible inside the function. And when I want to use that message variable outside of the function, it returns an error. And how do we know that it's inside the function? Because when we are declaring a function, we start from the beginning of the left side of the note here when I'm typing down, but when I have the colon and when I enter, I start typing something, for example, here, it does not start from the beginning of the left hand side. Okay, it starts with some space. This means that this part of the code that has some space from the left hand side is included in this function that has a colon sign above here. But because here again I'm having the start point as the left side of the page, we see that it's in the global part, it's in the main part of the code. But because here, let me illustrate it with another example. Greeting function, then colon, print hello from the greeting function. Okay, and when I come here and I call this greeting function,
Let me run the code. It says hello from the greeting function. It is being printed out here. Why? Because this part is a part of this greeting function. How? Because we see that there is a space there. So this is a part of the above line. Okay, but here that I'm calling this greeting function, there is no space from the left side, so it's not a part of the greeting function but an independent part. So in this video we learned how local variable works in Python, and we learned that they are only accessible within a function that they are declared and initialized and not outside of the function. Thank you for watching.
Hello everyone and welcome back. In the previous video, we talked about local variables. In today's video, we're going to talk about global variables. So global variables are declared outside of functions. So they are global and they are accessible from any functions. To illustrate it with an example, here I'm having a variable called message and it is having a string that the string is hello world. So it's a global variable because it is outside of any function, and this is the only function that I have here. The name of my function is function1. I use the def keyword, and basically this function is going to print this message variable that is defined outside of this function. So this function can access a global variable that is defined and that is declared and initialized outside of this function. This is how nice the global variables are. So I call the function one here, and I expect to have the output message in the output because this function is going to print the message variable, and this message variable is saying hello world. Therefore, when I call this function, I expect to see the message hello world in the output. Also, I can have another print function here that is printing out the message function in outside of any function. So it is also globally trying to access a global variable. So when I run this code, I see two hello world message being printed out in the terminal. So in this lesson, we learned how to declare and initialize a global variable, and we learned that we can access a global variable inside a function even though that variable is declared and initialized outside of that specific function. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have a coding exercise that have local and global variables together in one example. So if a local variable has the same name as a global variable, the function will use the local variable. For example, I'm having a global variable called number and it is equal to 10. Then I'm having a function called modify number and I'm using the def keyword. In this function, basically, I am initializing a variable called number and it is equal to 5. Then it is going to print this variable number for me in the output. So I call in the main part, I call this modify number function. So it is declaring and initializing a local variable called number, and it is going to print its value, which is 5. And then I'm printing out the outside function, and then I'm trying to print the global variable number. So when I run this code, I see that inside function equals 5. So we see it here, inside function, the number variable equals 5. The outside function, the number variable equals 10. And the reason is why in this function now we are not accessing the variable number which is global. The reason is that we didn't declare global number and then start modifying, for example, number equals, for example, 10. This is why when we are not typing down this line of code, when we are typing down only the declaration of a variable like number which has the same name as the global variable, it is going to consider it as a local variable. However, if I comment this part and I have
this part right here and this part right here, I'm using this line for the declaration of the global variable inside my function, and then I'm having this global variable equals to 20. So now the global variable has been modified to 20. So when I run this code, I see inside function the variable is 20, and outside function the variable is also 20. So this is very important to use the global number uh, creation and declaration of the global variable inside a function if we want to use this global variable inside of the function. Otherwise, if we just type down the declaration without the global keyword, it is going to consider that you're declaring a new variable, a new local variable inside of this function. So this is why when I'm having only the declaration equals to 5 and then printing out the number variable, it is printing 5 for me in the inside of the function, but outside of the function, when I'm printing the number variable, it is accessing this global variable. Thank you for watching.
Hello everyone, welcome back. In this video, we're going to write a program that declares a function that takes a number as a parameter and prints whether it's an even number or odd. So here is my function. I'm using the def keyword to declare my function, and I'm having the name of the function called check even odd, and I'm having one argument for this function that we call it number. It could be x, it could be y. We can get to choose this number, okay? And this function is basically checking to see a number if it's even or odd. In order to understand if a number is even, we need to do a division. So when this is a definition of an even number. When a number is divided by 2 and the remainder of this division equals 0, it means that that number is even. Otherwise, that number is odd. So let me write it down for you. If a number is divided by 2 and the remainder of this division equals 0, it means that number is an even number. Otherwise, it is an odd number. So this is a definition of an even number. So if a number is divided by 2 and the remainder of this division equals 0, it means that number is even. And if a number is divided by 2 and the remainder of that division does not equal 0, that number is an odd number. Okay? So for example, when 10 is divided by 2, the output of this division is 5, but the remainder of this division is 0. So we understand that 10 is an even number. But when 11 is divided by 2, the remainder of this division is not equal to, does not equal to 0, is not equal to 0. This is why 11 is an odd number. So now we want to define a function that checks whether a number is even or odd. To do that, we are having one if-else condition here. So the number that is passed to this function, we are having this operation on that number. So this number is divided by 2. And we are checking to see if that number that is passed as an argument to this function, it is divided by 2. And it's the remainder of this division equals 0. We are checking the if condition. If this happens, print even. Otherwise, print odd. So it checks to see if a number is passed to this function. That number is divided by 2. Its remainder equal to 0. If this statement is true, then this part is true. Then it is going to enter this if condition and it is going to print even. Otherwise, it is going to print odd for us. Let me illustrate it with an example. So I call this check even odd function, and I'm passing number 10 as the argument. And I'm calling this function one more time, and I'm calling the function, I'm passing the argument that is 7. So let me run the code. So when I run the code for the number 10, I see even in the output. When I have the number 7, I see odd in the output. So one thing to remember is that I'm using the modular sign here. So the modular sign is going to return the remainder of a division. So this number is divided by this number. When I'm using this modular sign, it means that if this number is divided by this number, print me the remainder. Okay, give me the remainder. So when I'm having, let me illustrate it with an example. So when I have 10 divided by 2 here, when I run this code, you see number 5 in the output, okay? 10 divided by 2. But when I have print 10 modulo 2 and run this code, we have the output 0. What does it mean? It means that if 10 is divided by 2, the remainder of that division is what number? This is 0. Okay, so this is how the modulo sign is going to help us to understand the remainder of a division. It was a very good example. And now we see that here I'm having this block of code being executed whenever we call this function. Just imagine that we were not using the function. So I'm calling the function 2 times using 2 lines. Okay. And this part of the code is written only once. So if I wanted to not have a function, and every time that I was checking a number to see if it's odd or even, I had to write these 4 lines. So whenever, for example, I want to check 10 numbers, each time I had to write 4 lines of code. So 10 numbers multiplied by 4. So 40 lines to check 10 numbers if they are odd or even. However, here I'm having only 4 lines being written only once. And when I'm calling that function, I'm just using 1 line to call this function to do the mathematical work for me. So if I want to call this function 10 times, it will take 10 lines plus these 4 lines that are written only once. It will be 14 lines of code. However, if I want to this mathematical operations, these 4 lines for 10 numbers to be checked, the result will be 40 lines of code. And this is just a simple example. So it is very useful to use functions to reduce the repetition in our code and therefore increase the readability. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that declares a function that takes 3 numbers as parameters and returns the largest number. I'm declaring my function using the def keyword. The name of my function is find_max, and it is taking 3 arguments, a, b, and c, and they're separated by commas. And basically, this function is going to return the maximum number among these 3 numbers. So this is a user-defined function. The user-defined function in this example is find max because we are defining this function, okay? But we are having one built-in function as well. If you remember, we discussed this in the introduction. For example, the print function is a built-in function. So the Python itself give us this permission to use the print function to simply print and do no further works, okay? And this max function also is one of the built-in functions. So when I'm having this max function here, whatever that I'm putting in the parentheses, it is going to calculate the maximum among the numbers, and it is going to return me the maximum number among those numbers. So this function, whenever it's called, it is taking 3 arguments. It is going to call this built-in max function to find which one is the largest number and then return the largest number for me, okay? Now I'm having a variable called largest. It is equal to this line. Basically, this line is going to find max. It is going to call the find max function, and these are the three arguments: 10, 20, and 15. So these three variables are used here as A, B, and C respectively. So 20 is B, C equals 15, and A equals 10. And then this function basically is going to call the built-in function and find the largest number, which is 20, and return that number. And that output of that function is going to be assigned to this variable largest, because there is an equal sign here. And it is going to basically print the largest variable, which we expect to have the output 20. As you see here, we are having 20. Here again, I could have, for example, largest 2, and I'm calling the find max function. I'm having, for example, 100, 2, and 35, for example, and then I'm printing largest 2 variable. So when I run this code, I see 100 is the largest number, and indeed it is a true output for us. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about functions with default values. So we can assign default values to parameters of a function. So if no argument is provided, the default value is used. Here I'm having a function called greet. I'm declaring it using the def keyword, and I'm having a parameter here, but this is a bit different from what we saw so far. Previously, we were having a function, for example, called def hello, and it was having the name, and it was printing in the output for us the hello message, and then, and then the name. Okay, this is what we saw so far. So when I call this hello function, let me comment these two lines. So when I call this hello function and I'm having an argument here, so when I call it, it says hello Reza, okay? And when I call this function with no argument, there is an error here, and we saw that that this error will come up when we are having an argument in the parentheses for the function when we are declaring it, okay? So in order to avoid this error, we are going to have functions with default values. So here I'm having a function called greet with default values. So it has the name again, it has the same argument. It is having one argument in the parentheses, and it has this part that is extra. What is this part is going to do is the following. Name equals friend. And this function, when it is called, it is going to print hello and then print out the name that is used when calling this function. However, we can call this function with an argument and without an argument. So when I call this function with an argument, it is going to say, for example, hello Reza. But when I call this function without any argument, it is going to say hello friend. This is a function with default parameters or default values. So when I call this function now, so let me comment this part. So when I call the greet function and I'm having Charlie here as the argument being passed to this function, and when I run this code, it is going to say hello Charlie, okay? But here when I call this function and I put nothing in the parentheses, if I call the hello function with empty parentheses, we saw that there will be an error. Why? Because it requires an argument. But when I call this function greet, it requires an argument indeed as well. But when I call it with empty parentheses, it is going to by default set this friend string equal to name and assign it to the name, and then consider that name in the output. Whenever I call this function with no argument, it is going to use this default value. This is why we call them functions with default parameters or default values. So let me run the code. Now I'm calling this function and I'm passing no argument. It says hello friend. In the next line, I'm calling the function and passing an argument. It says hello Charlie. Okay, so let me review it one more time. Functions with default values are like this. When we are calling the function with an argument, it is going to place the argument here. So when I call the function with the Charlie argument, Charlie string, it is going to set Charlie to name, and then in the output says hello Charlie, as we see in the code here. But when we have the greet function being called with empty parentheses, it is going to by default use the friend keyword here and put it equal to name and print hello friend in the output. Okay, so this is how a function with default value would work. We learned that this is not possible in normal functions, because in normal functions, when I have this hello function and it has no default value, I must have an argument when I'm calling this function. Otherwise, if I call this function with empty parentheses, it is going to return an error for me. And how we can understand that a function is a normal function or it's a function with default values? It's a good question if you're having it. This is the answer. So this part shows us, okay, this is a function with default value. This is a sign for us to understand. When we see this equal and certain value equals to, for example, the argument of the function, we should understand, okay, this is a function with default value. So when I call this function with my own argument, it is going to use my argument. But when I call this function with no argument, it is going to use a default value itself for that function. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have a coding exercise with functions with multiple return values. So functions in Python can return multiple values. Here is an example. I'm using the def keyword to declare my function, and I'm having a function called get sum and product. And in parentheses, it takes two arguments. And this function, whenever it is called, is going to declare a new variable called sum. And sum equals a plus b. So it is going to have the result of a plus b stored in sum. Then it has a new variable called product, and it is storing the result of a multiplied by b. This sum could be x, and this product could be y, but we are just naming them like that so it increases the readability of the code. So after that, it is going to return the value of sum, this variable that is calculating a plus b, and product, which is this variable that is calculating the multiplication of a and b. Okay? And whenever I want to call this function, as before, I'm having the get sum and product name, so the name of the function, and then in parentheses, I'm having two numbers because it takes two numbers in parentheses as the argument. So 3 and 4. I'm calling this function with 3 and 4. However, because this function is returning two values in the output, this line of code, this call of the function equals two variables on the left side. So the first one is the result of the sum, and the second one is the result of product. And because this get sum and product function is returning first the value of sum and then the value of product, I'm having the first left-hand side variable here, result of sum, because the first return value is going to be stored in the first variable on the left-hand side here, and then the product, which is the second returned value, is going to be stored in the second declared variable in the left-hand side. Okay, so this is the point of having a function with multiple return values. It is going to return two values, sum and product, and therefore when I'm calling this function, it equals two variables on the left-hand side, one for sum, one for product. And if it is returning sum first, be aware that it is going to store sum in the first variable declared on the left-hand side, and the same logic goes for the product. Okay, then I'm printing the result. So I'm saying that print and the message sum, result underscore sum, which is the first variable, and then print the message product, and then a result product variable, which is the second variable. So when I run this code, we see this sum message is shown here, and it says the result sum equals 7, and the product is shown here, and the result product equals 12, which are the correct numbers, 7 and 12. So this is a very good example of having a function with multiple values, multiple return values. Why? Because maybe we would like to have a function that does different types of mathematical operations for us. We can combine all these mathematical operations in a single function, and not even 2, 3, or 4 functions. So it is very useful to combine them and ask the function to return multiple values for us after doing the calculation, and then we are assigning them to different variables. As we see, we are trying to learn how to optimize our code as we proceed through the course, because it's very useful to have an optimized code, a code that is having high level of readability. Thank you for watching. Hello everyone, welcome back. In this video, we're going to talk about return statement in functions. So functions can return a value using the return statement. The value returned can be stored in a variable for further use. Let me illustrate it with an example. So here I'm having a function called add. To declare this add function, I'm using the def keyword, and in parentheses, I'm having two parameters or arguments. They are separated by a comma. The first one and the second one. The first one is called A and the second one is called B. Whenever we call this function is going to return A plus B. Okay, so this function is going to add the first number and the second number that are passed to this function by doing this line, return A plus B. So let me show you how I'm calling this function. Now when I call this function, I'm having a variable called result, and this result variable equals the result of this function, the output of this function equals this result variable. So I'm calling the add function, so I'm typing down the name of the function. Then in parentheses, I'm having two numbers and they are separated by a comma, 3 and 5. So 3 is going to be equal to A because this is the first parameter or argument that is passed to this function, and 5 is going to be set to B because this is the second argument that is passed to this function, and B also is the second argument. So I'm calling the add function and I'm passing 3 and 5. And when I'm calling this function is going to return a value for me. It is going to return the value A plus B for me. And A plus B equals 8. So the output of this function is going to be assigned to my result variable here. So 8 is going to be stored in the result, and now I'm printing out the result. So when I have the output, when I run the code, I see that when I'm printing the value of result, I see 8 in the output. I can have, for example, a new variable called x equals add, and then I'm having 2 and 2. I can have y add 5 and 6, for example. I could have z equal add, for example, x and y. And in the output, I would like to have the result of x, then x, print the result of y, then print y, and then finally I want to show the result of z and have the z here. So what I'm doing here is that, again, like the result variable, I'm declaring 3 new variables, x, y, and z. I'm calling the add function, asking the function add to perform the a plus b with 2 numbers, 2 and 2. So when I call this add function, the first 2 is placed for the a, the second 2 is placed for the b, and a plus b is going to be returned when I'm having this line, and the result of the return, the output of the function is going to be stored in x. So I expect the value of x will be 4. Then I'm calling the function another time and assigning the result to variable y. And when I'm calling the function, I'm having 5 and 6. So 5 is a and 6 is b. 5 plus 6, the result is 11. So I expect to have the 11 for the y. So 11 is the output of this function, and this is going to be assigned to variable y. And then I'm calling the function one more time, this time with the variable x and variable y, and they are previously taken 2 values. So I expect the result will be 15 because x is 4 and y is 11. So x is now placed for the a and y equals b. So 4 plus 11 equals 15. So when I run this code, I see the result of x. So here also I'm printing out the output of x, y, and z. The result of x equals 4, which we expected. The result of y equals 11, which we expected. And the result of z equals 15, which we expected. So this is how we can have a return statement in a function to give us some output of the function, and we store that output in, for example, certain variables for further use here. And also we learned how functions can be useful, because now I'm performing this line of code a plus b one time only, but I'm using it 4 times in my code. Instead of typing down these mathematical operations 4 times, I'm just calling it with different parameters. So it is much easier to have a function to do the job for us, and we have different part of the code where we call the function to do that job for us. So we don't have any repetition. We are having the mathematical operations being written only once. This is how it can reduce the amount of code that you're going to write, and this is how it is going to improve the readability of your code, because you're typing down the operations one time, but when we are going to have like 10 times of this operation, instead of having it 10 times being repeated in the code, and it would be not very easy to read, it would be hard to follow. Okay, another time I'm having for example, a plus b, another time I'm having 2 plus 2, 5 plus 6, x plus y, etc. Instead of having these, I'm just calling the function, and the code is being reused several times, and it is being written one time only. So this is how useful the functions are in Python. In the next videos, we're going to dive deeper into this concept. Thank you for watching. Hello everyone, welcome back. In this video, we're going to write a program that declares a function And this function takes a temperature in Celsius as a parameter and returns the equivalent temperature in Fahrenheit. Here is my function. So I'm using the def keyword to declare my function. This is the name of my function called Celsius to Fahrenheit. And in the parentheses, it is taking one parameter or argument, and I just name it Celsius. We can call it X, we can call it Y, whatever we want. And this function is basically is going to return the value of this statement. This statement is the following. Celsius times 9 divided by 5 in parentheses plus 32. So this is the very famous formula, and we know it from before, that is going to take a Celsius degree and convert it to Fahrenheit. So this is the formula to do that. For example, this Celsius could be, for example, 30, and I want to know 30 degrees in Celsius is what is the temperature of equivalent of 30 degrees in Celsius in Fahrenheit. So this is the Celsius value, so 30 for example, and then using this formula we can get the output of the Fahrenheit temperature. Now to do the job for me, I'm having a variable called temp. I call it x for the sake of simplicity. So I'm having a variable x, and we are calling this Celsius to Fahrenheit function. We're calling this function using the argument 25. What does this 25 mean? This means that I'm having 25 degrees in Celsius and I want to know its equivalent in Fahrenheit. And it is going to call this function with 25 equals Celsius. So 25 is multiplied by 9 divided by 5 in the parentheses, and then plus 32. The output is going to be returned. So when I call this function, this is doing this part for me and return its value. So, and the return value is assigned to X variable. Okay, we are assigning it to X variable. And finally, I'm printing out the X variable. So when I run the code, I see the equivalent of 25 degrees in Celsius is 77 degrees in Fahrenheit. We could try like 18 degrees in Celsius and find its equivalent in Fahrenheit. And we see its equivalent in Fahrenheit is 64.4. So this is how we can take a number and do some mathematical operations on that number and return the output. In particular, in this example, we learned how to get a number as the degree in Celsius and do certain mathematical operations to convert the Celsius number to the Fahrenheit number and return the output. And the returned output is stored in variable x, and then we are printing out the x variable. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that declares a function that takes two numbers as parameters and print their sum. I'm declaring the function called add numbers, and I'm using the def keyword, and in parentheses I'm having two parameters, a and b. And whenever this function is called, it is going to print the value a plus b for me. To call this function, I'm typing down the name of the function, and then I'm typing down two numbers, so 3 and 7. When I call this function, 3 is placed for A and 7 is placed for B, and A plus B means 3 plus 7, and it is going to print the value of 10 for me because it is 3 plus 7. So when I run this code, I see the output 10. I'm having another, for example here for you. I'm having add numbers, meaning that I'm typing down the name of the function. I'm passing two numbers, 10 and 20. I run this code, the output is 30. And let me define another function here, exactly like this. So when I'm having add my numbers, and I'm having A and B as the argument. Oops, sorry. A and B. I'm having the colon. It is going to return A plus B for me. Okay. So when I call this add my numbers function with two values like 100 and 200. So if I run this code, I see the output is 300. So we see here that I'm having another function called add my numbers. The first one was add numbers, and this is a new function that I defined, add my numbers. And in the parentheses, we are having A and B. And this function is going to use a return statement, A plus B. So whenever I call this function is going to return A plus B, and automatically we see the output in the terminal. So this was an example of how to declare a function that does, for example, the sum of two numbers for us. We could either use the print function so that function is going to print the output, or we could use the return statement to have the output of the function. Here I'm printing the output using the print function A plus B. We see 10 and 30 is printed in the output. Here I'm not using the print function, but I'm using the return function, and it is going to return the value A and B, A plus B. So whenever this function is called, this value is going to be returned, and we see the output in the terminal. This was a very good example of how to call a function and how to have a function with print or a return statement to do the job for us. Thank you for watching. Hello everyone, welcome back. In this video, we are going to learn about how to modify a global variable inside a function. I'm having a global variable called count, and it is equal to 0. Then I'm having a function called increment count, and I'm using the def keyword to declare this function and empty parentheses, so it accepts no argument for this function, then colon. Then in this function, I am declaring the global variable. In order to modify a global variable, for example, in this case, the count variable, I must use the global keyword before declaring this count global variable inside this function. So if you want to modify a global variable, you must use the global keyword and then the name of that global variable that you're intending to modify. So I'm typing down global keyword and then count, meaning that I would like to modify the count variable, which is a global variable. And after that, I, for example, type down count equals 1. So now I modified my global variable. This is what is going to happen in my increment count function. And then I'm calling this increment count function in here. So I'm calling the function. So I expect when this function is called, the global variable count is first declared and then modified. And finally, in my code, I am using the print function to print this global variable here. So when I run this code, I see the output is 1. Previously, when we initialized the count variable, it was equal to 0, but now it shows the value equal to 1. How it worked? It worked using this function. So this function helped us to modify a global variable. To review, in order to modify a global variable, we must use the global keyword and then the name of the variable that we are intending to modify. After that, we type down the name of the variable and then assign it a new number. For example, here I assign number 10. So when I run, this function is being called using this line, and then the modified
count variable is printed out in the output. So we see number 10 in the output. So if I put number 1, it is going to make it to be number 1. If I put number 2 here, it is going to print number 2 in the output for us. It depends how we modify and what number we set for this global variable. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program that define a function called calculate, which takes two numbers and return their sum, difference, and products. So it is going to have multiple return values. To do that, I'm having the calculate function being declared here using the def keyword, and it accepts two arguments, a and b. Basically, this function is going to return three values. Each value is separated by a comma. So the first return value is a plus b, the second return value is a minus b, and the third return value is a multiplied by b. Then when I'm calling this function here, I'm calling the calculate function and I'm passing two arguments, 7 and 3. A equals 7 and b equals 3. Why? Because a is the first argument in this function and I'm passing 7 as the first argument, so a equals 7. With the same logic, b equals 3. Then this calculate equals three variables on the left hand side. One variable is called sum, the other one is difference, and the other variable is called product. So a plus b, the return value of this first return value in this function is going to be assigned to the first variable on the left hand side here. So a plus b is going to be assigned to sum. A minus b is going to be assigned to the second variable called difference, and the third return value, a multiplied by b, is going to be assigned to the third variable on the left hand side, which is called product. Then I'm printing out the sum, the difference, and the product. So when I run this code, I have the sum equals to 10, which is true because 7 plus 3 equals 10. I have the difference equals to 4, and the product equals to 21. So in this coding exercise, we reviewed a function with multiple return values, and we saw that we can have one line to do all the mathematical operations in one function. And then when we are calling this function, on the right hand side, we type down the call of the function, and on the left hand side, I'm typing down three variables because this function is returning three values. Thank you for watching.
Hello everyone, welcome back. In today's video, we would like to write a program that calculates the diagonal of a rectangle given its width and height. Here, because we want to do some mathematical operations, we are importing the math library to use its function. For example, one of the functions that we want to use is the sqrt. So this is why we type down the keyword import and then the math keyword, which means that we are going to use the math library and we are going to import the math library. Then we are going to show this message to the user, enter the width of the rectangle using the input function. And because whatever that we get from the user using the input function, it is by default in Python treated as a string, we need to convert it to a float. And because we want to convert it to a float, we are going to use the float function, and this is the float function. So we are using the float function, so everything that is inside these parentheses is going to be converted to the float. So therefore I type down the input function inside the float function, and inside the input function parentheses I say enter the width, for example, and the user is going to enter a number. That number is stored firstly in a string data type, and then it is going to be converted to a float, and the output is going to be assigned to the width variable. The same reasoning happens for the height variable. We are going to show this message to the user saying that, okay, enter the height of the rectangle, whatever the user is going to enter. Firstly, it is stored in a string data type. Then we are going to converted to a float, and then it is assigned to the height of the rectangle. Okay. Then we are having this variable diagonal equals to the formulation. So this is the formulation to calculate the diagonal of a rectangle. In order to calculate that, we need to have a square root of width to the power of 2 plus height to the power of 2. Okay. And when we are having this output, we are going to calculate its square root, and it is going to give us the diagonal of a rectangle. So in order to compute the diagonal of a rectangle, first we need to have the output of width to the power of 2 plus the height to the power of 2, and then have the square root of their summation. So this formula is written in Python like this. So we call this math function and math library, sorry, and then the sqrt function, then width to the power of 2, star star 2 means to the power of 2, plus height to the power of 2, star star 2, and then the output is assigned to diagonal variable. And finally, using the print function, we are trying to print the output saying that the diagonal of the rectangle is, then I type down the name of the diagonal variable, so it is going to print the output for me. So I type down the width of the rectangle is 10, for example, and the height of the rectangle is, for example, 25, and it calculates the diagonal of the rectangle. It says the diagonal is 26. So this is how we can calculate the diagonal of a rectangle given its width and height using the math library and square root sqrt function and to the power of 2 in Python. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that truncates a floating point number to its integer part without rounding. So to truncate means to remove the fractional part of a number, leaving only the integer part without rounding it up or down. For example, if we want to truncate number 3.9, the output would be 3. So how do we do that in Python? We're going to use the math library. So we type down import math. Then we are having this message being shown to the user, enter a floating point number. Then it is read using the input function from the user, and we learned that it will be by default a string. So we need to convert it to a float. Therefore, we type down the float function. And the right hand side is assigned, the output is assigned to the variable called number. Then in order to truncate the number, we type down math.trunc, trunc, and in parentheses, we type down the name of our variable. In this case, it is called number. So we have the math.trunc, and in parentheses, okay, we type down our variable. In this case, our variable name is number. And the output is assigned to a variable called truncated. And then we are printing the truncated in the output. So when I run this code, it says enter a floating point number. So I type down 3.14. It says the output is 3. I type down, for example, 1.85. It says the output is 5. I type down, for example, 20.5. It says 20. So we learned now we can use the math library and using the trunc function to truncate a number easily for us. Basically, it is going to remove the fractional part of our number and leaving only the integer part. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates the maximum number of full tiles needed to cover a floor, given the area and the size of one tile. Here, what we mean by to cover a floor given the area. So for example, if the output is to have 28.5 tiles to cover the floor, when we are using the floor function, it is going to return number 28. So it is going to round it down. So let me illustrate it with an example. Here we are having the math library being imported. We are showing this message to the user, enter the total area of the floor in square meter. And we are storing it in area variable. Then we are saying that enter the size of one tile in a square meter. And we are going to store it in tile size variable. Then the variable tiles needed equals math.floor. So this is the floor is the function of the math library. And in parentheses, we are calculating this area divided by tile underscore size. Basically, if I run this code, it is going to be something like this. So enter the total area of the floor. So imagine that for example, the room that I would like to cover it with tile is 20 square meters. And for example, enter the size of one tile in a square meter. And it's, for example, one tile is 0.7 square meter. Okay. So when I run, we see that the output says you will need 28 full tiles to cover the floor. But when this area is divided by tile size, which means 20 divided by 0.7, if you do it yourself with calculator, you will see that the output is 28.571, for example, approximately. Okay. But because we are using the floor function from the math library, we see that it is rounding it down to number 28. So it says that you need 28 full tiles to cover the floor. This is how actually this floor function from math library is going to work. So basically, we are going to ask the user to enter the size of the area of the floor in a square meter, for example, then the size of each tile in a square meter, and then divide the area by the tile size and round it down to the closest integer number. Then it is going to show us in the output using the print function saying that you will need, for example, 28 full tiles to cover the floor. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that calculates the total number of pages required to print a given number of lines, where each page can hold a fixed number of lines. Here, we are using the math library. We are asking the user enter the total number of lines to print. It is assigned to lines variable. Then we ask enter the number of lines per page, and it is going to be assigned to lines per page variable. Then we are going to divide line by lines per page. Okay. And then it is going to be assigned in pages variable. But we want to round it up. In order to round it up, I use the actually math library, and I also use or call the ceil function from the math library, and in parentheses I type down lines and then lines per page. For example, if I have, for example, 200 lines, and in each page there are 19 lines, so I would like to know how many pages do I need. So 200 is divided by 19. The result, if you do it yourself, will be approximately 10.52. But because we are using the ceil function, the output will be 11. So it is rounding it up. So let me run the code. It says enter the total number of lines to print. So the total number of lines, it's 200, for example. Then enter the number of lines per page. I would say it's 19, for example. It says you will need 11 pages to print 200 lines. But you see that 200 is divided by 19 in this formula here. 200 is divided by 19. but because we are using the ceil function, the output, which is 10.52, is rounded up to 11, and we see that in the output, number 11 is shown. So this is how we can use ceil function from the math library to round up the output for us. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program to calculate the number of possible arrangements of n objects. What do we mean the number of possible arrangements? It means that, for example, we are having two objects. Just take it as an example, X and O. There are how many possible arrangements for these two objects? There are two, in fact. The first possible arrangement is X and O, and the second one is O and X. So they're changing their place. So there are two possible arrangements for two objects. Okay. Then for three objects, how we would have this X, O, and Y. For three objects, we have X, O, Y, O, X, Y, O, Y, X, X, Y, O, Y, X, O, and Y, O, X. So there are 6 possible arrangements for 3 objects. Okay. This is how we can do it manually, but it's very hard to do it. So I first need to do it carefully and make sure I'm not making any mistake. Then I start counting 1, 2, 3, 4, 5, and 6. Okay. So here, in order to understand it in Python, it's very easy to use math library and factorial function to do this for us. We're going to tell the user enter the number of objects, and whatever the user is going to enter is stored in n, and simply we are using the math library and then factorial function, and in parentheses we put the name of our variable, which is n. So when I run this code, it says enter the number of objects. I say 2, it says the number of possible arrangements is 2. So if I run one more time and enter the number of objects, so this time I enter 3, it says that the number of possible arrangements is 6. So here is the output. So this is what I did myself to calculate it, and here is the output in Python in just 1 second. So if we mention that we have 4 objects, we see that the output is 24. Basically, it is going to calculate n factorial for us. It means that if we have n object, there are n factorial possible arrangements. So if we have only 2 objects, for example, therefore we are having 2 factorial, therefore the output is 2. But if we are having 3 objects, it will be 3 factorial, and the output is 3 multiplied by 2 multiplied by 1, so the output is 6. And when we are having 4 objects, the output is 4 factorial, and it means that we are having 24 possible arrangements. And it's very hard to compute it when we are dealing with a large number of objects. For example, if we are going to have, for example, 5 objects, we see that the possible arrangement is 120. Then if we are having, for example, 8 objects, we see that the possible arrangement is 40,320. So we see that it's very useful to do things in Python. It's easier and it will give us a solution very fast. Thank you for watching. Hello everyone, welcome back. In this video, we would like to write a program to calculate the time in years it will take for an investment to double at a given annual interest rate using the following formula. So this is the formula, and we are having the logarithm 2 divided by logarithm plus rate. And it is going to be assigned to a variable called time, and we are going to print time in the output. So first of all, we're going to ask the user enter the annual interest rate as a decimal. For example, for 5%, we type down 0.05. Then whatever the user is going to enter is stored in the rate variable. And then we type down exactly this formula in Python here. Okay, but we need to have the math library. So math.log in parentheses, we type down 2 divided by math.log 1 plus rate, and rate is something that we got from the user. And this is assigned to the variable called time. We call it time, it can be anything. And then we print the output of the time. So when I run this code, it says enter the annual interest rate. For example, the annual interest rate is of 5%, and with 5% of annual interest rate, it would take 14 years, almost 14 years, for my investment to be doubled. Okay, so if I put $100 in my investment bank account, it would take 14 years, approximately 14 years, for my investment to become $200, so to be doubled. So this is how we can calculate it in Python using the math library and logarithm function. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the remainder of a division. In order to review, when we want to divide 10 by 2, 10 is our numerator and 2 is our denominator. Okay, so we are asking the user to enter a numerator and we are storing it in variable x. For example, let's say I name it x. And then I am asking the user to enter the denominator, and whatever the user is going to enter is going to store in a variable called y. Okay, so a numerator is asked from the user, which is stored in x. A denominator is asked from the user, and it is stored in y. Then, in order to find the remainder, I need to use the math library and fmod function. So this is my fmod function. And to access that, I need to type down math.fmod. And in parentheses, I need to put two arguments, one before comma and one after comma. So the one that is before comma, I need to put my numerator. And my numerator is stored in variable x, as you see it here. So I type down x, and then after comma, I need to type down my denominator, which is stored in variable y. And we can name it whatever we want. We can name it h, we can name it r. It depends on what we want, okay? Then this fmod function from the math library is going to calculate the remainder of the division of my numerator divided by denominator. And we are going to use the print function to print our remainder in the output. So when I run this code, it says enter the numerator here, okay? So I want to divide 10 by 2, for example. 10 is my numerator and my denominator is 2. It says the remainder of 10 divided by 2 is 0. Yes, okay. So if I type down my numerator to be 11 and my denominator to be 2, now we see the remainder of 11 divided by 2 is 1. So using the fmod function from the math library, we can easily find the remainder of a division. Thank you for watching. Hello everyone, welcome to this lecture. In this lecture, we're going to discuss a project. So in this project, we would like to create a simple calculator that performs basic arithmetic operations for us. To do that, first of all, I'm printing the message, welcome to the calculator for the users. So I'm printing out this message. And then I would like to take two numbers from the user. First, I ask them to enter the first number, then enter the second number. And then using the input keyword, I'm getting this
message being shown in the output for the user and storing this entered data by the user using the input function. And because we learned by default in Python, it is going to store it as a string. We are using the float function to convert the variable, the input variables that is used and entered by the user, to convert them from a string to float. And then this is assigned to my variable called num1. The same logic goes with the second number. I'm showing the message for the user using the input function saying that enter the second number, and the user is going to enter a number. Okay, and that number, using still the input function, is going to be stored as a string for users in the memory. And then, because by default it's a string and we want a number because we would like to do some arithmetic operations, we need to convert it to a float or integer. But float is more flexible. So in order to do that, I'm having the float function and parentheses, and inside parentheses, I'm having the input function. So whatever that is stored using the input function is going to be converted to float, and the resulting value is going to be assigned to my num variable. So I'm using the input function and the float function, okay? And basically I'm having the float, and inside that I'm having the input function, and in this input function I'm having my message. Okay, so this is how I'm showing a message to the users to enter two numbers, then storing them as a string, converting them as a to float, and then assigning them to num1 and num2. Then I'm showing another message to my users. I'm saying that choose an operation: addition, subtraction, multiplication, or division. And then when they want to enter the operation, I'm going to take it as an input and store it in the variable called operation. So here is the fun part. Now I need to define if, else, and elif conditions. Why? Depending on what mathematical operations the user is going to choose, the output is different. Because if they choose, for example, the addition, the output should be num1 plus num2. If they, for example, choose multiplication, the output should be num1 times num2 multiplied by num2. Okay, so this is the difference. So now I would like to start my if condition. I'm saying that if the operation variable equals the plus sign which we store, so we store the operation that the user is choosing in the operation variable. So if this equals plus sign, the result variable equals num1 plus num2, and then we are going to print the result is, then print out the result value. Elif the operation equals subtraction, the result variable equals num1 minus num2, and then we are going to print the result. Elif the operation equals star, we are going to have the variable result being equal to num1 multiplied by num2, and then we are printing out the output here. And elif, another elif is that operations equals the slash. It means that we want to do the division, but before doing that we must check that num2 does not equal 0, because if num2 is equals 0, there will be, mathematically speaking, there will be a problem. No numbers can be divided by a 0, so num2 should not be equal 0. So if num2 is not equal to 0, then result equals num1 divided by num2, and then we are printing out the result. Otherwise, if num2, otherwise is this else function, is else part here, which means that num2 equals 0. Okay, print error, division by 0 is not allowed. And if operation is not equals, the operation variable does not equal to any of these any of these options here, I mean the addition, subtraction, star, and the slash, print invalid operation. For example, if the user enter another operation. So we're going to illustrate it with an example. So let me run the code. When I run the code, it says, welcome to the calculator. Enter the first number. I say 20. Enter the second number. I would say 10. And then enter the operation. I'm typing down the plus. So it says the result is 30. Okay, so it is taking the operation and then do the job for me. So this message was shown, enter the first number, enter the second number, then choose an operation. Then I entered the operation, so it was stored in operation variable. Then because I was choosing this addition, it said if operation equals addition equals plus. Is it true? Yes. Then it entered this if condition here. Because it entered this if condition here, it did the num1 plus num2, stored the result in the result variable, and then print out the output. So when I run this code one more time, it says enter the first number. I said 20. Enter the second number. I would say 15. And choose an operation. And from the operation, I choose subtraction. It says the result is 5. So let me analyze the code one more time. So it stored two numbers that I entered and stored the subtraction sign that I entered here. It start the if condition here. So operation is operation equal to plus? No, because I entered minus, I entered subtraction. So because this condition is not true, it's not going to execute this part of the code, and it jumps to the elif part. So the next condition, it says operation, is it equal to subtraction? Yes, because this statement is true, it is going to execute this part of the code. Therefore, the result variable is equal to num1 minus num2, which was 20 minus 15, and the result was 5 as shown here. So when I have another run, I would say the first number is 20 and the second number is 0, and I choose the division operation. So it sends me an error saying that error, division by 0 is not allowed. What happened? So the program stored my two numbers. Then it stored the division operation here. It checks to see operation equals plus. No. Then this part is not executed. It jumps to next elif, operations equals minus. No. Then it does not implement this part. It jumps to the next elif, operations equals star. No, it does not implement this part. And then finally it says operation equals slash, which is division. Yes. If it checks this statement, num2 is not equal to 0. Is it true? No, num2 equals indeed to 0. Therefore, it comes to this else part and says error, division by 0 is not allowed. This is exactly the thing that we got in the output here. So when I run this code one more time, I say 20 and then the second number 10, and I type down the slash, which means the division, and it says the result is 2. So in this case, it comes here, operation equals slash or division. Yes, it checks num2 is not equal to 0, and my num2 was 10. So this statement is true. Therefore, it is going to implement this part of the code, and result equals num1 divided by num2, and the result is being printed out, which is number 2 here. And when I run the code one more time, I type down 20 and I type down the number 10 as a second number. It says choose an operation. So I choose the AND sign, which is not one of the predefined operations. So when I run this code, it says invalid operation, which is this message here. So when we are having this code and neither of these options are considered here. So the first option is addition. The second option is subtraction. The third option is star, and then this division here. Okay. But I chose the AND operation, and AND operation is not included in any of these lines here. Okay. So when the and sign is not included in any of these lines here, it is going to return the invalid operation message because it's the else part. So if operation is either one, either this, and either this, do these things. Otherwise, which is this part, show the message invalid operation. So in this project, we learned how to create a simple calculator that performs basic arithmetic operations for us. Thank you for watching. Hello everyone, welcome back. In this project, we are going to create a game where the user guesses a random number between 1 and 10. In order to write this program, we need to import random library in Python. So we need to type down this keyword in the beginning of our program as a header. Then I'm initializing a variable called random number, and it is equal to random.randint. In the parentheses, I have 1 and 10. It means that generate a random number for me between 1 and 10 and assign the generated number to my random number variable, okay, to this variable. Then show the message, I have picked a number between 1 and 10. Can you guess it? If we wanted to have a number being generated between 1 and 100, we type down 1 and 100. Between 2 and 10, between 5 and 10, we can choose it. Then it shows the message saying that, okay, I generated a number for you. Can you guess it? Then we are having a while loop, and it is a while loop equals to, so the condition for this while loop is true. So it's an infinite while loop. So as long as we are not finding the correct number that is generated, this while loop is going to continue. And at certain point, we are going to use the break keyword to get out of the while loop because it's an infinite loop. If I don't have this break keyword, it's going to continue until the end of the word. So in this while loop, I'm having the guess variable. It is being initialized and declared using the input function. I'm saying that enter your guess to the user. I'm saying to the user, enter your guess. And because by default in Python, it is going to be stored as a string, I'm using the int function to convert whatever the user is entering to an integer. And then the result is being assigned to this variable called guess. Then I'm having an if condition here saying that if this guess variable that we got from the user equals the random number that was generated randomly here, print congratulations, you guessed it, and break and get out of the while loop. So it's over. We could guess the generated number. Otherwise, if we couldn't guess it, and elif here we are having, if the guess number that we guessed there is lower than the generated number, print too low, try again, and it goes back up again and asks us to enter another number. Okay, and if this guess number is larger than the random number, it says too high, try again. This line could be executed using elif or the else. Why the else? Because either two numbers are equal, or one number is larger than the other, and one number is the guess number is either equal to the random number, or it is lower than the random number, or it is larger than the random number. So if it's not equal and it's not lower, therefore the else condition is the fact that else is larger than the random number. We could either use the else or elif to define this condition. And then if the guess is larger than the random number, it says too high, try again, and it goes back up again and says that enter your guess number. So when I run this code, it says I have picked a number between 1 and 10. Can you guess it? So here it is having the number being generated and showing this message to me. Now it is asking me to enter a number. I say 10. It says too high, try again. So it checks my number with the generated number and says it sees that my entered number is larger than the generated number. This is why it shows the message too high and try again. So I say this time I say 5. It says too high, try again. And again, when I type 3, it says too low. Try again. Why too low? Because it compared my number 3, my guess number 3, with the random number, and it says too low because my number is now lower than the generated number. So I assume that it must be 4. And when I enter 4, it says congratulations, you guessed it. So this message is shown, and then the break keyword is getting out of the while loop because we are not seeing the message saying that try again, try again. But if you cannot guess the number, it is going to ask you, okay, enter your guess number, and show the message either too low or too high. So this is how we can generate a game where it generates a random number between two numbers for us, and we can start guessing that generated number. Thank you for watching. Hello everyone, welcome back. In this video, we're going to have another project. So we would like to write a program that calculates simple interest based on user input. To do that, first I'm showing the message to the user saying that welcome to the simple interest calculator. Then I'm going to ask the user 3 inputs. The first one is the principal variable, the second one is the rate, and the third time is the time. So I'm going to ask the user enter the principal amount and store it in the principal variable. Then I'm asking the user to enter the rate of the interest in percentages and store it in the rate. And then I'm asking the user to enter the time in years. So the user is going to enter the time and store it in the time variable. Then using this formula, I'm going to calculate variable called simple interest. So this formula is the following: principal multiplied by rate multiplied by time in parentheses, and their result is all divided by 100. And in the output, I'm saying that the simple interest is, and then I'm showing the result here. So when I run this code, it says enter the principal. So I would say 10,000. I would like to apply for a loan, for example, for my car from the bank. And I would like to ask for 10,000. And the rate of the bank is 4.5, for example, percent. And then I'm going to return this in 10, let's say in 20 years. When I want to return it in 20 years, it says that this interest is 9,000. So you're going to pay 9,000 after 20 years of interest to the bank. So now I would like to get a mortgage from bank to buy an apartment, for example. I would type down 100,000. I would say the interest rate is 7, and I'm going to return it in 30 years. It says that after 30 years, I have to return $210,000 to the bank for the initial principal amount of 100,000 with the 7% of the interest for the duration of 30 years. So in this video, we learned how we can provide a program that calculates simple interest based on input user. Thank you for watching. Hello everyone, welcome back. In today's video, we are working on another project. We would like to write down the FizzBuzz program. So a program that to print numbers from 1 to 100, replacing multiplies of 3 with fizz and multiplies of 5 with buzz and multiplies of both of them with FizzBuzz. To do that, I'm having a for loop ranging from 1 to 101, and the reason is I'm having 1 and to 101 is that because the start is inclusive, so we want to go from 1, so I'm typing down the 1. But the end is exclusive, so it says that 101 because the end is exclusive. So if I type down between 1 and 100 because the end is exclusive, it is going to iterate until 99. Okay, so if we want to have until 100, we need to type down 101. And
there, when we enter the loop, we are having certain if, elif, and else conditions that we need to check. In order to understand if a number is multiplies of 3, a number is a multiply of 3 if that number is divided by 3 and the remainder of the division equals 0. Okay, this is how we can understand if a number is a multiply of 3 or divisible by 3. So we are going to type down the fizzbuzz message in the output if the number is divisible by 3 and at the same time it is divisible by 5. If the number is only divisible by 3 to print fizz, and if the number is only divisible by 5, print the buzz message. Otherwise, print that number in the output. So in the AND operator, if you remember, both sides of the AND must be true. So if a number is divided by 3 and its remainder equals to 3 and that same number is divided by 5 and the remainder of this division as well equals 0, sorry, it is going to print fizzbuzz message. And if only that number is divisible by 3 to print fizz, if it's only divisible by 5, print buzz, otherwise the number itself. So when I run this code, we see the output here. So number 1 and number 2, the numbers are written like here because neither of these conditions are true for them. Therefore, this else part is true for them. So we are printing out the num. So the variable num that we are initializing here is going to take number 1, 2, 3, 4, 5 until it reaches 100. So for the first iteration, it is 5. It passes none of these conditions and 1 is printed out here. Then for 2, the same thing. For 3, because 3 is divisible by 3, the fizz message is being printed out here. 4 is not, neither of these conditions are true for number 4. Therefore, number 4 is printed out here. Then we are having number 5 here. We are having the buzz here because when num equals 5, 5 is divided by 5, the remainder equals 0. Therefore, it prints buzz. Then for the 6, it prints fizz because fizz means number 6 here, and 6 divided by 3, the remainder equals 0. Therefore, we are having the fizz message in the output. So it goes until it reaches, for example, number 15. And number 15 is divisible by both 3 and 5. Therefore, this fizzbuzz message is printed out in the output. And you see that when I go down, I see all these messages that are printed out here. So in this project, we learned that this num is going to take numbers from 1 to 100 using for loop, and depending on these if conditions, it is going to print certain message or value in the output. Thank you for watching. Hello everyone, welcome back. In this video, we are going to work on another project. So we would like to write a program that reverses a string entered by the user. In the beginning, I showed a message saying that welcome to string reversal program. Then I'm asking the user to enter a string to reverse. And this entered input by the user is going to be stored using the input function and be assigned to the user string variable that I'm initializing here. Then this user string variable and then having the square brackets colon -1 is going to help us to read this variable, this string that is stored in this variable from the end. Okay, and then the result of this is assigned to reverse a string. So for example, if I type down Reza here as the input string, when I have this Reza input assigned to my string variable, for example, and then I have my string variable colon -1, this code is going to reverse my string, meaning that it is going to reverse the string to be like this, as you see here. So the original string is like this, and when I'm having the my string colon -1 in the square bracket, it is going to have the reverse of my original string. So using this user string and this colon -1, I am reversing the string and assigning my reversed string in a variable called a reversed string. Okay, and then here I am printing out the message saying that the reversed string is, and I'm calling this reverse string variable. This could be x, for example. For the sake of simplicity, I can call it x. So this x variable is holding the reverse of the input a string entered by the user, and then we are printing out this here. So when I run this code, it shows the message, welcome to the string reversal program. So this line is being executed, and it is saying that enter a string to reverse. So first this line is printed out, and now this line is being executed saying that enter a string to reverse. So I would say Reza Shahin, this is my string. So when I enter, it is going to reverse my string exactly as it is. So it says that the reverse string is this. So the output is this. So when I entered Reza Shahin string here, it stored my string using input function and assigned it to the user string variable. And then this user string variable is reversed using this colon -1 code. Okay, and the result is being assigned to variable x, and now here I am printing out the variable x here, so you see the output, which is the reversed version of what I entered initially. Thank you for watching. Hello everyone, welcome back. In today's video we are going to learn how to add or update key value pairs in dictionaries in Python. So here is my dictionary. It is called person, and it has 3 keys: name, age, and city, and it has 3 values: Alice, 25, and New York. So when I print this dictionary in the output in the terminal, we see that all the data of the dictionary is being printed. So name Alice, age 25, and city New York. If we want to add a key value pair to our already existing dictionary, we type down the name of the dictionary first, and then we are going to use square brackets, and in the square brackets in quotes we can simply type down the new key that we would like to add to our dictionary. And then the left hand side equals to the right hand side, and the right hand side represents the value that is associated to this key for this dictionary. So if I now again print the dictionary person, we need to see the updated dictionary. So up until here everything is the same, but as you see, email is being added here, and also the email address is written on the right hand side. So it means that somehow like this is being written in the dictionary now when we are having the adding of the new key value pair. So when we are having this, it means that a new key is being written here, and a new value associated to this key that was just declared is also existing there. So in order to do that, I am going to review now. We type down the name of the dictionary. In the square bracket, we are typing down the name of the new key. And on the right hand side, we are typing down the value that is going to be associated to this key that we are declaring now. Then if we want to update our dictionary, for example, one element, one value of an existing key, we can have this code here. So when I run this code, we are seeing the, sorry, I need to print the output. So when I run the last line, the last modification of the code, and I run the code again, we see here I'm typing down the name of the dictionary, which is person. And here I'm typing down an already existing key in my dictionary, which is age. So when an already existing key name is mentioned here, it means that I'm trying to update the value that is associated to that key. So when age already existing there, it means that I would like to modify this age. So age was already 25, but now I would like to update it and make it 26. Then when I print the dictionary, we see in the output, the age is now 26 and not 25 anymore. Okay? So in this lecture, we learned how to add a new key and its associated value to an existing dictionary. And also, we learned how to modify an existing key's value in a dictionary in Python. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to remove items in a dictionary. Here is my dictionary called person. It has 4 keys and 4 values: name, age, city, email, and Alice 25, New York, Alice at example.com. And we would like to remove this key and its associated value from our dictionary. To do that, I use the del keyword. Then I type down the name of my dictionary. Then I have open bracket. Then in the bracket, I type down the name of the key that I would like to remove, and then I close the bracket here. When I print my dictionary here and I run the code, we see name Alice, so the first key and its value is there. We see age and 25, it's here, and then we see email and the email address here, and we see there is no print in the output of the city and the New York. It means that using the del keyword, we accessed the person dictionary to remove the city key and its associated value. So basically, this is how we can remove items from our dictionary. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to iterate through a dictionary. So this is our dictionary called person. It has 3 keys: name, age, and city, and 3 values: Alice, 25, and New York. And we would like to iterate through this dictionary. To do that, we need a for loop, and we are going to use the for keyword here. Then I'm having 2 iterating variables here, one named key, one named value. I'm just choosing the name myself, so because I think it's easier to understand it when I'm typing down key and value. So one of the iterating value variables that is called key is going to iterate over name, age, and city, and the value is going to iterate over the associated data to the associated value or data to these keys here. So this value iterating variable is going to take Alice, 25, and New York. When we are typing down the for loop, we know that we need to use the for keyword, and it means that for each key and value in the person dictionary, and we need to have the dot items in empty parentheses, it means that we are calling the items function to go through the items of these dictionary that we are having here. And then in the for loop, in each iteration, we are going to print out the key and value. So when I run this code, I see name, Alice, age 25, city, New York. Basically, in the first iteration, key equals name and value equals Alice. So this is why we see name and Alice in the first iteration. In the second iteration, key equals age, value equals 25. And in the third iteration, key equals city, value equals New York. So this is why we see name Alice, age 25, and city New York. So in the first iteration, key equals name, value equals Alice, and we are printing out key, then value. So key is name and value equals Alice. In the second iteration, key equals age and value equals 25. We are having age and 25. And in the last iteration, key equals city and value equals New York. This is why we see city and New York in the output. So this is how we can use a for loop to iterate through a dictionary in Python. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that creates a dictionary with information about a person, name, age, and city, and prints each key value pair. We're declaring a dictionary called person. The name is John, the age is 30, and the city is Los Angeles. Then, in order to print each key value pair, we need a for loop. And we need two iterating variables, key and value, for each key and value in the person dictionary, and we use the items function with empty parentheses to iterate over the items of our dictionary one by one, and then we're going to print key and value in each iteration. So we see name John, age 30, and city Los Angeles. So in the first iteration, key equals name while value equals John. In the second iteration, key equals age, value equals 30. In the third iteration, key equals city, value equals Los Angeles. So in the first iteration, key equals name and value equals John. This is why when we are printing key and value, we see name John. Then in the second iteration, key equals age and value equals 30. This is why we see age 30. And in the third iteration, key equals city and value equals Los Angeles. This is why we see this part in the output. Thank you for watching. Hello everyone, welcome back. We would like to write a program that adds a new key value pair to an existing dictionary and prints the updated dictionary. Here I'm having a dictionary called student. It has two keys, name and grade, and two values, Emma and A. In order to add a new key value pair, we learned that we can type down the name of the dictionary, and then in brackets we type down the name of the new key, and then on the right hand side we type down the associated value. This is how we can add a new key value pair to an existing dictionary for a student. The name of the dictionary, the name of the key, and the value on the right hand side. Then we are going to print the student dictionary. So when I run this code, I see name Emma, which was there already. I see grade A, which was there already. and we see subject math, which is something that we added here. So the subject and math. So our new dictionary looks like this now. Subject, then it's having the math as its associated value. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that removes a key value pair from a dictionary and prints the updated dictionary. I'm having a dictionary called car. It has three keys: brand, model, and year, and it has three values: Toyota, Corolla, 2020. If we want to remove one key value per from this existing dictionary, we use the del keyword, then we type down the name of the dictionary, and in the brackets, we're going to type down the name of the key that we would like to be removed from this dictionary. So after that, I'm trying to print the dictionary here. So when I run this code, I'm having brand Toyota, model Corolla, and year 2020. When I delete this key, the associated value to this key is going to be removed as well automatically. So when I print my car dictionary, I see brand Toyota here, and then I see year 2020 here. So I see no information about the model Corolla in the output after having uh, the model keyword and its associated value being removed using the del keyword in Python. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to program that checks if a specific key exists in a dictionary. I'm having a dictionary called colors. It has three keys: red, blue, and green, and it has three associated value. And in this program, we would like to check and see if one key called blue is existing in our dictionary or not. Is it there or not? Does this blue key exist in our color dictionary or not? So to check that, I'm typing down one if conditions. So I type down if, then the string blue because I'm looking for blue, in the colors, in colors, so colors is the name of my dictionary, print the color blue is in the dictionary. Else means otherwise, print the color blue is not in the dictionary. So I'm going to say it one more time. We check with if condition if this string in the colors. So colors is the name of my dictionary. So when I run this code, I see the output says that the color blue is in the dictionary. It means that we are having a key in this dictionary that is called blue. But if I type down, for example, here, yellow, it says the color. So the color, maybe you should also change this one and this one here, for example. So I rerun. It says the color yellow is not in the dictionary. So this message is being printed out in the output. Why? Because it checks and see yellow is not one of the keys declared in the color dictionary. This is why, because it cannot find it. It goes to the else part and it prints this message for us in the output. So this is how we can actually check to see if a specific key exists in a dictionary or not. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program that counts how many items are in a dictionary. I'm having a dictionary called fruits. It has three keys: apple, banana, and orange. And each of these keys are associated with one value. So for apple, we have value 3. For banana, we have value 5. And for orange, we have value 2. So we would like to count to see how many items are in a dictionary. In this dictionary, I'm having 3 items here. So 3 keys. By items, I mean 3 keys. So 3 keys are inside the fruits dictionary. But how can we count it in Python? We can use the len function, in fact, the len function. In the previous videos, we have already worked with this function. So we can use the len function to give us the number of keys that are inside this dictionary, but inside this function, we need to type down the name of our dictionary, which is fruits. So we are initializing a variable called count, and it is equal to the len function, and in parentheses we are having the name of the dictionary. So this function is going to calculate the number of items that are inside the fruits dictionary. Then I'm printing out the count for myself in the terminal. So I'm having this message: the dictionary has, and then the count variable is here, and then the items at the end of my message. So I'm printing out the dictionary has 3 items. So, and if we count it, we see that there are indeed 3 items inside this dictionary. So if we have a dictionary with a lot of keys, we can simply use the len function to do the job for us, to do the work for us, and we can easily understand how many keys are declared inside a dictionary. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to merge 2 dictionaries. I'm having dictionary number 1 and dictionary number 2. I would like to put the information of the second dictionary in the first dictionary. And we see that dictionary 1 and 2, they have one element in common, which is B. So the key B is shared between them. But in the first dictionary, it is associated with 2, and in the second dictionary, it is associated with number 3. I'm going to type down the name of my first dictionary dot update. So I'm using the update function, and in the parentheses, I type down the name of my second dictionary. And then I'm printing out the first dictionary in the output. When I print the first dictionary in the output, I expect to see this element in the dictionary 1 and these 2 elements in the dictionary 1 and not this one. Why? Because B is a common element, is a common key, let's say, between these 2 dictionaries, and we are updating the information of the first dictionary with the information of the second dictionary. Therefore, because they have one key in common, it is going to, this part is going to be replacing this part. Okay, so I expect to see A1, B3, and C4 in the output when I'm using this line of syntax and code. So the name of the first dictionary dot update using the update function, and in the parentheses I'm typing down the name of my second dictionary. So in the output, as you see here, I'm printing the first dictionary. I see A1, B3, and C4. So we don't see B2 in the output. Why? Because the information of the first dictionary is being updated, and the information of the second dictionary is being inserted in the first dictionary, and because they have one key in common, the key of the second dictionary is going to be in the place of the B key in the first dictionary. So we see this one in the first dictionary and this one in the first dictionary, and this one is going to replace this one here. And we have another method to merge 2 dictionaries as well. To do that, I'm having a new dictionary being declared called merged, and then I'm using braces, and in braces I'm having star star and the name of the dictionary 1, comma, star star, the name of the second dictionary. So this is going to do the same work as this line does. So it depends which one you find more convenient, and you can go ahead and choose it. So after that, I'm printing the merged dictionary, and as we see here, the output of the first method and second method, both of them are the same. The outputs are the same. So it depends on you which one that you prefer, you can go ahead with that. So this is the second method. So in this video, we learned how to merge or update dictionaries in Python. We can use this method, name of the first dictionary, then update function, and in parentheses, the name of the second dictionary, or we create a third dictionary. For example, in our case here, it is called merge. And in the braces, we type down star star the name of the first dictionary and comma and star star the name of the second dictionary. Then we are printing out this third dictionary that has been created, which is called merge in this case. And then we see the outputs are the same. Thank you for watching. Hello everyone. In this video, we're going to learn how to loop through keys, values, and items in a dictionary. Here I'm having a dictionary and it has 3 keys here, as you see: name, age, and city, and it has 3 values: John, 30, and New York. If we want to only iterate through the keys of this dictionary, we can type down the keyword for, and for each key in my dictionary dot keys. If I use the keys function, this is going to help me to only iterate through the keys of the dictionary, okay? Name, age, and city. Then for each iteration, I print key. So in the first iteration, key equals name. Second iteration, key equals age. And third iteration, key equals city. Okay? So in here in the code, I'm printing a loop through keys. Then I'm typing down my key variable here, which is my iterating variable for each key in my dictionary dot keys. Print this key for me. So in the first iteration, key equals name, second one age, and third one city. Here is how we can iterate over the keys in a dictionary. Then what if we would like to iterate over the values only, not the keys anymore? We are typing down this message for us, loop through values, and then I type down 4 values in my dictionary and then dot values in parentheses, in empty parentheses. So we are using the values function to iterate over values, and then in each iteration I'm printing the value in the output. So in the first iteration, value equals John. In the second, value equals 30. And in the third value, equals New York, as you see it here. So using values function in dictionaries, we are able to iterate through only values. And if we would like to iterate over key value pairs, we use the items keyword. So I'm typing down for any key and values in my dictionary dot items print key and value. So it is going to say name John, age 30 in the second iteration, and the third iteration city and New York. So when I run this code, in the output we see loop through keys, and only keys are being printed as we expected here: name, age, and city. Then we are having loop through values. So values are John, 30, and New York. John, 30, and New York, as we expected. And then loop through key value pairs. We see name John, age 30, in city New York, as we were expecting to see the same thing. So in this video, we learned how to loop through keys, values, and key value pair. Thank you for watching.